And welcome back to our new series called Computer Vision Hands-On. So in this particular series, actually, we'll be mostly working with this particular computer vision task, and it will be like mostly like practical side, because theoretical wise, actually, we already know, okay, like how we can let's what are the theory behind this particular image classification, object detection, and all. But when it comes to, like, let's say practical implementation, we usually face the difficulties. So in this particular series, actually, I'm going to cover all kinds of actually computer vision tasks here. So today, actually, we'll be showing the like image classification task we can perform with the help of TensorFlow. We'll be also learning about PyTorch and all, right? Then after that, we'll be also learning about object detection, image segmentation, object tracking. Okay, so these are the things we'll be covering one by one, and we'll be exploring all the different framework and tool. Okay, whatever actually you can see over the internet nowadays, and it is like most used tool in the industry also. We'll be also exploring everything. Okay, so this session, I think it will give you like broad idea about the practical implementation of these kinds of computer vision tasks. So make sure you attend regular basis, okay? And also try to practice with me. So whatever code, let's say I'm writing here, so you just also write with me and try to practice in your system. Then definitely things would be very much clear. And I will share all the resources, whatever things actually I'll be doing, and where you will get the resources and everything, I will also tell you. Okay, so before starting with the session, first of all, I just wanted to tell you, if you go to our iNeuron YouTube channel, so here you already see we have started this particular session. Okay, we have started this particular community series called this one. If I show you the playlist, I think playlist hasn't added yet. So what you can do, you can go to the live session, and this is the live session actually today is going on. And in the description section, you will see the course link. Okay, so here is the course link. So here's the course link. If you open this particular course link, so you will able to see this particular dashboard, okay, called Computer Vision Hands-On. Now here, what you have to do, you just need to enroll this particular course, and this is completely free. Okay, you can see this is completely free. You don't need to pay for anything. So once you enroll it, so you will get all the resources, all the materials inside this particular dashboard itself. Okay, so make sure you just create an account. And after that, so I already logged in with my account, so I'll just enroll this particular course. So I'll just click on enroll now. See guys, enrollment is successful for me. Now if I go to my courses, so this is my dashboard. Okay, so initially you won't be seeing anything because we haven't updated any kinds of resources and video, because today is the first session. Okay, so after the session, after the, let's say, discussion, you will get everything here, all the let's say assignment, quizzes, as well as the materials, whatever I'll be sharing. And you will also see the video link. Okay, so you can refer this particular dashboard. Okay, so make sure you just enroll this particular course, guys. After that, you will get all the resources and materials. Okay, so this is the basics of dashboard overview I have given. Now you just need to enroll it. Okay, so first of all, let me give you some idea about this particular series, actually what we are gonna do, and different tasks actually we are gonna perform. So let me just write down here. Okay, I think everything is fine. Okay, just a minute. All right. Okay, so we have started something called computer vision. Okay, computer vision hands-on series. Okay, hands-on series. So here we'll be like mainly focusing on the practical implementation. So first of all, we'll be starting with the image classification. Okay, image classification. Okay, so if you have already learned about, let's say, CNN, okay, convolutional neural network, CNN. So in CNN, you will see the first task actually you have to perform something called image classification. So you can either create your custom architecture, either you can use like pre-trained models. Okay, pre-trained models is also available, which is trained on this particular ImageNet dataset. Okay, ImageNet dataset. So this is like benchmark dataset. They have trained different model. Let's say we have VGG16. Okay, VGG16. We have Inception. Okay, Inception. Then we have ResNet. Okay, we have ResNet. Then we have MobileNet. Okay, we have MobileNet. Then we have DenseNet and so on. Okay, there are so many models you can use, and these are the pre-trained model. Okay, so this model is already trained with ImageNet dataset. So what I can do, I can like apply something called transfer learning, and I can download these at the model weights. Okay, on top of that, I can train my custom data. Let's say you are having a different dataset. Let's say you are having a dog cat dataset. Okay, dog and cat dataset. So basically, you want to also add this particular, let's say, label in your model so that your model can also predict, okay, whether it's a dog or whether it's a cat image. Okay, so for this, what you have to do, you will be picking up this particular base model. Okay, the model actually which is trained on ImageNet dataset. On top of that, you will be training your data. Okay, the dog cat data actually we are having, and that is called actually fine tuning of the model. Okay, so we are applying transfer learning because it is already known. We are just transferring the learning, okay, in the model itself. So this is called transfer learning. So we'll be following these are the approach only because nowadays nobody creates their custom architecture. If you're creating your custom architecture, so definitely you won't be getting good performance from the model, and you have to train like you can say lots of epoch, and you should have lots of data for this. Okay, but as a developer, we don't have that much of time. Okay, if you are going for the research purpose, at that time you can like work with this particular custom architecture. So let's say if you want to bring a architecture which would be better than, let's say, VG16, so at that time you can design your architecture, you can propose a paper on top of it. Okay, but again you have to use this ImageNet dataset. You have to use this particular ImageNet dataset to evaluate your model whether this model is performing okay better than the VG16 model or not. Okay, you have to prove that. Okay, for this you have to publish a paper. So that's why actually over the internet you will see people are coming up with a new let's say architecture. Okay, nowadays, and they're publishing a paper on top of it, and they're claiming that this model is performing better than this model. Okay, so that's how actually, if you are going for the research purpose, if you want to work with the custom architecture, you can use it. Otherwise, as a developer, what you have to do, you have to go with the pre-trained model, whatever model actually we are having. So we'll be downloading the weights of the model, and on top of that, we'll be training our custom data, and we'll be building the application on top of that. Okay, so this is the idea. Right. Now, the second task actually will be exploring called object detection. Okay, object detection. So this is like very used task actually over the industry, object detection. So if you see any company, those are working with this particular computer vision domain, so they will be working on this particular object detection task. Okay, so in object detection also you have so many, let's say, tools and technology, so many algorithms are there also. So we usually use something called faster RCNN, okay, SSD. So these are the model architecture we'll be using, okay, for the object detection task. I'll be also discussing these are the thing like what are the framework, okay, we can use, how we can get the, let's say, pre-trained model, okay, how we can train on top of our custom data, and how we can perform object detection in real time. Everything I'm going to discuss. Then after that, we'll be also discussing something called we'll be discussing object segmentation. Okay, object segmentation. So this is another very powerful application you can talk about in the field of computer vision, because currently actually I'm using one object segmentation, let's say, tool. Okay, because see, I'm using this particular let me show you. I'm using this particular NVIDIA broadcast. So here in the camera, actually, if you see, I have added my virtual background. Okay, in the camera, I have added my virtual background, but how it is applying this particular virtual background? Okay, because it is segmenting out. Okay, it is segmenting out me as a person and my chair, and rest of the thing it is removing. Okay, and there actually I can add this particular virtual let's say background. Okay, so this is one like one good application of this particular object segmentation, because it is segmenting out me and my chair, and rest of the thing it is removing. Okay, so that I can attach any kinds of image here. Okay, so there are so many like application you will find over the internet of this particular object segmentation, but this is like most used actually task. So this particular technology you are using with your Zoom, with your Google Meet, okay, any kinds of, let's say, video conference, let's say, platform you are using, everywhere you will see people are using object segmentation to segment out that particular object, that means the person and chair, and rest of the thing it is removing, okay, as a background, and you can attach any kinds of background with that. Got it? So we'll see like how we can perform object segmentation. And we'll also learning like how we'll be training our own object you can say segmentation model on top of our custom data with the help of this pre-trained model and all. Okay, and mostly we'll be using in the object segmentation mask RCNN model. Okay, mask RCNN model. Okay, and in object detection we'll be using faster RCNN and SSD, that means single shot detector. And in image classification, I'm going to use, these are the model VG16, Inception, ResNet, MobileNet. So if you can learn only one implementation, rest of the thing you will be implementing. I will tell you, I'll give you the guidance, okay, how to select different model. But in this particular video, I'm going to use something called VG16 model. Okay, VG16 model I'm going to use. Okay, yeah. Then after that, I'll be also discussing something called object tracking. Object tracking. What is object tracking? Object tracking means it will track the object. Let's say in object detection, we only can let's say detect the object. But when it comes to the real time tracking, okay, I think you have seen like there are so many organizations they're using this particular object tracking system. Let's say you have one big construction okay industry, so there are lots of trucks and let's say a vehicle is coming. Okay, so what they are doing, they're counting that the vehicle, like how many vehicles are coming, how many vehicles are like let's say moving. Okay, that's how they're making the count. But how they're making the count, they're tracking that particular object. Okay, real time they're tracking. Even nowadays in sports industry also people are using object tracking. They're tracking the player. Okay, they're tracking the ball. Okay, that's how they're performing. These are the tasks on top of it. So we'll be also learning how we can perform object tracking in real time. So for this actually I'm going to use something called deep sort. Okay, so deep sort is a object tracking algorithm, state of the art algorithm we'll be using. And for the object detection, I'll be using YOLO. Okay, YOLO V5 I'm going to use. So whenever you are performing object tracking, first of all, you have to detect that particular object. And after that, you have to track that particular object. Okay, for detection, you will be using YOLO V5. And for tracking, we'll be using deep sort. Okay, that's how actually we'll be covering. Yeah. Then I may also discuss about GANs. Okay, generative adversarial neural network. I think you know that. Generative adversarial network. So GANs. GANs I'll be also discussing. We'll be seeing like how we can generate like a new image, because nowadays like this is like very powerful application you are using in the field of image generation. So nowadays lots of LLM comes, right? Large language model comes also. With the help of that, you can generate an image with the help of prompt. If you give any kinds of prompt, it will generate the image for you. Okay, so we'll be also learning the mechanism behind GANs. Okay, how we can develop a GANs, our own GANs, and how we can use this particular GANs algorithm to do different tasks. Let's say you want to perform super resolution. Let's say you have one image which is like very less low resolution image. If you want to convert it to high resolution, you can use GANs. Okay, for this. So that's how actually there are so many GANs are available. Okay, you can use and I'll also like give some brief idea about this LLM, like how LLMs uses GANs and all. Okay, to generate these are the images and all, right? So yes, these are the tasks actually only available inside computer vision. Okay, if you know these are the tasks, I think it's enough for you. Okay, now you can perform any kinds of, let's say task, or you can solve any kinds of problem statement. Okay, in industry. Yeah. And apart from that, if you need anything, let's say you want to learn this particular technology, you can comment out in the description, or let's say you can comment out in the comment section, so that we I can look into it later on, and I may come up with that particular series also. Okay, so you can let me know. Yeah, because I was getting lots of queries related to this particular computer vision, whether we are having computer vision related job role or not in the market. So definitely there is a job role. But the thing is, like, you have to master these are the technology. Okay, these are the you have to master these are the tasks. And if you have some good projects, okay, on top of it, definitely you will get a job. Okay, because companies are also using computer vision, companies are also using NLP. Okay, they're also using machine learning, deep learning, everything they're using. Okay, it's not like that. Let's say currently generative AI came, all the companies are working on generative AI only. It's not like that. People are also working on computer vision because their company is related to computer vision only. Okay, so there are lots of, let's say, computer vision engineer would be hired. So definitely you should have a good profile, you should have a good skill set. Okay, definitely you will also get a job, right? Yeah. So yes guys, this is the complete agenda for the entire actually series actually we'll be covering. Okay, so today actually I'm going to perform this image segment image classification, okay, with the help of TensorFlow. And mostly tomorrow we'll be showing the PyTorch implementation as well, like how we can use PyTorch as well, because People are also telling like, sir, I know the TensorFlow implementation, but when it comes to the PyTorch implementation, so I get difficulties. Okay, so I also need to explore the PyTorch. So that's why I'm thinking to also show you the PyTorch implementation so that you can also use PyTorch apart from the TensorFlow. Okay, yeah. But what I feel like TensorFlow would be a little bit easy to implement because Keras has been integrated with TensorFlow right now. Okay, so that's why actually Keras has actually high level API, so you can like import all the functionality as a high level and you can perform these other jobs. But whenever I'm talking about PyTorch implementation, so there actually you have to write low level Python programming. Okay, so that's why some implementation actually will get difficulties. But again, I'll tell you, I'll give you the understanding, so things would be very much clear. But if you want to understand the PyTorch code, definitely you should have knowledge on this particular OOPS concept, okay, in Python, object-oriented programming. Okay, if you have this OOPS concept, so definitely you will understand the PyTorch implementation as well. Okay, yeah. Now, one question would be in your mind. So what is the difference between image classification, object detection, object segmentation, okay, and object tracking? So for this, I'll show you one particular image, so your understanding would be clear. So here I can write search about difference, okay, between object detection, image classification. So there is the image actually we'll get from the Google. So let's say I'll pick up this particular image. So let me just show you. Yeah, so this image actually I can take, I'll copy, and here I can paste on my board. Yeah, so here you can see we have three different images actually. The first image is telling it's an image classification problem statement. Okay, why it's image classification problem statement? Okay, if you see here in this particular image we have one particular object only, which is nothing but dog. Okay, now this image classification task will tell you whether this image is a dog image or it's a cat image. Let's say you are having one cat here. Okay, instead of dog, that time it will tell you it's a cat image. But whenever you are having dog image, at that time it will tell you it's a dog image. But you can't see it will detect that particular object. Okay, I can't see the detection. But whenever I'm talking about, let's say both, okay, cat and dog in the same image. Okay, so what will happen actually at that time? If you're using image classification, it will fail because it can see actually both images are present in that particular image. Okay, so that's why it will fail that time. So that's why actually instead of applying image classification, we perform something called object detection. So object detection, what it will do, it will detect that particular object. Let's say this is a cat, okay, and this is a dog. That's how it will detect separately. Okay, it will detect separately, this is a cat, okay, and this is a dog image. Okay, so this is called object detection because it is localizing that particular object in that particular image. Okay, then there is another task called image segmentation. Okay, as I already told you, it will segment out that particular object and rest of the thing, okay, it will remove. You can either remove, you can either keep, it's up to you. But the thing is like it will mask. Okay, it will mask on top of this particular object, as you can see. Okay, it has applied this masking. Okay, it has applied this particular masking. Okay, this is called mask. So you have to also apply this masking, and after masking actually you can segment out that particular object. Okay, so this is called image segmentation task. Okay, and what is object tracking? Object tracking is nothing but you will detect that particular object. After that you will track. Let's say this dog is moving. Okay, this dog is moving. Let's say this is the position 1. Okay, this is the position 2, this is the position 3. Initially let's say this dog 1 on the position 1, so you have to track this dog here. Let's say whenever this dog will move in the position 2, okay, again you have to track this particular dog. Let's say this dog will move in the position 3, okay, you have to track this particular dog. So this is called object tracking. Basically you are tracking real time. Okay, you are tracking real time of this particular object, so we call it as object tracking. Okay, so these are the difference between image classification, then our object detection, image segmentation, and object tracking. Okay, and I think you already know about GANs. Okay, that means generative adversarial neural network. We can generate like you can say new data with the help of GANs. That means we can generate an image. Okay, nowadays actually diffusion model is there also, so it is like very powerful model. With the help of diffusion model also you can generate an image and all, right? Yeah, so this is the like idea of the entire series. Actually, I hope you got it. Now we'll be starting with the implementation because this is a hands-on series. Actually, I'm not going to discuss about the theory, how this image classification how this like CNN works and all, right? So for this I'm expecting you already have the basics idea about image classification. Okay, this convolutional neural network and all. Okay, then you will be able to understand this particular practical series. Okay, yeah. So for this actually what I'm going to do, I'm going to open up my Google Drive. Okay, so you can open up your Google Drive and you can create a folder. So I have created a folder called YouTube Live and CV hands-on. Okay, so here what I will do, I'm going to create a Google Colab. Okay, so let me create a Google collaborative. So in the Google Colab, actually we'll be performing all the codes. Okay, so let's name this particular notebook as image classification. Okay, image classification using TensorFlow. Okay, so TensorFlow is a like framework, deep learning framework. I think you already know about TensorFlow. So it has implemented by Google team. So TensorFlow, TensorFlow. Okay, so this is the official like website of the TensorFlow. So we'll be using this particular TensorFlow API. So here actually we'll get Keras integrated. Okay, previously Keras was a separate actually framework, but they have collaborated together. They have integrated this particular Keras with the TensorFlow. Okay, now I can access like Keras from the TensorFlow itself. Okay, and with the help of this particular TensorFlow, we can do all kinds of tasks. Actually, you can perform image classification, object detection, okay, object tracking, anything you can perform. But we'll be exploring different tools and technology, because we won't be relying on one particular tools and technology, because in the industry people are exploring all kinds of technology, all kinds of framework. Okay, so you should also have the idea on top of it. So you can go with the documentation, like how to install this TensorFlow and all, everything they have given the guidance and all. If you're using local system or whether you are using Google Colab and all, let's say if you are using Linux, Windows, okay, Mac OS, anything you can use, and you can see the guideline of the installation. Okay, but whenever I'm talking about, let's say, Google Colab, so by default actually TensorFlow comes with like installation here, so you don't need to install separately. Okay, so if you want to test it, so first of all, what you have to do, just select the runtime as GPU. So let me select the runtime as GPU, because here I'm going to train my model. So definitely you should have GPU configuration machine. Okay, otherwise if you're using CPU, so it would be very you can say slow training. Okay, but I don't want that. So if you're using like free Colab, so you will get this particular like T4 GPU. Okay, T4 GPU is there. But if you're using paid Colab, so you will be getting this A100 GPU and V100 GPU. Okay, so I'm using this Colab Pro, so that's why I have this particular premium GPU. But if you're using free Colab, you can use this particular GPU called T4 GPU. Okay, it's completely fine. With the help of T4 GPU, also you can perform the training. Okay, now I have my Pro access, so I'll be going with this particular V100 GPU. Okay, I'll also select the higher RAM and I'll save the instance. Then after that, I'll just connect this particular notebook. So once it is connected, I'll import this particular TensorFlow here. Then I can start the further implementation. Okay, so they have already written, give you the guidance and all, GPU device plugin and all, everything you can refer from here. Okay, now it is connected. Now what I will do, first of all, I will check whether I am having this particular TensorFlow integrated or not. But before that, if you want to test the GPU, whether it has integrated GPU or not, you can execute this particular command. So let me zoom this particular screen a little bit. So you can write NVIDIA, okay, NVIDIA -SMI. So this is the command to check the GPU instance, whether you are having GPU or not. So see guys, here I got Tesla V100 GPU and it is having a 16 GB VRAM, okay, because it's a premium GPU. But if you're using T4, it will have, I think, 12 GB VRAM, okay, mostly. I don't know. Yeah. Okay, now let's import TensorFlow and see whether I'm able to import or not. So here I'm going to write import TensorFlow. Okay, TensorFlow as TF. Okay, so you can give a nickname of this particular TensorFlow, because every time you don't need to call this TensorFlow name, you can name it as TF. Okay, TF means TensorFlow. Now if I execute, so it should import my TensorFlow because it is already installed in my Google Colab. But if you're using in your local Jupyter Notebook or VS Code, you have to install it. Okay, and installation guideline you will get from the documentation itself. Got it? Now see guys, execution is done. There is no error. That means I'm able to import this particular TensorFlow. Now if you want to check the version, okay, version of the TensorFlow, you can just write tf dot hyphen version. Okay, hyphen. So if I execute now it will show me the version. Okay, so currently TensorFlow actually is like 2.15.0. Okay, this is the current version. If you want to verify, you can go to the PyPy. So TensorFlow PyPy. Okay, so PyPy having all the hosted package. So TensorFlow is also there. Now if I go to the release history, okay, so 16.1, but in Google Colab it is installed 15.0. Okay, no issue. You can either install 16.1. Okay, this is the current, and the release date is March 9, 2024. Okay, but I'm using 15.0. I think I'm using 15.0. So 15.0 is there. The release date was like November 15, 2023. Okay, so if you want to, let's say, install this particular TensorFlow, just click here. This is the command you need to execute. Okay, in the Google Colab. Okay, in the Google Colab, you have to execute this particular command. Then you will be able to install this particular 2.16.1 version. But I won't be recommended, because whenever they comes with, let's say, the latest version of the package, so definitely some issue would be there. So I'll suggest go with the previous version, because in the previous version it is already stable version, people are already using, so you won't be getting any kind of difficulty level. Okay, yeah, so that's how actually we can check the version, okay, of the TensorFlow. Even you can also check the version of the Keras. So here I can just write from TensorFlow, okay, import Keras, because Keras is already having inside TensorFlow, so I can import Keras. Now if you want to check the Keras version, just write Keras, okay, dot hyphen version hyphen. Okay, you can also check the Keras version. Okay, so Keras 2. Has not debuted version, so let me check how to check the version of the Keras. So maybe I will get the code of the Keras. Just a minute. TensorFlow. Yeah, so this is the code, I think. Now I will go back, and here I'm going to replace. So TF. So I don't need to import it, I think. Can remove it. Now I think this will give me the Keras version. Okay, so I'm not getting. Let me check. To print the Keras version, import Keras. To print the TF version, import TF. Okay. Let me go to the Stack Overflow and see that. Yeah, you can also directly import Keras. It is also possible. So let me show you. So here I can write import Keras. Okay, now we can check the Keras version as well, because again it is coming from TensorFlow itself. So no need to import. So here I can write Keras dot hyphen version hyphen. Now see guys, it is also 2.15.0, because it is using 2.15.0 this particular TensorFlow version. Okay, that's how you can check different version. Okay. Now let me show you the data set actually I'm going to use for this particular image classification task. So this is a simple data set, guys. This is a dogcat data set I'm having. So that's how actually you have to prepare the folder. So in the data folder, you have to create two folder. One is like training, okay, another is like validation. Okay, as you can see, another is like validation. So inside training, I kept my training images. So first of all, you have to create a folder called dog. Inside that, you will be keeping all the dog images. Okay, see, these are my dog images, and I'm having 168 dog images here. Okay, it's like very less images for the training, but this is a live session. I just need to show you the training. That's why I kept less images. But if you want to train a good model, so definitely you should have use lots of data here. And where you will get this particular data? This data set is available in the Kaggle. Okay, if you just go to the kaggle.com, you can search about dogcat data, Kaggle. Okay, so Kaggle is having lots of repository, so you can download the data from there only. Okay, so let me show you. See, dog versus cat data are available, and here is the data, guys. So if I click on the data, and here you can download. See, here you can download this particular data, and it's around 853 MB, because it is having like lots of images. Okay, so you can download this particular data if you want to train a good model. Okay, but what I did, I just kept some of the images here. Okay, in the training, that means in the dog folder, as well as in the cat folder. Okay, these are the cat images, as you can see. Okay, now similar wise, in the validation folder, I created dog and cat folder. Okay, and inside that I kept my dog image, and I kept my cat image. Okay, so that's actually you have to provide the label. Okay, you have to provide the label of the model. Okay, so what is happening here? So let's say here I created the folder like that. So first of all, I'm having one data folder. Okay, I'm having one data folder. Okay, now in this particular data folder, what I'm having? Okay, I'm having two folder. One is like train. Okay, another is like validation. Okay, so inside train. Okay, inside train. So here I can. Yeah. So just a minute. I think I can write like that. It would be good. Yeah. Inside train, I'm having two folder called dog, and another is like cat. Okay, cat. And inside that I'm having the images. Okay, all the images inside that I'm having all the images. Okay, images. Okay, then I have another folder called valid. That means validation. Okay, inside validation also I'm having two different folder called dog and cat. Okay, and inside that I have my images. Okay, so what is happening actually? So whenever, let's say this is my model. Okay, this is my model. So whenever you are giving this particular image as an input, let's say this image will go as an input. Okay, and how your model will get to know, okay, whether it's a dog image, because see, you have already given the folder name. Okay, it will take this particular folder name as the label. Okay, it will take the folder name as the label. So that means this is the y, this is the y. Okay, y, that means this is my x, image is my x, and what is y? Y is the folder name. That means x is my input and y is my output. That means this is my label. Okay, so x is the image. Okay, y is the label. Okay, label of that particular image. So this image is nothing but it's a dog image. That's how actually whenever you are giving cat image also, you are also giving the folder name. Okay, so this is a cat image. Okay, this is also y. So that's how actually it is picking up the label. Okay, it is picking up the label and it's trying to understand, okay, whether it's a dog image or whether it's a cat image, because again it's a supervised learning technique. Okay, you have to give the label of that particular image, and that's how actually we provide the label. Okay, in image classification. So we don't do the annotation here, we just create a separate folder. So let's say let's say you have 5 different, let's say, object. Okay, you have 5 different images. Let's say you also have frog image. Okay, so what you will do here, you will be creating another folder called frog. Okay, frog. So inside that you will be keeping the frog images. Okay, so this is the idea only. Okay, that's how you can add so many label. Okay, as many label you can add here, you can add here. Okay, but I'm using only 2 label. One is like dog, another is like cat. Okay, so that's how you have to prepare the folder structure, and it will automatically pick up the folder name as the label. Okay, you have to remember in that way. All right, so this is the data structure, guys. So this data, now what I have to do, I have to upload in my Google Drive, because from the Google Drive itself I'll be reading my data. Okay, so what I can do, I can upload it quickly in my Google Drive. So I'll go to my Google Drive, and here I'll open it and I'll upload this particular data here. Okay, and I will mount my Google Drive with my this one, Google Colab. Then I can access this particular data from here. Okay, I think it has uploaded. Now you can see here. Now what I have to do, I have to mount my Google Drive. Okay, so how to mount the Google Drive? So left hand side you will see the folder icon. Just click here, and after that you just need to click the third option called mount drive. Okay, if you just click on the mount drive, so it will connect with your Google Drive. Okay, now see, it is mounting. So now let's connect. Now here you have to provide the account. So it will automatically mount. Okay, you don't need to provide the account if you have opened from the Google Drive itself. Let me change the view so that you can see everything here. Yeah. Okay, I think mount is done. Now if I cancel, now if I refresh, so I'll see the drive option. Okay, see, drive is there. That means I am connected with my Google Drive. Okay, now I will go to the folder. Okay, the folder actually I'm having my data. That means this particular folder location. So how to go? Just click on the drive, go to my drive. So I'm having so many files and folder in my Google Drive. That's why it will take some time. But if you have less files, so it will take less time. Okay, now see, this is my name. Inside that I'm having my YouTube live. Okay, so my classes, and here is the YouTube live. In the YouTube live folder, I'm having this CV hands-on. Okay, that means this particular folder. Now I'm inside this particular folder, CV hands-on. Okay, now I'll copy this particular folder location, copy path, and here I'm going to mention. Here I'm going to just write CD. That means change directory. Okay, change directory to this particular location. Okay, I want to go inside this particular location. Okay, that means currently if I show you my PWD, that means project working directory. So if I just write PWD, so I'm inside content. That means I'm inside my Google, this one, Google Colab. Okay, Google Colab, let's say path. But I want to go inside this particular location in my Google Drive. So for this, I need to change the directory. So this is the command. You just need to write CD, and you need to give the path of that particular folder. Okay, so this is the path you just need to copy, and here you have to paste. Okay, then once it's done, if I execute, now I will be able to see I'm inside this particular location. Now if I again copy this particular command and run it here, now you see I'm inside this particular location. Okay, I'm inside this particular location. Now I can minimize this particular screen. Okay, yeah. Now whatever content actually I'm having, I can also list down. So here I can write ls command to list down everything. See, I'm having this cat.zip. Okay, if I show you, this cat.zip is there, and I'm also having this particular notebook. Okay, IP1B file. Now what I have to do, I have to unzip this particular data. Okay, because inside that I'm having my data, right? So I have to unzip this particular like zip file. So to unzip that particular zip file, you just need to write one command called unzip. Okay, unzip, and you just need to give the name of this particular zip file. I'll copy this particular name, and here I need to paste it. Now if I perform the unzip operation, so it will unzip. See, unzip is going on. Yeah, unzip is done. Now if I go to my Google Drive and refresh the page, now you'll be able to see that yeah, this thing. So training folder is there. Now it will take some time to load all the folders and like you can say file. So please wait. Now again, if I perform ls operation here, I'll be able to see everything is created or not. Yeah, train and validation has came. Okay, that means I got all the folders. Okay, that means whatever folder I'm having in that particular zip file. Okay, now everything is came, right? See, this is my training image. Okay, inside that I'm having my cat and dog image, and I also having my validation image. Okay, now what I have to do, I have to import some of the library. Okay, to start with my image classification. Okay, so first of all, I need let me just import all the library one by one. Just a minute. Yeah. Okay. So first of all, I need something called these are the library. So from TensorFlow. Okay. Dot keras, because I'm going to use keras. Okay, keras dot layers. I need some of the layers. Okay, layers, because what will happen actually, I'm going to download that particular pre-trained model, and at the last layer actually I'm going to add my custom layer. Okay, that's why I need this particular layer. Okay, I'll be using layer. So layers, I'm going to import first of all input layers. Okay, then I'm going to use also lambda. Then I'm also going to use dense layer. Okay, then I'm also going to use something called flatten layer. Okay, then I also need my model object. So for this actually I'm going to again write from TensorFlow. Okay, TensorFlow dot keras. Okay, dot models, and import. I'm going to import this particular model object. Okay, model object, because I'm going to create my model. Okay, with my custom layer I will be adding. I'll tell you this part whenever I will be downloading that particular pre-trained model. Okay, then whenever I'll be adding the custom layer, at that time I'll tell you what is happening. Okay, then I also need something called the model. Actually I'm going to use here. So the model name is VG16. Okay, so this model is also already available inside keras application. Okay, let me show you. If you search keras application on Google, so you'll be able to see this particular page. Okay, now here I'm having this particular model called VG16. Okay, not only VG16, you are having different model. Let's say exception model, VGC19, ResNet 50, ResNet 50 V2. Okay, MobileNet, DenseNet, EfficientNet. Okay, then CompNet large. So you are having different model with different size. Okay, as you can see, different size, and these are the accuracy of the model. Let's say you want let's say quick inference, okay, from the model. At that time you can go with a smaller model, because smaller model will have lesser parameter, okay, and you will get the quick inference. That means quick prediction. It will take less time to do the prediction, okay. But let's say you want higher accuracy, but you are not worrying about the speed. At that time what you can do, you can go with the bigger model, okay. You can see bigger model, whenever you will take, the size will increase, even the parameter size also will increase in the bigger model, okay. And this is the time of the inference, okay, on the CPU and the GPU as well. So based on the time, actually, okay, you can, and this is in millisecond, okay. Based on the time, actually, you can select the model. Let's say you need faster speed, at that time go with the smaller model, and whenever you need, let's say a higher accuracy, at the time go with the let's say higher speed model, that means the bigger model, okay. That's how you have to select the model. But in this particular problem statement, I'm going to use VJ16 model, and this is the size of the model. This is the top accuracy, okay. That means this is the accuracy they have trained on the ImageNet dataset. This is the benchmark accuracy they got, okay. And this is the parameter size, okay. This is the depth, that means it is having 16 layer, okay, 16 let's say convolutional layer in this particular model, okay. And this is the time execution on the CPU machine, and this is the time execution on the GPU machine, okay. 4.2 millisecond. Got it? That's how you can select the model. Now if you want to load this particular model, just click here, and here is the code snippet, okay. You can use this particular code snippet to load this particular model, okay. Now let's load this particular model, and this model takes input size is equal to 224 3. This should be the image input, okay. 224 3. Okay, now you can tell me, I am having the image, okay, it is not 224 3, okay. If I show you the image resolution, it is less than, or let's say bigger than your 224. No need to worry. If you are using TensorFlow Keras, it will automatically take care. These are the let's say image resolution and all, okay. Let me show you the properties. Now if I go to the details, now see guys, this is the resolution of the image, okay. Now it is more than 224 3, okay. Now what I have to do, I have to resize this particular image with respect to my model input. For this, I'm going to use some Keras preprocessing function, and I'll be doing, okay. Let me I'll show you this part. First of all, let me load this particular model. So let me load this particular model. So I'm going to open up my notebook. Now here I'm going to just write from TensorFlow. Then you have something called Keras, okay. Then you have something called application, okay, because it is available inside application. I already showed you. And here you have something called VGZ model, okay, VGZ16, okay. Now you need to import this particular VGZ16. Just write VGZ16, okay, this particular model. So now I'm importing this particular VG16 model, okay. Now let's see if you want to use any other model, okay. Just go to the model. Let's say I want to load this particular ResNet 50 model. I'll go. Only you just need to change this particular object, okay, ResNet 50 object. Now if I show you here, okay, so here you will be writing something called ResNet, okay, and here you will be using this particular object called ResNet 50, okay, ResNet 50, okay, and here you also need to use ResNet 50, okay. That's how you'll be loading, okay. But I'm going to load VG16 model, okay. That's how I'll be loading, okay. Then after that, I need some Keras preprocessing function, so I'm going to also import. So from TensorFlow, okay, TensorFlow dot Keras, okay, dot preprocessing, okay. I'm going to import image, because with the help of this image, actually I'm going to perform the preprocessing image. Then I also need something called image generator, okay, from the image. So what I can do, I can copy this particular statement, and here I can write dot image, okay, and I'm going to import image generator, okay, image data generator, and I also need something called load image method, okay. So this thing I need. Then I also need to import something called sequential layer, okay. So I'm going to call this particular things TensorFlow models, okay, and I'm going to import sequential, okay. Then I also need NumPy, so from import NumPy as np, okay. Then I also need something called globe, okay. So from globe. So these are the required library I need, okay, for my project, okay. So that's why I'm importing everything all together, globe, okay. So whenever I'll be discussing, okay, why I'm using globe, why I'm using sequential, okay, why am I using this particular load image, I'll be explaining later on. So these are the library I need to import. Okay, now let's import these at the library. Okay, so now it has successfully imported. Now what I have to do, I have to define my image size. Okay, I have to define my image size. So the image size, I think you saw, it should be 224 comma 3. Okay, but by default I'm using RGB images. Okay, as you can see, I'm using color images. Okay, and color images having 3 channel. Okay, that means green, blue and red. Okay, 3 channel it will have. If I show you, so whenever you are using grayscale image, okay, grayscale image, in the grayscale image we will have only one channel. Okay, only one channel you will be having. Okay, this is the height. Okay, this is the height, this is the width. Okay, this is the width, and depth is like one. Okay, only one depth you are having. But whenever I'm talking about color image, okay, color image, so here you are having 3 different channel. Okay, so one is like, first of all, red, green, blue. So red, then you have something called green, okay, or I can create like that, red, green, okay, and blue. Okay, so this is red, this is green, and this is blue. Okay, now this is the height and this is the width. Okay, and this is the depth. Okay, you can see this particular thing is my depth. Okay, depth, and depth is like 3. So 1, 2 and 3 depth. Okay, this is called RGB image. Okay, that means color image. So we already know like our channel is 3. Okay, we don't need to mention the channel here because this is a color image. I only need to mention the height and width of the image. Okay, and the height of the image, width of the image I already got to know. I'm using the VG16 model, and VG16 takes actually 224 comma 3 here in the description, in the argument input shape. Okay, it should be 224 comma 3. So let me set this particular parameter. So I'll open up my notebook, and here I'm going to write image size. Okay, image size, image underscore size. Okay, it should be equal to 224 comma 3. So let me just mention 224 okay, 224 comma 3. I don't need to mention because this is a colored image. Okay, I already know. Then I also need to mention my training image path. So train image. Okay, train path is equal to, so here I need to give my path of the training image. Okay, so now if I do the ls, is you can see here, so this is my training image path. My training image is present inside this particular train, okay, train folder. So now let's copy the name. So this is the training image path. Okay, then I also need to mention my validation image. Okay, so let me copy, and here I can write my val path. Okay, valid image path. So it should be inside the validation folder. Okay, now let me define these are the variable. Okay, now I need to download the VG16 model. Okay, from the Keras application. As you can see, this model weight I have to download. How to download this particular model, the base model? So for this, just call this particular VG16. The VG16 we have imported here. I'll call this particular VG16. Okay, and inside that, first of all, you have to define the input shape. Okay, input shape, because it will take some of the arguments. As you can see, it will take the input shape, then weights. Okay, then it will also take classes. So these are the parameters it will take one by one, but you don't need to pass all the parameters. Some of the parameters you have to pass here. So first of all, you have to give the input shape. So let me give the input shape, input underscore shape. Okay, input shape is equal to this is the image size I can take from here. So image size, okay, plus I can add 3 dimension with that. Okay, because what will happen, so let me show you. So if I add 3 here, it will give me that 224 comma 3. See, 224 comma 3. Okay, that's how actually I'm providing 224 comma 3. Okay, that's how I'm giving this particular image size. Okay, now here what will happen, I got my image size, that is input shape. Then I also need to mention the weight. Okay, weight is equal to, I want to download the image net weight. Okay, that means the pretrained model. If you want to download the pretrained model, you have to give the image net weight. Okay, image net weight. Okay, then after that, you have to write another parameter called include. Okay, include top underscore top is equal to false. Okay, you have to make it as false. Okay, why you have to make it as false? Let me discuss. Okay, so include. Okay, it should be false. It should be false. Yeah, I think it's fine. Now, if I execute, but before that, I need to also store this particular object in a variable. I'll just name it as VGG16 object. Okay, it's a VGG16 object. Now let me download. Now see, this model is downloading from this particular URL. Okay, now see, it's downloaded. Now let me comment out everything. So here I imported the library. Import package. Okay, then after that, I set constant. Okay, then I downloaded the model. Download VGG pre-10 model. Okay, pre-10 model. Okay, yeah. Now what is happening? So let me show you why I've given this include top is equal to false and how it is getting downloaded. Okay, so if I show you the VGG16 architecture, okay, VGG16, okay, architecture. So it is having 16 layer. Okay, let me show you. So it is having 16 layers. So for this, I'll take this particular image. Okay, I'll take this particular image. So I'll copy, and here I'm going to paste it. Okay, so this is the VG16 architecture. Okay, now here if you see, it is having 16 layer. Okay, so here is the 16 layer. Let me take a color. So you can see here, it is having 16 layer. 16 layer. Okay, so this is called actually conv layer. Okay, conv layer. Conv layer. That means convolutional layer. Okay, with the pooling and everything, we call it as conv layer. Okay, but you can see here there is another layer actually I'm having called dense layer. This is called dense layer. Okay, that means your NN, that means artificial neural network. Okay, this layer actually called artificial neural network. We are calling it as a dense layer, and this layer actually we call it as conv layer. Okay, but whenever we download this particular model, okay, whenever we download this particular model, so by default this model is already trained with ImageNet dataset. Okay, ImageNet dataset, and ImageNet is having, like, let's say if I show you the ImageNet data, ImageNet, okay, ImageNet data classes. Okay, ImageNet data classes. So it is having 1000 classes. Okay, see, 1000 classes. ImageNet is having 1000 classes. Okay, 1000 classes in that particular data. Let me show you. See, these are the 1000 example it is having. Okay, 1000. See, it has chicken, then it has a vehicle. Okay, so these are the 1000s labeled. Actually, they have trained with this particular model. But in this particular example, okay, in this particular project actually we are doing, we are only having two label. Okay, two label we are having, two label. Okay, one is like dog and this is like cat, but I can't use this particular last layer because it is having 1000. Okay, 1000 label. Okay, so what I have to do, I have to remove this particular last layer. Okay, I have to remove this particular last layer called dense layer. Okay, so if you want to remove it, so you have to write this particular statement called include top is equal to false. That's why, that means I'm telling to my model the top. Okay, the top actually layer actually you are having, which is nothing but dense layer. Okay, just try to remove it. Okay, that means false. Just try to make it as false. That means I don't want this particular layer. I only need this particular conv layer because it will have the pre-10 weights. Okay, it will have the pre-10 weights, and if I have this particular weights, okay, I can easily train my model. Okay, now what I will do at the last layer, okay, at the last layer, instead of taking this particular dense layer, I'll be adding my custom dense layer here. I'll be adding my custom dense layer. Okay, so here I will add my custom dense layer, and here I will specify I'm having only two label. Okay, I'm having only two label in the last layer. Okay, so this is the idea. So whenever I will train my model, it will only train the last layer. Okay, last layer, and it will pick up your previous learning. That means this previous weight you are having in this particular conv layer. Okay, so this is the complete idea to do this transfer learning operation. That means you are getting one pre-10 weights, you are removing that particular last layer, that means the dense layer, and you are adding your custom dense layer with the help of your number of label actually you are having. Then you are training your model on top of it. Okay, so this is the complete idea. So that's why actually we have written this particular statement called include top is equal to false, and I want the weight of the ImageNet. Okay, yeah. Now what I have to do, I have downloaded the model. Now I have to freeze these are the weight, because I already told you I won't be training these are the weight of my conv layer. Okay, I have to freeze these are the weight. And if you want to freeze it, so what you have to write, so first of all you have to looping through all the weights. Okay, so here I can write for layers. Okay, for layer in VGG16 dot layers. Okay, VG16 dot layers. Now if I print all the layers, you will see it is having 16 layer. Okay, it is having 16 layer. All the 16 layer it will print one by one. See, it is having 16 layer. Okay, now I want to freeze them. Okay, that means I want to freeze all the weights. Okay, I don't want to train, only I will train the last layer. Okay, the custom layer actually I'll be adding. Now if you want to make it as freeze, so what you can do, I can copy this particular code snippet and here I can mention. Okay, so here you just need to make this layer. Okay, layer. Okay, layer. There is a attribute you will get called trainable. Okay, trainable is equal to false. Okay, you need to make it as false. That's it. Okay, you need to make it as false. Now if I execute, so it will freeze all the weight. Okay, now if you want to verify, so what you can do, you can copy the same for loop. Okay, and here you can write print. So layer. Okay, layer dot name. Okay, and layer. Okay, layer dot trainable. Trainable. Okay, now if I print, you will see all the layer has been false. Okay, all the layer has been become false. That means I have freeze all the weight. I have freeze all the weight. Okay, now we have successfully freeze the weight. Now what I have to do, if I go to the model summary right now, so that means VG16 dot summary. Okay, summary of the model. So this is the entire summary of the model, like how many trainable parameters it is having. Okay, what is the input shape and all, everything it will show you. See, these are the total parameter, and trainable parameter is equal to 0 because I have made all the parameter as false. That means I have freeze all the weight. Now I'll adding my custom layer here. Okay, I'll be adding my custom layer. But before that, I need to load the number of classes actually I'm having in this particular folder. Like how many object we are having. I'm having two particular level, cat and dog. So if I want to get the number automatically, so what I will be doing, I'll be using this globe package. Okay, the globe actually I have imported. So here I already imported the globe. So this is the globe. I can copy the name. Okay, globe. Inside that you have to give the location. Okay, you have to give the location. So I'll give my train folder location. Okay, inside train I want to tell start. That means refer everything. Okay, now it will give me the folder. Okay, so it will give me the folder. Now I need to check the length of the folder. Now if I show you the folder, so here I'm having two folder. One is like cat and dog. Okay, cat and dog, as you can see, one is like cat and dog. Now what I will do, I'll check the length of this particular folder. Now you see I'm having two classes. One is like cat and dog. Okay, now I can automate this process. Okay, to create my custom layer. Now I'll be adding my custom layer. Adding our custom dense layer. Okay, adding our custom dense layer. So for this, first of all, I'll be defining my model called sequential. Okay, sequential, I think I already imported. Here I already imported sequential because it's a sequential model. Okay, sequence by sequence you have to define everything. So sequential, then I have to add model.add. I'll add my base model. The base model actually we downloaded this VG16. Okay, VGC model. Then after that I will add one flatten layer. Okay, model.add. I think we already imported flatten. Okay, flatten. Then after that, I need to add my dense layer. Okay, the custom dense layer. That means this particular layer actually I'm adding. Okay, my custom dense layer. So I'll be adding only two dense layers. So model.add. But in VG16 it was having three dense layer. Okay, but I'll be adding two dense layer here. You can add as many as layer you can. Okay, it's up to you. But I'll be adding two dense layer here. Okay, so dense. I already imported this particular dense. Okay, on top of. And in the dense, I want actually 256 neurons. Okay, 256 neurons. Okay, in this particular dense layer. And here I want to use activation function. Okay, activation function is equal to relu. Okay, relu. I think you already know what is relu activation function. Okay, then I'll use the same statement. And at the last layer, I'm going to add 2 only because I'm having two classes. Okay, as you can see, I'm having two classes, cat and dog. Okay, instead of giving two hard coded, what I can do, I can also give the length of the folder like that, but you can also mention two because you already got to know you have having two classes here. Okay, and at the last layer, activation function, I'm going to use softmax. Okay, softmax activation function, because I have having more than one classes. Okay, that's how I'll be using softmax activation function. Now let me define my architecture. Now if I again do the model.summary, now you'll see the trainable parameter. Okay, you will see the trainable parameter. Yeah, so this is the model architecture right now, and this is the trainable parameter. Okay, so I can't see the trainable parameter. Just a minute. Let me check. Okay, sorry, I have to write model.summary. Okay, I have written VGG16 summary. Okay, that's why it's giving me the previous object. Now you'll see the model.summary. You will see this is the trainable parameter. Okay, now this is the trainable parameter. That many parameter you have to train. Okay, now what I will do, I'll compile this particular model, because in TensorFlow you have to compile the model. Okay, to compile the model, just write model.compile. Okay, model.compile, and inside that you have to mention the loss function. Okay, loss function. So loss is equal to, I'm going to use one loss function called categorical cross entropy. Okay, categorical cross entropy. This is the loss function I'm going to use. Then I also need to mention something called optimizer. Okay, optimizer. Okay, optimizer, because it will help me to do the gradient descent. Okay, that means the back propagation. So I'm going to use the Adam optimizer. Okay, there are so many optimizer. Stochastic gradient descent is there. Adam is there. Then you have ADA grade is also there. RMS prop is there. Okay, different optimizer are there. Then I also need to use the metric. Okay, so here I can write metric. Okay, metrics wise, I'm going to use the accuracy metric, because this is a classification problem statement. Okay, that's why I'm going to use accuracy. Okay, accuracy metric. Okay, so now I'll be doing the compile of the model. Yeah, compilation is done. Now I have to load my image. Okay, I have to load my image, because as you can see, the image actually I haven't loaded yet. Okay, and I also need to do some transformation on top of the image. Let's say I will be performing the scaling operation, because if you know, image is nothing but it's a pixel. Okay, if I search any kinds of image, let's say image as pixel. Okay, pixel numbers. So if you see, any image is a pixel numbers only. If I open any image, it's a pixel number only. See, it's a pixel number only. Okay, so this number actually, if you see, it's varying. Okay, sometimes it's a smaller number, sometimes it's a bigger number. Okay, and it will range between 0 to 0 to 255. Okay, this is the particular number. Now you have to scale those number. Okay, you have to bring in a one particular scale, so that your back propagation, that means gradient descent, would be very fast. Okay, so for this you have to scale it. First of all, I will be importing one particular library. So here I can write image processing. Okay, now here I'll be importing one library from TensorFlow dot keras. Okay, dot preprocessing. Okay, image. I'm going to import this image generator. I think image generator we already imported here. Let me show you. Yeah, image generator, I think we already imported. Yeah, I don't need to import. I already imported image generator. So I think I can remove it. Yeah, image generator I don't need. So first of all, I'll use this image generator object, and inside that I'm going to pass. Okay, I'm going to pass the scale parameter. Okay, the scale parameter. So here I can write rescale. Okay, rescale. CEL, rescale. CALE, rescale. Okay, rescale is equal to, you have to give 1 point divided by, okay, divided by 255. So here actually I'm performing min max scaling. Okay, and this is the number you have to give. Okay, if you want to perform min max scaling, okay, it will perform min max scaling for you. Then you also need to perform some image augmentation, because what happens actually, I'm having this very less number of images in the folder. I will be performing augmentation. That means I will be generating some new image. Okay, what is augmentation? Let me show you. So image augmentation. augmentation. Okay, so augmentation is nothing but you are just using the same image sample and you are generating some image. Okay, let's say this is the cat image I'm having. So what I will do, I'll take this particular cat image, I'll rotate, I'll change the brightness. Okay, I'll cut this particular cat. Okay, I'll resize it. So that's how actually I'm generating new image. Okay, by referring the same image. Let's say I'm changing the brightness, contrast, okay, hue, saturation, and all. So this is called image augmentation. Okay, and if you want to perform image augmentation in runtime, you can also do it with the help of this image generator. Okay, now inside that you have to perform some of the parameter. Let me show you. So these are the parameter you have to mention. So share ratio, that means it will perform share. That means it will rotate this particular image. Okay, so here, so this is called sharing. Actually, this will rotate. This will rotate this particular image. This is called sharing. Then zoom range. That means sometimes it will also zoom that particular image. Let's say this is the image. Sometimes it will zoom that particular image. Okay, so this is the zoom range. And you also need to give the horizontal flip. That means it will also perform the flip operation. Let's say this is the original image. After flipping, actually it will look like that. So let me show you one flipping example. Yeah, so here I can show, let's say this is the original image. After flipping, it will look like that. Okay, so you also need to set the flipping parameter. There are so many actually things in the image augmentation. You can write Keras image augmentation. Okay, so you will already get all the functionality. See, random crop you can apply, flip you can apply, translation you can apply, rotation you can apply, zoom, contrast, brightness. And here is the code, guys. Okay, if I click here, so here is the code. Okay, how to apply, these are the thing. Here is the code you can apply. You can explore later on thing, but here I'll be applying these are the things only. Okay, now it will give me my training image. Okay, my training data generator. So here I can store it, this particular object, training data generator. Okay, now similar wise I also need to perform for my testing. Okay, so here see, testing I don't need, because training, in the training itself I will be only doing the data augmentation. Okay, but in the testing image I will only apply the rescale operation. So what I will do, I'll copy, and rescale I will only apply. Okay, and I think I'll close the bracket. Rescale is fine for me. Now let me also change the, this is the testing image. Okay, test image, test data gen. Okay, now let me load this particular object. Okay, now what I have to do, I have to load this particular image because I already created the object. Let's say what are the transformation I'll be applying. So instead of image processing, I can write data transformation. Now I have to load the image. Okay, load the image from the directory. So loading images. Okay, so how to load the image? So first of all, I will call train data gen, and inside that you have one like method called flow form directory. Okay, that means it is available inside my directory. Okay, let me show you. So if I just write ls, it is available inside my directory. So it is available inside my directory. Okay, training directory and validation directory. Okay, so I need to give this particular directory location. So flow from directory, and here you have to give the directory. So it is inside my training folder. Okay, training folder. Okay, then I don't need to give the path, only training folder is fine. Okay, yeah, so I need to give enter. Just a minute. So this is inside my train. Okay, then I also need to give the input size. That means the model input size is 224 3. Okay, and your image should be also converted to 224 3. That's why you also need to mention the target size of the image. So it will automatically crop this part of the image, okay, for you. So you don't need to manually do it. Then you also need to give the batch size. Okay, because during training, how many batches actually it will take the image. Okay, then you also need to give the class mode is equal to category, because it's a categorical classification I am doing, not a regression. Okay, it's a categorical classification I'm doing. Now I already given my generator. Now it will give me my training set. I'll get my training set. Okay, training set. Now I also need to load my testing set as well. Okay, so first of all, let's load the training set. Loading training images. Okay, train images. Now let me load. See, found 333 images belonging to 2 classes, because it is referring my training, okay, training folder as well as the validation folder, and it is combining all the images together, and it is telling that many of images it is found. Okay, then I also need to load my testing image. I'll copy the same code, and here I'm going to mention, and here I'm going to mention is the testing image. Okay, so for testing image, here I can write this is a test set. Okay, and I'm going to use the same test gen right now, because train gen I have loaded. Here I can write test gen because this is my testing image. Okay, testing image generation. Now test gen flow from directory. Okay, and here you have to give the target size, batch size is equal to, and the class mode. Okay, so everything you have to give like that. Now let's load the testing image as well. So I'll load the testing image. Now testing image wise, it got 333 images belonging to two classes. Okay, it's completely fine. Let me check, verify once again. So everything is fine or not. Test gen. Okay, it is coming the same image. Why? Just okay. Sorry, I'm giving training folder, so it should be testing folder. Sorry, validation folder. Otherwise, it is loading my data from the training image. Okay, that's why you need to give the validation folder, because this is the testing image. Okay, now I think it should work. Where I have given? Sorry, not here. I have to give in here validation. Here I have to give. Okay, now let's load the training. First of all, yeah, compilation is done. Now let's load the training image. First of all, let me define that data gen again. Then load that. Then I also load my testing image. Okay, now see, testing image, it got 59 images only belonging to two classes. Okay, everything is fine. Now I'll start the training. To start the training, what you have to do, just write model dot fit. Okay, and inside that you have to give the training set. Okay, so I am having the training set here. So this is the training set, training data. Then you also need to give the validation set. Okay, validation underscore data is equal to, here is the validation set. That's been testing set, validation set. Okay, then you also need to give the epoch, number of epoch you want to train. So epochs. Okay, epochs is equal to, I want to only 10 epochs, or you can also increase the size. That's 50 epochs. Okay, 50 epochs at least. But whenever you are training your actual model, make sure you are increasing the epoch size. Okay, otherwise your model won't be learning better. Okay, then I also need to give my step per epoch length and validation step per epoch length. Okay, so you can give like that. So these are the default parameter you need to pass inside the model.fit. Okay, step per epoch and validation step per epoch. For this, you can take the length of the training set and you can take the length of the validation set. Okay, that's it. Now you can start the training. So let's start the training. But before that, I will also want to store my model training object in a variable. So here I can just write, I can store in a, that's a variable. So here I can write history. Okay, history. Okay, so this is my variable. Now here I can execute. See guys, my epoch has started. Now it will train 50 epoch, and you can see the accuracy and losses. Okay, see loss and accuracy, you can see real time. So let's wait. Okay, it will take some time. So this is my training accuracy, training loss. This is my validation loss. This is my validation accuracy. And see, it is learning, I think. So we can check here. See, initially it was 49. Now it has become, validation accuracy has become 76, 79, 81, 81. That means it is learning. Okay, it is learning better. And if you can observe, your accuracy is not increasing, loss is not decreasing, at the time you can stop the execution. Okay, but you can see my learning is going on. And see, accuracy, training accuracy and validation accuracy should be close together, otherwise your model will be overfitted. Okay, make sure this two accuracy and losses is close together. You can see my accuracy is 97 and validation accuracy 83. It's fine, I can call it, it's learning. But if there is a huge difference, okay, that time you can consider it's a overfitting problem. My loss is decreasing Accuracy also increasing sometimes and sometimes decreasing because it is learning right now. Again, you don't have let's say huge amount of data, that's why learning is not good, so you have to add more images here. I only trained how many images, guys? So here is the image size 168, so it's not enough. At least you should have 1,000 example, okay, in each category. So 28 epoch is going on, so let's wait for 50 epochs only. Okay, after that I think we can show you. Can we use LLM for image classification? LLM, again, see, in LLM actually you have two kinds of LLM. You have LLM, that means large language model, and you have something called LIM, that means large image model. Okay, large image model can only generate image. Okay, not it can't actually do the image classification. It can perform image classification. Let's say if you give one image and you can give a prompt, let's say which object present in the image, it will tell you that particular object. But image classification is a separate thing we need. Okay, so I always tell, let's say you can let's say kill one bird with the help of, let's say but with a stone actually. But why you will be using, let's say, rocket launcher for this? Okay, so it's kinds of thing like that only. So you can solve this problem statement with the help of simple architecture, let's say BG16 rather than 50. But why you will be using LLM there? Because LLM would be very like costly now at the end. See, my accuracy is not improving. That means I can stop the execution right now, but let's wait at least 50 epochs. I already done. Okay, it's done. Now I can show you the graph, actually loss and accuracy graph. So for this, I can use something called matplotlib. Okay, so import. You can also use Seaborn, but I will be using matplotlib. So matplotlib dot pyplot, okay, as PLT. Then I can just write. First of all, let me import. Yeah, so I can just write PLT dot plot. Okay, PLT dot plot. First of all, I want to plot my history. Okay, dot history, because it is having one method called history. Okay, so let me show you. The history object actually I stored here. Okay, history, it is having another object called history, and in that particular history I'm having all the matrices, okay, in a CSV file. Let me show you in a table actually. So history dot history, if I just do, so it will show you one table. Okay, so it should be attribute only. See guys, it will give you all the metrics and losses. Okay, all the metrics. See, this is the loss and this is the accuracy. Okay, everything it will give you. Now this thing I want to plot. Okay, how I want to plot? So I'll be using plt.plot. I want to plot history. First of all, I want to plot the loss. Okay, so here I can give, I want to plot the loss, because as you can see, it is having also losses and accuracy. Okay, losses and accuracy. So I think somewhere I saw the loss. See, this is the accuracy and this is the loss. I think this is the loss. Okay, I want to plot the loss first of all. So let's plot the loss. Then I also need to give the label. Label is equal to, this is my train loss. Okay, this is my train loss. Okay, then I also need to plot my validation loss. Okay, so for this I'm going to use the same code, plt.plot. Now history, here I'm going to write my validation loss. Okay, val loss, val underscore loss. Okay, now label should be validation loss, val loss. Okay, then I want to create a legend. So for this, plt dot legend. Okay, legend, legend, legend. Then after that, I will get to show this particular image in my Jupyter notebook. So I'll just write plt dot show. Okay, then I also need to save this particular file, okay, in a PNG file. So for in a JPG file or PNG file, you can also save. So for this, you can write plt dot save file, save file, okay, and here you can give any name. So it is my loss val graph, okay, loss, okay, loss graph. It's my loss graph, okay. Here I can save like that. Now let me execute and show you. Okay, save file is not there. I think save fig. Okay, it's a save fig, not a file. It's a save fig. I want to save the figure. Okay, now you can see this is the loss. That means your training epoch is increasing. Your loss is also decreasing. Okay, loss is also decreasing. But here is the saturation, as you can see. But I already told you don't need to train that much of epoch. Here I got my lesser loss. But again, this is your validation loss. You can see this is the value loss, this is the training loss, and it is like slightly difference because again you have less amount of data. That's why you can see this. These are the difference. Okay, but if you're having, let's say, a huge amount of data, and at the time you will see these two losses would be close together. Okay, that time your model is learning. I can't tell this model is better, but at least I showed you the training. But later on, you just download that particular image I showed you from the Kaggle. Okay, use all the data and now train the model. Okay, you will see your model will be learning better. Okay, so this is the loss graph, and this image actually I have also saved. Okay, now if I go to my drive and refresh the page, now see this loss graph also I have saved. Okay, this is the image I also saved in my Google Drive. Okay, now we can also refer later on. Okay, so you can download and you can see that I already saved this. Now what I have to do, yeah, now what I have to do, I also need to show you the accuracy. Okay, accuracy graph. So accuracy wise, I can use the same thing. Only I just need to use the accuracy. Okay, instead of loss, it should be accuracy. Okay, accuracy, and this is my training accuracy. Okay, as well as my validation accuracy. Okay, accuracy, and everything will remain same, and this should be my accuracy graph. Okay, now let me execute. Now see guys, this is the accuracy. That means epoch is increasing, accuracy is also increasing. But again, you can see the difference because I have by less amount of data. Okay. Now what I have to do, I have to save this particular model. Okay. How to save the model so that you can do the inference later on. You can create an application later on. So here I can write save model. Save model. Okay. So to save the model, you have to use something called you have to use something called model dot save. Okay, this is the method you have to use, and inside that you have to give the model name. So I can save the model with the help of this particular name, model underscore VGG16. Okay, VGG16 dot h5. Okay, if you're using TensorFlow, you have to use this particular format called h5. But if you're using PyTorch, you need to give pt.pt. Okay, so this is the difference only. Now let me save the model. My model is saved. Now if I go to the drive and refresh the page, now after some times you'll see it will load. See guys, model has been saved. Okay, now I'll tell you how we can load the model as well. Okay, how we can load the model as well. So first of all, yeah, so to load the model, you have to use this particular use this particular load method. Okay, so you just first of all need to import this particular load method from the TensorFlow. So here I can write load model. Load model. So for this, you need this particular load method from the TensorFlow. So TensorFlow, okay, TensorFlow dot keras, okay, models import load underscore model. Okay, load model, and inside load model, here you need to pass this. So model is equal to load model, and this is the name. Okay, the name actually you have saved the model, you have to give the same name. Okay, now it will load the model. Okay, it has loaded the model. Now I want to do the prediction. Okay, on top of my test data. So what I can do, I can also do the prediction. I can just write model dot predict. Okay, model dot predict, and here I can pass my test data. Okay, test set. Okay, test set actually I loaded. So test underscore set. Okay, now it will give me the prediction. That means y hat. So here I can write y pred. Okay, y prediction. So let me predict. Okay, now here I got all the prediction and it is in softmax output. So it is in softmax output. Okay, that means 2 probability I'm getting. So highest probability should be my actual answer. Now how to filter out the actual answer? Okay, so for this you have to use numpy. So I already imported numpy. So here you just need to write np.argmax. Okay, with the help of argmax you can solve this problem. So argmax. Okay, inside that you need to give the y prediction. Okay, the y prediction you got. Okay, and you need to define the axis. Okay, as axis is equal to 1, and after that it will give you the y pred again, y underscore pred. Okay, now if I print it, now see I will get my 0 and 1. Okay, 0 and 1. That means whenever you are having 0, okay, whenever you are having 0, that means it's a, whenever you are having let's say 0, it's a cat, or whenever you are having 1, that means it's a dog. But how I will get to know whether my 0 is cat and 1 is dog? Okay, for this you have to check the this one. Actually, if I go to the folder, okay, if I go to the folder, now you can check the alphabetically order. Okay, now see cat. Okay, cat is coming because if you see the C alphabet, okay, C alphabet, C, after C actually D come. Okay, so if I now assign the index, okay, if I assign the index between these two folder, so C will have the 0 index and D will have the 1. Okay, that's how actually by default your keras will also consider. C will be assigned with 0, that means cat will assign it with 0, and D will be assigned, that means dog will be assigned with 1. Okay, so that's how whenever your model is predicting, 0, that means it is predicting as cat. Okay, and whenever it is predicting as 1, that means it is a dog. Okay, that's how we can define this particular label. Okay, now what I will do, now I need to, so this is my prediction. Okay, this is my final prediction. Now let's say you want to do a single image prediction. Okay, you can also do the single image prediction. So let me show you how to perform the single image prediction as well. So first of all, let's load upload one image here. Okay, in my directory I'll upload one test image. Okay, so I'll upload one cat image. Let's upload one dog image first of all. So this is the dog. Here is the dog I can see. Let me upload one dog. Let's say this is the dog. Okay, this is the dog. I'll upload this particular image. I'll copy, or I can drag and drop here. Okay, this is my dog image. Now, first of all, let's load this particular image. Okay, to load this particular image, I think you remember, we can also use a matplotlib to show the image. Okay, let me show you. Just a minute. First of all, let's load the image. So load our testing image. Load test image. Okay, so what is the name of the test image? So here I can take the name ls. So here is the name of the image. Okay, so image name, this is the image name. Now I can load the image with the help of the image library we have imported. Let me show you. So here we have imported the image, I think somewhere. Yeah, image I imported. So here I imported the image. Okay, I'll copy this particular library, and here I can use image. Okay, image dot load. Okay, load. Okay, load image. I think load img. Load underscore img. Okay, now inside that you have to give the name of the image. So this is the image name. Okay, then you also need to define the target size. Okay, the same target size you train the model. Okay, 224 224. So it will load with respect to that only. Now it will give you the image object img. Okay, image object. Now let me load the image. Okay, then after that you have to convert it to numpy array. Okay, this image actually you got. you have to convert it to numpy array. Okay, and this will give you the numpy array. Now see guys, this is my pixel value, okay, of that particular image. Now if you want to like show it, okay, like how these images look like, you can use plt.show. Okay, sorry, it should be image name. Now it should show. So this is my dog image. Okay, now what I will do, I'll see the shape of the particular image. Okay, x dot shape. So it's 224 comma 3. Okay, now I have to apply the scaling operation. I think you remember we also perform scaling operation during training. Okay, the min max scaling. I need to divide with 255. Then I need to process the input because I need to add one batch dimension here. Okay, that's why I'm going to use this process input function. Now here you can set the batch dimension like that. Let me show you. Okay, so I'm expanding one dimension here. Okay, because what is happened by default, if you see, it is the dimension of the image. Okay, but when we train, there is another dimension called batch dimension. Okay, but this image doesn't have any batch dimension. That's why I'm adding one batch dimension. Okay, one extra dimension. So now if you see my final dimension, it's 1. That means one batch. That means one image I'm having, which is nothing but 224 comma 3. Okay, 224 is the height, 224 is a width, and 3 is the channel. Okay, then finally I can give it to my model. So model dot predict. Okay, model dot predict, and here is my data, my image. Okay, now it will give you the prediction, but again it's a sort max output. Okay, but if I want to get an authentic output, that means 0 or 1, at that time I can use argmax. Okay, argmax, inside that I can do it, and it will give me the result. Now if I show you the result, now it is predicting as 0. Okay, it is predicting as 0. Now what is 0 means, guys? 0 means it's a cat, but my model is failing. Okay, in this particular case, now see, it is predicting as cat. Whenever it is let's say 1, it's a dog, other is a cat, but here it is predicting as 0. That means my model is not a good model because we have very less amount of image. Okay, that's why it's not predicting. So now what you can do, you can try with a cat image also. So let's upload one cat image. I think cat image, I think it should predict. So let me try. Let's say I am having one cat image here. So this is the cat image. So I'll be using this particular image. Okay, now let's load this particular cat image also. So here is the cat image. Let's load quickly. Now see, cat, it is predicting correctly. Okay, but dog, it is not able to identify because maybe you have to add some more dog images. Okay, then it will work fine. Okay, now see, cat, it is working fine. Okay, now see, that's how you can also do the image prediction. Okay, if you have any single image, you can also do the image prediction. Okay, now you have your model. Okay, you have your model, and you already know how to, let's say, test on top of the model, how to load the model. Okay, how to upload an image. Now what you can do, you can create a web application right now. Okay, you can create a web application. There user will upload one image. Okay, you will receive that particular image and you will perform these are the operation and will show the prediction whether it's a cat and dog image. Okay, that's how you can do. Okay, so this should be your task. Just try to create a web application with the help of Flask or Streamlit. You can create. Okay, that's how actually you can create an application on top of it. But I have showed you the entire step, how we can prepare the data, how we can training and all. Okay, and how we can perform the image classification technique. Okay, see, on top of image classification, I implemented one package called image seeker. Okay, long back. So if you don't know about coding and all, if you are worrying about the coding, so you can use my package. Okay, image seeker package. So you don't need to write any code for the image classification. So this is the PyPy package I developed. So author is me, Bappi Ahmed, and this is the repo of this particular PyPy package. So 2 years back, actually, I implemented this. 3 years back, okay, I implemented this particular package, and this package tell you, see, these are the steps actually we performed so far to perform the image classification. Okay, but if you're using my package, what you have to do, only you just need to create an environment, install image seeker. After that, launch the image seeker. Okay, you will get this kinds of interface, and here you just need to click on the get started. give your data location, number of classes, model name, which model you want to use, choose the model, number of classes you need to give. After that, click on start training. Okay, it will automatically train. After that, you will see all the graphics, metrics and everything. Then after that, you need to click on the predict button. Then you will get this kinds of interface. Okay, now if you upload any image and click on the predict, it will show you whether it's a cat and dog. Okay, so this is the class, like image classification library I developed long back. Okay, then on top of that, I think I already added one YouTube tutorial how to use this image classification. Now let me show you the YouTube tutorial as well. So it is available in my YouTube channel. So if you go to my YouTube channel, so this is my YouTube channel. So in the video section, I think you will see that image seeker. Okay, you can search on the search button. There is a search button you will see. You can search here called image seeker. You will get this particular thing. So this is my YouTube channel. Okay, so that's how, guys, you can also work on, you can automate this particular task. Okay, if you want, and you can build something for the community. Okay, yeah. So yes, guys, this is all about from the today's session actually. And today we have learned about image classification with the help of TensorFlow. Tomorrow we'll be exploring about the PyTorch implementation as well, like how we can use PyTorch to the image classification and all, right? Yeah. So make sure you subscribe to our channel to get the always notified, and make sure you subscribe for this. You have enrolled for these courses. So whatever material actually I have done, I'll share each and everything here. Okay. Yeah. So with that, guys, thank you so much for joining the session. Okay. Please share this video with your friends and family so that they can also learn about this. Okay, and bye everyone, take care. So today actually will be show you this particular image classification task with the help of PyTorch, because in our previous session we have seen how we can perform image classification with the help of TensorFlow, right? So because see, PyTorch also, I mean, it's a good framework, okay, you can use, because PyTorch is like very powerful and all, and it is mostly used in the research field actually, if you see, because it's like low level framework. Okay, if I'm talking about coding wise, so today actually whenever I will do the coding and all, you will get the idea. But whenever I was using TensorFlow Keras, actually it was high level API, so there I don't need to write tons of code for that. Okay, so everything it was written inside that only, so I just need to call that particular, let's say, class and method. I need to perform my job, but here you have to write each and everything manually. Okay. Okay, and today I'll show you how we can create our custom architecture, because yesterday I was discussing about pre-trained model. So in this particular session, I'm going to show you the custom architecture, how we can develop our custom CNN architecture. Okay, and with the help of that, how we can perform the image classification task. Just a minute. So we'll be creating one basics neural network here, and I will also give you some of the reference, so that if you, let's say, if you want to also use pre-trained model, okay, you can also use pre-trained model. Yeah, I'll show you the documentation, and I will also show you the resources and all. You can follow along with that. Okay, because see, I'm not going to directly jump into the advanced part of the PyTorch, because I know this PyTorch is a little bit complicated. So that is why I will start with the very basics. Okay, I will show you the very basics image classification. Then I'll also guide you for the advanced part, like how we can perform. Okay, if you understand the basics one, advanced part would be almost same. Yeah, so first of all, let me show you. So if you're looking for the resources and the video, like where it would be available, video you'll get over the YouTube channel. Okay, we are having this YouTube channel, so here actually we'll get all the videos. Apart from that, actually, if you want to get everything in one place, so what you can do, go to our iNeuron website, and here you can go to the community program. So this is the community program is going on, guys. So the name of the program is Computer Vision Hands-On. So if I click here, so please make sure you have enrolled for this particular course, and it's completely free. Then after that, if I go to my dashboard, okay, here if you see, all the videos, all the materials has been updated. Let me show you. So if I go to the dashboard, okay, so it is in it's not updated yet, so I think it will be updated by today. So here actually we'll see all the like resources, all the video link. Okay, everything would be there. So from there actually you can refer, and yesterday notebook would be also available here. Yeah, so you can get it from here. Okay, so before starting, first of all, let me show you the PyTorch. Okay, PyTorch documentation. So currently PyTorch is like 2.2 version is you can see. If you want to verify the version, you can go to the PyTorch PyPy. So here you will see the version, actually the current version. So release history, yeah, so it is 2.2.2. This is the current version. Okay, and how to install this particular PyTorch based on the like machine configuration. Let's say if you're using CPU, GPU, okay, different CUDA version. At a time you can go to the PyTorch official website. Okay, so if I go to the PyTorch, so here they have already given the installation guideline. So see, so here you can select the stable version, that means the current version of the PyTorch, and your operating system you have to also select. Let's say here I'm using Windows machine, so I'll be selecting Windows machine. If you're also using Mac and Linux, so you can use these are the machine as well. Then package by using which package manager you want to install. Either you can go with Conda, either you can go with pip. You can also install with the source and libtorch, but I will suggest go with pip installation. And language wise you have to select. So here I'm going to use Python programming language, so you can select Python. If you are also working in the field of, let's say, C++ and Java, you can also use that particular PyTorch there also. Okay, then CUDA, that means based on your CUDA version, okay, in your system you have to select this particular CUDA version. Let's say if I want to check my CUDA version, so I'll open up my CMD. Okay, if I open up my CMD command prompt, so from here I can check my CUDA version. Okay, so if I just write NVIDIA, okay, NVIDIA hyphen SMI, so it will give me the GPU configuration I'm using in my system, and this is the CUDA version actually I'm using 12.0. Okay, based on that actually you have to select. Now whenever I'm talking about 12.0, that means I will be going with this particular CUDA version. Okay, 12.1. And if you don't have GPU, if you want to install on the CPU, so you can use this particular CPU command, and this is the final command you need to copy and install. But I'm going to use Google Colab for this particular you can say session. uh, because in Google Colab everything would be installed there. I don't need to install anything. But if you want to install, so that's actually you can install. Okay, and let's say if you want to also go with the previous version of the PyTorch, just click here. So it is having, let's say, lots of previous version as well, apart from 2.2. So you can see lots of version are available. Okay, you can also use previous version of the PyTorch. Let's say if you need this PyTorch for any specific project, you want to use, let's say, 2.1.1. okay, at that time you can also install the previous version of the PyTorch. Okay, it is also possible. So that's how they have created one beautiful documentation. So this is the best way to learn actually PyTorch. So everything will get in one place. Let's say you want to learn about the source code and all, so just go to the documentation. Okay, and here they have given everything. Let's say I want to learn about image classification. Okay, so here I can search about image classification. I think it is there. So torch NNN, yeah, so documentation, torch audio, torch vision. Okay, so I need to go with the torch vision. Okay, because vision is a computer vision actually functionality they will provide you. So if I go to the torch vision, now here you can see image classification example is also there. So let me show you. So transform the augmentation image example and training and inference example and tutorial. If I go here, get started with transform v2 illustration, end-to-end object detection, segmentation is there, but I want the image classification code. Either you can search here image classification, okay, PyTorch docs. Okay, so it will automatically redirect to that particular page. You can also see, you can also refer this particular tutorial. See, all the tutorials are there, all the source code are there. Okay, you can copy paste from here only, and you can try to understand what is happening. But I'll explain each and everything how we can perform the image classification. Okay, and I'll be taking one dataset from the PyTorch only. Okay, the dataset name is fashion MNIST dataset. Okay, so let me show you the fashion MNIST dataset, how it is look like. Fashion MNIST dataset. So this is the dataset, guys. So it has actually fashion related data. So let me show you. So it is having this much of class actually, bag, t-shirt. Okay, then you have shoes. If you have different actually fashion related actually equipment. So this is called actually fashion MNIST dataset. Okay, I'll be using this particular dataset. You can also use your custom data. Okay, I'll tell you how to use the custom data. I will also give you the reference after the session. Okay, and this dataset is already available in the PyTorch. You don't need to download it manually. If you want to also download, this dataset is also available in the Kaggle. Okay, from the Kaggle also you can download. Okay, Kaggle is also having this particular dataset. You can also download from Kaggle. If I go to the all, see Kaggle is also having fashion MNIST dataset. Okay, you can also get from here. But I'm not going to download because this dataset is already available inside my PyTorch. So from there, actually, I will access my dataset. Okay. Yeah. So first of all, let's open one Colab notebook. So actually, I work on code generation using transformer PyTorch, which work as the retrieval, and I wanted to get the LLM GC with trained on this large language content. You can see like how you can actually do the code generation with the help of that particular model. Okay, just explore over the internet, you will get it. Now here, let me create one notebook. And I'll first of all name this particular notebook image classification using PyTorch. So first of all, I'll be selecting the runtime because I'm going to use GPU here. So make sure you also select the runtime. So let's take the free GPU, T4 GPU I'll be taking, and let's save it. And after that, I will connect this particular node. Okay, it's connected. Now let's first of all test our PyTorch is available or not. So for this, you just need to write import torch. Okay. Now, if it is working, that means it is already there. Yeah, it is already there. Now let's check the version also. So torch dot hyphen version underscore. So now if I show you, see, this is the torch version and CUDA 12.1. Okay, 2.2.1 it is installed, and CUDA they are using 12.1. Okay, that's how we can also check the version of the torch. All right. Okay, now let's start our coding part of the image classification. So first of all, what I will do, I'll import some of the library which is required in this particular project. So let me first of all import all of them. Yeah. So first of all, I already imported torch. I don't need to import. So I'll be importing neural network from the torch. Okay. So from torch. Okay. From torch, actually, I'll be importing neural network. Okay. NN. You can check the documentation. I already showed you image classification documentation. They're also importing like that only. See, let me show you. They have also their Colab notebook and all. You can download the notebook. Either you can go with the GitHub repo they have shared. And yeah, transform, torch vision. Actually, you need to download these at the you need to import these at the package. Okay, but let's use simple neural network only in this particular series because I already told you I'll be starting with the very simple concept of the image classification with the help of PyTorch. Then I will also show you the like advanced one. Okay, I'll guide you like on top of the advanced one how we can it can be done. Okay, so let me import torch NN. Then I need also data loader. Okay, from the PyTorch. So from torch. Okay, it is available in the utils. Okay, dot data. I need something called data loader. Okay, then I also need something called dataset because I'm going to access the MNIST dataset, fashion MNIST dataset. So it is already available inside torch vision. Okay, torch vision. Okay, import datasets. Okay, then I also need something called some of the, let's say, I mean processing library. Okay, processing package actually. So it is already available inside torch vision. So torch vision, I can copy the name, and here you have something called transform Okay, transform. I need to import two tensor. Okay, then I also need lambda. Then I need compose. I'll explain whenever I'll be using these at the, let's say, method and all. I'll be explaining what is this two tensor compose. Okay, why I'm using this particular things. Then to showcase my image, actually, I need this matplotlib. So let's import some matplotlib. Okay, matplotlib dot pyplot. Okay, as plt. Okay, so these are the packages as of now I need, and if I need anything else later on, I'll import. Okay, one by one. Okay, it's giving one error. It's telling cannot import lambda from torch vision transform. Okay, so why it's not? Okay, so it should be lambda. Lambda. Okay, now I think it should work. Yeah, so now it is working. Let me change the view so that you can also see everything. Yeah. What is the lambda used for? I'll tell you whenever I'll be using. Okay, I'll tell you what is the use of lambda. Okay. Yeah. So now what I have to do? First of all, I will load the data. Okay, I'll load my fashion MNIST data. Okay, so this dataset is available inside datasets. So here you need to call fashion. Okay, if you go to the documentation of this particular PyTorch, you will see they are also loading like that only, fashion MNIST. Okay, fashion MNIST. Now inside that you have to provide some of the parameter. Okay, like why you want to download this particular data. So I want to download. Okay, root is equal to. It will create one folder called data. Okay, inside that it will download this particular data. Then after that, I need to specify I want to download the training example. Okay, so train is equal to true. Okay, then I also need to specify I want to download this. Okay, so download is equal to true. Then I want to transform everything to the tensor. Okay, because by default this PyTorch take actually tensor type dataset. Okay, not a numpy. So you have to convert all the, let's say, number to the tensor. Okay, I think you know the tensor. Okay, tensor is a data type. Actually it supports actually GPU computation. Okay, CUDA computation. So you have to convert everything to the tensor. In TensorFlow also, Keras will take care of this part. Okay, they will directly convert to tensor, but here you have to manually convert it. Okay, to tensor. So for this, here you just need to write transform. Okay, transform is equal to. So here I have already imported this particular two tensor. Okay, so it will automatically convert your number to tensor type data. Okay, now yeah, so this is for my training example. Okay, so here I can write this is my training example. Training underscore data. Okay, similar wise I also need to download my test data. Okay, so here I can write for the testing. So this is my test data. So here root the same directory, but here train is equal to, I need to make it as false because this is my testing example. Okay, download is equal to true, and again I need to convert to tensor. Okay, now if everything is fine, now let me execute this particular code snippet and let's see whether it is able to download the dataset or not. See, it is downloading the dataset from this particular URL. Okay, now if I go back here in this particular directory, now if I refresh, okay, you will see one data folder has been created. Okay, now if I go inside the data folder, fashion MNIST raw. Okay, and inside that, see, it has downloaded all the data. Okay, but it is in binary format. Okay, by default, whenever you are downloading data from the, let's say, torch vision, it would be in a binary format. Okay, so this is the format actually they will be downloading. You can't see that particular image, but if you want to load the actual image, you can also get from the Kaggle. I already showed you. Okay, so it's completely fine. I only need the data. I already downloaded this particular data. So here let me comment out. So download the data. Download data. Okay, data. Now next step, what I have to perform, I got my data. Now I have to define the data loader, because what happens actually, see, in PyTorch actually you have some concept. Okay, so you can't directly actually use the data during training. Okay, so first of all, let's say I downloaded the data. Okay, I download data. Okay, then what I have to do? Okay, I have to create a data loader object. Data loader object. So these are the common steps you have to remember for every project. Okay, you have to create a data loader object. In the data loader object, you have to mention the batch size. Okay, batch size, batch batch size. Okay, like during actually training, how many batches actually it will take the data. Okay, and this data loader will help you with that time. It will load the data from the directory you are having. Okay, and it will also define the batch size. Okay, like how many example will come during the training. So that's why data loader is very much important. Okay, so you have to define the data loader. Now let's define the data loader. Okay, I think I already imported this particular method. Okay, data loader. Okay, with the help of this, I will load the data. So now let's define the data loader. So it's like very easy. First of all, define a batch size. Okay, let's take 64. You can take any number. Then I'll call the data loader. Data loader is equal to okay, data loader. Inside that, I need to pass my training example first of all. Training data. Okay. Then I also need to give the batch size. Okay, so batch underscore size. Okay, is equal to batch size. Okay, so then I also need to load for my testing. So this is my training data loader. Okay, so train underscore data loader. Okay, train data loader. I also need to do it for my test data loader. So I'll copy, and here is my test data loader. Okay, so here I'm going to pass my test data. Sorry, here I need to pass, I think. Now I think everything is fine. Now let's load the data loader. Okay, and if you see this particular object, okay, if I print this particular object, so it's a data loader object. Okay, torch data loader object. You can't see the data. If you want to see the data, so what you have to do, you have to write a for loop. Okay, you have to iterate through this particular data loader, then you will be able to see the data. So for let's say it will give you two things, your x and y. Okay, in let's say test data loader. Okay, now if I print my x and y, see, this is the data actually I'll get. Okay, x means this is the image, that means your image pixel. Okay, and y means this is the label, like whether it's a let's say these are the actually I already showed you, I think, fashion MNIST classes. So it is having this many of classes. Okay, 10 classes: t-shirt, trouser, then pullover, dress, coat, sandal, then shirt, sneaker, bag, and ankle boot. Okay, now see, whenever it is coming 0, 1, 2, that means this is the label. Okay, label of this particular class. Now whenever you can see the 0, okay, if I show you, whenever you can see the 0, let's say I will only print the y. See, I'll only print the y. So whenever you can see the 0, okay, that means this is a t-shirt. Okay, this is a t-shirt. Okay, that's how actually it is aligned with the label. So let me go back. Just a minute. Let me go back. Yeah. Now we can see all the matrices. Okay. So that's how actually, and see, the data type is a tensor data type. It's not a numpy array. It's not a simple numpy array. This is a tensor data type. Okay. Now we are able to do the data loader part. Now we are able to load the data. Okay, in a batches. Now what I have to perform? I have to write one condition. Okay, because see, sometimes what will happen? Sometimes actually you will get some of the issue. Let's say you have used the limit of the GPU. At that time, actually, you will get the CPU. But that time, actually, if you mention the GPU training, that means CUDA, it will throw error. Okay, so for this, I can automate this process. So in PyTorch, actually, there is a logic actually you have to write. So if I just write device, okay, device is equal to, so CUDA, okay, if, okay, if torch dot CUDA is available. Okay, is underscore available, available. Okay, otherwise set CPU, else, okay, else you have to set CPU. Okay, sorry, CPU, it should be CPU. Yeah. Now see what will happen if I print the device right now. It will give me CUDA because I already selected the GPU. See, it will give me CUDA. because torch is automatically checking whether I'm having this CUDA enable or not. That means GPU enable or not, because I already showed you I selected already GPU, T4 GPU. But if you select to GPU right now, you will see it will print CPU. That's how it can automatically detect your device, okay? And it can like automatically set during training, like where you want to train this particular model, whether in CPU or whether in GPU machine, okay? So that's how you don't need to change the code, only you just need to write this particular statement and everything would be automatically done, okay, inside the PyTorch. Now what I have to do, I'll define my neural network, okay? I'll define my neural network. So let's define our custom, okay, NN, okay, or model. I can write model. Okay, so here I'll just write one class for neural network, neural, okay, neural networks. So in PyTorch, actually, you have to write this thing manually, okay? So that's why I already told you PyTorch is a little bit low level language. So if you understand Python object-oriented programming, so definitely it should be clear. Then I think you remember we already imported this NN, okay, neural network. So I have to inherit, okay, from this particular NN module. So that's how I'll be inheriting, okay, inheriting. So whenever you do inheriting, I think you remember you have to also define the constructor inside that. So underscore init, underscore, and here I have to define the self, okay. Then inside that I'll be writing one super class, okay. I think you know what is super class. Whenever you perform inheriting, okay, inheritance, you already know what is super class. So I want to inherit from this neural network, and here I just need to write self, okay. So all the functionality actually I will get from my NN module, okay, I want to access. So that's why I'm just writing this super class. So it should be underscore init, underscore, yeah, close. Now super class is ready. Now I will be adding the flatten layers of self dot flatten, okay. So here from the NN itself I will get the flatten layer, okay. So flatten, okay. After that I'll be adding my linear, okay, linear stack. That means my how many, let's say, neural network I'll be taking and what is the activation function I'm taking, okay. So for this I already created this particular architecture. Let me show you. So see, this is the architecture I already created. So this is my sorry, so this is my linear ReLU stack, okay. So here what I have done, here I have taken one sequential layer, okay. I think you already saw in the Keras also I was taking sequential layer because it's a sequential model, okay. It will go to the sequence to sequence will go. So first of all I'm taking one linear layer, okay, and it is having 28 cross 28 cross, okay. This is the image dimension, okay, because if you check this particular fashion MNIST, the image dimension is 28 cross 28 cross matrix, okay. So based on the image resolution you have to provide this particular input size, okay. Then you have to define the, like you can say, neurons, okay. How many neurons you want to take in this particular linear layer, okay. So I want to take 512 neurons. Then after that I have taken one ReLU activation function. Then again I took the, like you can say, one linear layer, and inside that I'm taking an, again, like you can say, see, this is the input. Like after going to this particular layer it will return this particular input, so this should be the input. And again I'm defining the output neurons, that means 512. Again I'm taking one activation function, ReLU activation function. Again I'm passing this particular input to this particular layer, okay. Then how many output actually we are having in this particular example? 10 example, okay. As I already showed you, level is equal to 10 different level actually we are having. But yesterday I was using only 2 level, okay, cat and dog. But here I'm having 10 level. That's why at the last layer actually I've just defined 10 neurons, okay. That means it will give you 10 output, okay. So that's how actually you can define a custom architecture, okay, with the help of PyTorch. And now see, everything you have written as a low level coding here. So here I'm not using any kinds of class and method. Everything you have to write as a low level. That's why PyTorch is like, it is most used in the research field, because in the research you have the customization option, okay. You can customize your architecture, you can customize anything. So whenever you are doing anything research for let's say research work and all, if you're creating your own architecture and all, go with the PyTorch implementation. Otherwise, if you're developing something, okay, you can go with the TensorFlow implementation, okay. Both you can use, both actually it is mostly used in the industry, but it's up to you which framework actually you will be choosing, okay. Personally, let's say I may prefer, let's say, Keras. You may prefer, let's say, PyTorch, okay. It's up to you, Okay, it's developer to developer choice which particular framework they'll be using for the specific task. Okay, both I'm showing you now. Just try to decide whatever actually we'll be using. Okay, now let's say you want to use the custom pre-trained architecture. Okay, let's say you want to use the pre-trained architecture. At the time that you can search ResNet or let's say VG16. Okay, yesterday I was also VG16 in PyTorch. Okay, so if you just search over internet, okay, you will see that particular code, how to load this particular VG16. Okay, so here is the code they have already given. Weight is equal to VG16. I want the example code. Main model pre-trained weights. Okay, data loader. VG16 optional non-parameters. So yeah, you have to import like that. Torch vision model VG16 base. Okay, you have to import like that. And these are some parameter you have to give the input. Okay, in the next phase, I think they have already given the tutorial. Okay, you can directly also search the tutorial like VG16 notebook. You will also get it. Okay, from there you can also copy paste the code. Classification, the last layer in the LLM and activation function. Sir, have you used a linear activation for the classification in the last layer? Here you're talking about at the last layer. No, last layer actually I haven't taken any activation function. Okay, because I want like 10 probabilities. Okay, that's why I haven't taken any activation function in the last layer. You can also add softmax. You can either like remove the softmax, both will work. Okay, now let's define the architecture. Let me define again. Yeah. Then here you have to also write another function called forward. Okay, because in the forward actually what you will do, you will do the forward propagation. Okay, so for this actually you need this particular forward. Okay, this forward. So here you will give the X data. It will first of all like pass into the neural network actually you have developed. Okay, this flatten. Then linear logic stack actually you have developed. It will go inside that. Then it will give you this particular output. Okay, so this is called forward pass. Okay, forward pass you have to write. And if you check the documentation, so here is the documentation. They have also written the forward pass. Okay, here let me show you. See, okay, they have also written the forward pass. That's how we have to define the neural network. Okay, inside the PyTorch. All right, so everything you don't need to remember. Everything is available in the documentation. So try to get the code from here. You don't need to remember anything because it's not possible to remember everything, right? Yeah. So it's just a like template kinds of code I'll be creating. So later on you just change the data and you can use this particular code. Okay, that's how we can use it. Done. Now what I have to do, I have to load this particular neural network to my device. Okay, the device actually I got. So if I show you my device, I'm inside CUDA. Okay, I'm inside CUDA. That means I'm using GPU. Okay, so let's load my model inside the GPU. So to load it, first of all, you just need to write model is equal to the neural network you have created, this particular class. Let me define this particular object. Okay, and you have to load two device. Okay, two, and here you just need to give the device because it will load everything inside the GPU because I want to perform GPU training. Okay, now if I print my model, okay, if I print my model, you will see this is my model architecture. Okay, this is my model architecture, entire model architecture. Okay, yeah. Now what I have to do, I have to define my loss function because yesterday also I was defining my loss function, then optimizer, right? So here also you need to define the loss function and optimizer. So how to define? Just write loss function. So loss underscore fn, that means function. So I'll be using something called nn dot cross entropy loss. Okay, there is a loss called cross entropy. Okay, cross entropy loss. This is the loss function I'm going to use. And optimizer wise, so let me just write optimizer. Okay, optimizer is equal to, I'm going to use torch dot optim. Okay, dot stochastic gradient descent. Okay, SGD, stochastic gradient descent. So this is the loss function I'm going to use. And here you just need to give the model parameter, the model you have developed. Okay, this model parameter you have to pass, because stochastic gradient descent will take the parameter and it will do the back propagation, right? It will update the weights. For this, you have to give the weight, all the weights you have defined, parameters. Okay, then here you have to pass the learning rate. So LR is equal to, so I can give the learning rate like that. So 1e, okay, minus 3. So this will give you one number. So let me show you this particular number you can provide. So this is the number 0.001. Okay, you can write this particular 0.001 like that, 1e minus e. Okay, that's how you can write. You can also write like that. You can also write like that. Okay, both you can mention. Okay, now let's load the loss function and optimize it. Okay, then here, first of all, what you have to do, you have to write one training loop. Okay, you have to write one training loop. So let me just write train loop. Inside PyTorch, you have to write one train loop. So if I show you the documentation also, they have also written the training loop. After neural network optimizer, see, this is the training loop. Train the neural network. For this, you have to write one training loop. Okay, and for like testing also, you have to write one testing loop. Okay, see, this is the testing loop. That's how you can write different loop. Okay, and this should be the custom loop. Okay, you can't use any kinds of functionality from the PyTorch. Okay, there is no class and method. It will automatically perform your training and let's say testing. You have to write this particular loop by your own. Okay, now I have already written this particular training loop. Let me show you how it will look like. So this is the common code for every, let's say, PyTorch implementation. So you can use it. So this is my training loop. Okay, so here I have named this particular function as train. It will take the data loader. That means the data actually you have loaded for the training. It will also take the model actually you have developed, the model architecture you have developed. Then the loss function you have created, and the optimizer. Okay, and first of all, it will check the size of the data. Okay, then after that, it will tell the model I want to train the model. Okay, that's why I'm just writing model.train. After that, I'm just taking the batches. Okay, that means the data. I think I already showed you, if you just perform for loop on top of the data, it will give you this particular data. That means the tensor. Okay, tensor value. This is what actually I'm loading. It will give you the image and it will give you the label. Okay, after that, I'm loading to the device. That means in the CUDA. After that, what I'm doing, I'm predicting on top of my model. Model will give me some losses. That losses actually I'm performing back propagation. Okay, so this is the back propagation code. So here I'm using optimizer, loss.backward, optimizer the step. That means it will calculate the loss. Okay, so what is happening here? So here you are giving, let's say this is your input data. This is your input data. Okay, so you are giving this particular input data to the model. Let's say this is my model. Okay, you are giving this particular input data to the model. So model will predict something, that means y hat. Okay, based on that, actually it will calculate the loss. Okay, loss. Okay, we'll get some loss. Based on the loss, actually what you will do, okay, based on the loss, you will come here to the model parameter. Okay, you will update the weight. Okay, we'll update the weight, and that's called backward parameter. Sorry, backward, like pass, we call it as back propagation. Okay, you are doing something called back propagation. So that is what actually it is happening. So if you check here, first of all, I'm predicting something. It will give me the y hat. That means the prediction. I'm calculating the loss. Based on the loss, actually, I'm doing the backward. That means I'm doing the backward propagation. Okay, backward propagation. Okay, back propagation technique. So here I've already commented out. So once it is done, I'm also like printing the loss after 10 epoch. Okay, after 10 epoch, or let's say after 10 steps. Okay, I'm printing this particular loss, and the accuracy actually I'm getting from my model itself. Okay, and this is the logic to write. So if you check the documentation, they have also written like that only. So here is the yeah, so here is the code. Okay, they have also written like that only. So you have to also written like that. Okay, now let's define my training loop. So this is my training loop. Now you can understand like how the things is working inside the keras. Okay, I think in the keras actually I directly use that particular, let's say, model sequential layer. Okay, after that model.fit I was doing, right? But how everything is working in the backend? Okay, they have also written the code like that only. Okay, everything they have written in a Python code. Okay, they are also using, let's say, low level TensorFlow in the backend whenever I'm talking about keras, and they're handling in that way. Okay, so if you want to understand the keras API, how the things are working, so you can understand this particular PyTorch code and you will be automatically get the idea how the things are working. Okay, this is the idea. Okay, so similar wise, you have to mention for the testing loop. Okay, so let's say I want to also test my data. my model. So here is the testing loop I can use. Okay, this is the testing loop. Since a testing loop, I'm not doing anything. Again, I'm taking the data loader model and loss function, checking the size, getting the basis. Okay, then I'm just doing the model.evaluation because I want to perform the evaluation. Then here, if you see here, I'm just predicting. Okay, then I'm just just updating the test loss and the correct. That means the accuracy. And here I'm just printing one by one. And the same thing they are also suggesting in the documentation. Let me show you. Same thing they are also suggesting in the documentation. So here, if I show you the testing example, yeah, so they are doing the same thing only. Okay, if you check here, testing code. Okay, they are doing the same thing only. Yeah, I'll provide the code in the resources section. Okay, we'll get it from that particular dashboard. Okay, otherwise what I can do right now, I can also share this particular notebook link in the chat. And everything will get from the dashboard itself. Okay, the dashboard actually I showed you, computer vision hands-on. Please make sure you have enrolled for this particular course. And this is completely free. Okay, this is a community program. So this is the notebook link, guys. You can refer. Okay. Now let me also define the test loop. Yeah. So finally, I can start the training. So let's start the training. Start training. Okay, to start the training, first of all, I need to define the epoch. Okay, number of epochs you want to train. So let's train 10 epoch only. Okay. 10 epoch is not like very good epoch. You can set like higher epoch whenever you are training your actual model. Okay, I'm just showing you. That's why I've just set 10 epoch. And now I'll just start the training. So for 14 range. Okay. And inside that I'll process the epochs. Okay. Then I'll print the epoch also. So let's print the epoch so that I can track my epoch, how many epoch is going on and all. Okay. Then after that, I'll call my training loop. Okay. So train. Inside that, I'm calling this particular function called train. It will take the data loader model, loss function, and optimizer. Let's pass one by one. So first of all, it will take the train data loader, train underscore data loader. Okay. Then it will also take the model you have developed. It will also take the loss function, loss fn. Okay. It will also take the optimizer. So optimizer, optimizer. Okay. Then I will also define for my test loop. Test loop. So here I need to write test loop. So it should be test loader. So it will take the model and loss function optimizer I don't need to give because I don't need to perform the back propagation during testing. Okay. Now once it is done, it will also print a done. Okay. Once training is done, it will print done. It will print done. Now let me start the training and let me see how things are working. Now see, this is the loss and every epoch actually loss is decreasing. Okay. You can see loss is decreasing. That means my model is learning. Now epoch 2 is going on. Because in one epoch, actually, it is performing that many of step. Okay, this call is step per epoch, and I have defined 10 epoch. Okay, so it will complete till 10 epoch, and every epoch, if you see, loss is decreasing. And once this 3 epoch is done, it will show you the accuracy, final accuracy. So 61% accuracy and average loss you got 1.49. Okay, again you can see 63% accuracy, 64% accuracy. So loss should be close to 0. Okay, then your model will be good. 65% accuracy. Okay, so 10 epoch is going on and loss is close to 0 right now. Still it will learn, so you can increase the epoch to 20. Okay, you will see more accuracy will get. I got 70.7% accuracy. Average loss is 0.78. Okay, and my execution is done. Okay, that's how we can perform the training. Now what I have to do, training is completed. Now I can save this particular model. Okay, so how to save the model? So save. Okay, save model. To save the model, just write torch dot save. Okay, and here you just need to write model dot state dict. Okay, state dict. Okay, you have to save this particular model in a state dict format, and you have to give the name. Okay, name of the model. So I want to save as a model dot pth. Okay, that means PyTorch model. Pth is a PyTorch format. Okay, pth. Then once this saved, I will also print this model is saved. Model saved. Okay, model saved. Now let me also save this model. Now if I refresh, see model would be there. Now model is saved. Okay. Now if you want to load this particular model, how to load it? So it's like very simple, load model. So for this you have to first of all define the architecture. So model is equal to neural network. The neural network we have created. Okay. Then after that I need to load this particular model. So model dot load state load underscore state dict underscore state underscore dict. Okay, state dict. So here you just need to write torch. Okay, dot load, and I need to give the name of the model. So this is the model name. So copy path, and here I can define. Okay, so model dot pth. You can also give the name of the model. It will work. Yeah. So that's how I can load the model. Now see, all key match successfully. That means you have successfully loaded the model. Okay. Then now what I will do, I'll define my prediction classes. Okay, all the prediction classes actually I'm having. So prediction classes. So where you will get this particular prediction classes? From the Kaggle, I think I already showed you. So if I go to the Kaggle, so these are my prediction classes. I'll copy one by one. And here I'll try to arrange everything. Okay, so here I'm going to create a classes list. Because my model will give me actually number. Okay, that number I need to map. Okay, map with this particular category, and I want to return the category. That's why I'm just defining one classes. Okay, classes list. And inside the list, first of all, I will define t-shirt and top. So because it is coming at the 0 index, okay, that's why I'm keeping at the 0 index. Okay, and after that I need to keep this particular trouser. This is in 1 index. Okay, that's how you have to align the index. Then coming pullover. Okay, then coming dresses. Okay, then I think after dresses, coat is coming. Okay, after coat, sandal is coming. Then after sandal, shirt is coming. Then after shirt, sneaker is coming. Then after sneaker, bag is coming. Then after bag, this ankle boot is also coming. Okay, so these are the classes. Now I can delete everything. Okay, now if I execute and check the length of this particular classes, you'll see it's a 10 classes only. So it should be classes. 10 classes. Okay, we are having in this particular example. Now what I will do, I'll just write the prediction code. Okay, but before that, I just need to do the model.eval. I want to perform the evaluation. Okay, then what I will do, I'll first of all take one test data. Okay, so let's take one test data. So I'll load this particular test data. So it is available inside my test data, test underscore data. Okay, I'll take the first example. So 0, 0. Okay, now if I show you this particular X, so this is my image. Okay, this is my image. Okay, this is my image. Custom it. Yeah. Now I also need the label, okay, like the actual label of this particular image. So here I can store it in the Y, and this thing I can load from here. So test data. Okay, I will take the label. Okay, label, it is available inside one index. Okay, now if I also print the Y, I think you can also see the Y. Okay, Y is also there, I think, somewhere. Let's only print the Y and see. Okay, Y is 9. 9 means it's a ankle boot. Okay, so here I've already defined it's ankle boot 9. If you see index 9, it's ankle boot. Okay, let's see whether my model is able to predict ankle boot or not. Okay. Okay, so if it is ankle boot, if it is predicting perfectly, that means my model has learned. Okay, because I got more than 70% accuracy. Okay, so it should predict correctly. So let's test it. So what I can do right now, I'll be using the model. So first of all, you have to write with torch, because I don't know, I don't want to perform gradient. Okay, on top of this particular prediction code. So that's why you need to define no grad, no underscore grad, no gradient. Okay, I don't want to perform any gradient operation. And inside that I have my model, and I'll pass my x data, and this model will give me prediction. So pred, I'll store it. Then after that, what I have to do, I have to uh, I have to map with the classes. Okay, the classes actually I have developed. Okay, let's say after prediction, this model will return the number. Okay, that number I need to map with the classes. Okay, how to do it? So that is how actually you can do it. Let me show you. Yeah, so here I already written. So whatever prediction actually I'm getting, I'm doing the argmax, because it will give me the probability score. Okay, I think you remember in the softmax activation function, it will give you the probability score. That's probability score actually I'm doing the argmax. It will give me the number right now. Okay, let's say it's a 0, 1 or 2 or 9. So this particular number I'll map with the classes actually I've developed. Now let's say if your model is let's say predicting 9. Okay, so if your model is predicting 9, so if I pass 9 in the classes, so what will happen? Okay, if I pass 9 in the classes, so it will print ankle boot. So it will print ankle boot. Okay, let's say your model is giving 8, so it will give me bag. That's how it will give me the index. Okay, that index actually I'm just mapping with this particular classes, and it will give you that particular value. Okay, from the list itself. That is what actually I'm doing here. Okay, then after that, I'm just also printing my actual prediction and the correct prediction. That means the prediction I got from my model. Okay, so both actually I'm printing one by one. Now let's see whether it is able to predict or not. So if I execute, now see, predicted ankle boot actually is also ankle boot. That means my model is predicting perfectly, because as I already showed you, the data actually I loaded here, testing data, it is 9. That means it's ankle boot, and your model is also predicting ankle boot. Okay, that is 9. That means this model is working fine. Okay, yeah. Now if you want to visualize all the images, so you can also do it. So let me show you. So this is the code. With the help of matplotlib, we can visualize some sample of the images. Okay, like how it will look like. See, so this is the ankle boot, this is the level 0, that means t-shirt. Then I don't know, I think this is a top. Then no, not this is a top, I think it's a, what it can be, it's a dress, coat, sandal, trouser. Maybe it's a dress, I think, mostly. Okay, then shoes we are having. Yeah, so that's actually you can visualize the image, and these images are actually BGB, you can say grayscale image. That's why it's looking like that. Okay, it's a one channel image. We can also work with color image. Okay, now let me also give you the guidance, like where you can learn the custom data, that means color image. Okay, as well with the pre-trained model. So for this actually you can refer Kaggle. Okay, so Kaggle is having different data. So let's say if I search for cat dog, okay, cat dog classification, okay, using PyTorch. Kaggle. So Kaggle is having lots of notebooks, so you can refer this particular notebook. So cat dog classification with PyTorch. If I open it up, so they have different notebook actually, and they are working with this cat dog example. The example I showed you, okay, yesterday. Now see guys, they're also loading the torch, setting the device. After that, loading the image. Okay, cat.image. Then they are define the directory of the image. Then they are printing some of the image. Okay, like how this images look like. After that, they are resizing the image. Okay, as you can see. Then they are defining the this one data transformation, because yesterday I was also telling about data transformation. You have to perform some augmentation, then resizing this particular image, okay, with respect to the model input you will be having. So everything they are performing here, and they are also loading the data loader. Okay, so as you can see, they are also performing the data loader to load the example. Okay, see data loader. But before performing the data loader, you have to load the data from the folder. Okay, the folder actually you are having. So for this, you have to use this dataset.image folder, and here you have to give the directory, like where you have this particular image. After that, you will be loading. Then what you have to do, we have to define all the classes name and all. Then this is the final tensor actually will get. Okay, and if you want to visualize, you can also visualize. Now you have to define the data loader. Okay, with the batch size. Okay, with the batch size, you have to load it. Then after that, they will be defining the model architecture. After performing compose and loading the image, data loader. Now they are getting the CNN classifier. Okay, and this is the CNN architecture they have developed. Okay, this is the custom architecture they are using. But you can also search for, let's say I want to use pretrained model, let's say VG16 or let's say ResNet 15. You can search over Kaggle, you will get that particular notebook also. Okay, that's how you can learn. Different notebook you can explore and you can learn. Okay, then after that they are training the same thing. They return the training loop and testing loop. Okay, see this is the training loop and this is the testing loop. Okay, the way actually I have written. Then after that they are doing the epoch. Okay, training the model. Then after that they are testing the model also. Okay, then plot the graphs and all, like how many accuracy they are getting and all, the losses and all. Then after that they are taking one image and doing the prediction. Okay, doing the prediction. So if you just go through this particular example, you will get each and every idea how the things are working. So what I will do, I'll add this particular notebook link in the notebook I have shared with you, so that you can get a reference later on. With custom data. So Kaggle is the best platform to explore, guys. So not only this particular notebook. So if I go back, it is having so many notebook. Okay, if I go to the data, cat dog classification, PyTorch, it is having lots of notebook experiment. Let me show you dataset. Cat dog. Not only cat dog, you can take any kinds of data, no issue. Cat and dog. If I go to the codes, here you can search PyTorch implementation. Okay, see PyTorch cat and dog classification with ResNet 50. Okay, see this is the transfer learning approach. Okay, you can refer. Now if I open this particular notebook, now see the same step they are performing as I already showed you, but when they're loading the model, they're using ResNet 50. See, that's how you have to load the model. Models.ResNet 50 pre10 is equal to true device you have to load. Then after that, you have to define the params is equal to gradient false, because you want to take the custom architecture. Yesterday I was discussing, I think. So you'll be dropping this particular dense layer and you will be freezing these at the weight. Okay, that means the convolutional layer weights you will be freezing. Okay, so that's how actually they are doing in the ResNet 50. Then the training loop, after that the testing loop, and the training is happening. Okay, then confusion matrix and all. Yeah, so I can also give you this particular notebook reference so that you can learn the pre-trained model also. Okay, now guys, if you have any query, you can ask me. And next class actually will be exploring this thing actually. Next class I think mostly will be start with the object detection. Okay, because image classification wise I think you got the idea. Okay, how to perform image classification and all, right, with the help of PyTorch as well as the TensorFlow, both I have showed you. Okay, now you can use any of them and you can decide which framework you'll be using. If you're using PyTorch implementation, you have to understand the low level programming. If you want to use, let's say, Keras, everything is at a high level, you have to import and use it. So which is like more easier to you guys to understand? Let me know. If you have attended my previous session, maybe you can compare. Okay, which code is like more suitable for you? Okay. Okay, so please try to practice. Okay, once you practice from your side, everything would be clear. And the reference actually I have given you, try to also go with this particular notebook and try to understand how we can create the custom architecture, CNN architecture, either how we can load the pre-trained model. Okay, both I have showed you. Yeah. Yeah, both are equally approachable, but again, it's your choice which one you'll be using whenever you are implementing any kinds of projects. Okay. Yeah. And we have already done lots of end-to-end projects in our YouTube channel also. If you go to the playlist, okay, we have used TensorFlow, PyTorch, everything. Okay. So end-to-end DL project implementation, end-to-end NLP project implementation. You can also refer those are the implementation. Okay, if you want to learn how we can implement our end-to-end projects. Okay, because here everything I'm showing you is a notebook experiment because this is a hands-on session. Okay, I'm taking. So I'm not going to implement end-to-end projects. Okay, so definitely if you want to learn end-to-end projects, you can refer our previous session. Okay, we have already taken. I have to integrate RAG in technique with the transformer. I made the transformer and generated the code. Please suggest. Yeah, so RAG already I took one tutorial, sorry, session. So here you can check it out. So end-to-end DL implementation. Yeah, so here full playlist. So here I already discussed end-to-end RAG application, RAG implementation using Bedrock. Okay, instead of Bedrock, you can use the model. Okay, you want to use. Okay, you can refer this particular tutorial. Okay, so yes, guys, this is all from this session. Actually, I hope you like this particular session. So let's connect in our next class, okay, and try to explore a new topic. So thank you, guys, everyone. So take care. Bye. So today actually we'll be learning about this particular object detection on our custom data. So as of now, we have seen how we can perform image classification tasks with the help of TensorFlow and PyTorch. Okay, and I have shown you different let's say example. I also used my custom data there. Okay, and I already did that particular transfer learning approach, and I already created that particular notebook and all right. So in this particular session, we'll be learning this particular object detection. I think you already know what is object detection. I already given you that particular idea, the difference between classification detection and image segmentation, okay, as well as the object tracking. So here we'll be identifying that particular objects in a actually image or in a video you can talk about. Okay, let's say you can consider any kinds of object. It can be smartphone, it can be your hand gesture and all, everything you can consider okay, as an object in this particular you can say project. So I'll use one particular data set. The data set name is actually sign language data. Okay, I'm already having this particular data set right now. But if you want to, let's say, build on top of any other data set, you are free to do it. I'll tell you why actually we'll get this kinds of data set. Okay, I mean, it is already annotated data set. But if it is not annotated, like how we can also perform the custom annotation and all, everything I'm going to discuss in this particular video. Okay, so hope you will be watching this particular video till the end, and I'm expecting if you watch till the end, so your most of the doubt would be clear, and at the end you will be able to train any kinds of object detection model on top of your custom data. Okay, so this is the entire idea. Now before starting with the session, so first of all let me show you the dashboard. So this is the dashboard, guys, computer vision hands-on. If you have already enrolled for this particular course, and this is completely free. Now if I open it up, so see, all the resources, all the materials have been already updated, okay, in the dashboard itself, as you can see. So now if I go to the resources section as well, see, resources is also updated. Now if you're looking for these kinds of resources and videos link and all, so you can enroll this particular course. Okay, so go to the iNeuron website, even it is already available in the video description. From there also you will get this particular link. Okay, so make sure you have enrolled for this particular course, and you will get all the materials, all the video from this particular dashboard itself. Okay, yeah, all right. So first of all, let me give you the idea. Whenever you are performing, let's say, this kinds of object detection task, what you have to perform, okay, at the very first stage. Okay, so today actually I'm going to do object detection. Okay, object detection. on custom data. Custom data. So whenever you are doing this kinds of object detection, so first of all, you have to collect the data. Okay, collect data. So it should be based on the task you want to perform. Okay, you want to perform. Now here I already told you I'm going to use sign language data because I'm going to detect the sign language. Let's say if I show any kinds of sign activity, so it should detect that particular let's say gesture, okay, and it will tell me what kinds of activity I'm trying to actually show. Okay, so you can use any kinds of, let's say, data here. You can do, let's say, vehicle detection, smartphone detection, okay, then path hole detection, anything you can perform. There are so many object detection tasks actually will get over the internet. So the first thing, you have to collect the data based on the task you want to perform. So here I'm going to perform something called sign, okay, sign language, okay, sign language detection. So here I need this kinds of sign language related data. Okay, I'll show you the data, how this data will look like. So I have already collected this particular data. See guys, this is the data of the sign language. Let me just see, this is the data of the sign language. So here you can see I am having different sign gesture. Okay, so let's say if I'm doing like that, that means I'm trying to say hello. Okay, see, this is the hello gesture. Now hello related image actually I'm having. Okay, so here if you see I'm having hello related image. Then I'm also having this kinds of let's say you want to tell I love you. Okay, so you want to show this particular gesture like that. So this is the image related I love you. Now you are also having related this particular no. Okay, let's say if you're doing like that, so you are trying to say no. So that's actually I'm having 6 different level. Okay, 6 different level, as you can see, like thanks, yes, and hello. Okay, so these are the things actually I'm having. Now you can consider like as much as sign gesture you can. So there are actually website you can find. So if I search for American, okay, American sign language, okay, so here you will see different sign language is there, so you can collect the images with respect to that only. But again, it varies, okay, based on the countries. Let's say if you are building this particular application inside the India, so you will see Indian sign language would be a little bit different, okay, apart from your American sign language. But in this particular like a picture, you can see I have collected the American sign language, okay, gesture. But whenever you are talking about India or let's say other countries, so there actually this gesture will be changing. So you need to take care. These are the part as well. See, so this is like I love you. Okay, so you have different gesture as you can see. Okay, now I think they have also is the sign language what did the original? Yeah, so I saw that there is actually a website. So it is having all different actually sign gesture. Let me show you. Yeah, so sign language, I think here I will get everything. See here. So by referring this particular website, I collected this particular data. Okay, let me show you. Let's say hello. See, this is the hello. Okay, this is the hello one. Now this is the thank you. Okay, this is the nice to meet you. Okay, then see you are having different things. Okay, different things you can see here. Even you can also write here. It will show you the gesture with respect to that. Even they are also having their YouTube video. So by referring the YouTube video, also you can collect these kinds of images. Okay. So yeah, so this is the website actually you can refer. So the website name is www.liveprint.com. Okay, you can refer this particular website if you want to collect these kinds of American sign language detection. Okay, images. I had made a project on a post detection and square parallel counter app features in the mail. Wait, how can I upgrade that projects? Okay, so you created with the help of this particular machine learning, right? So yes, you can like convert this particular projects with a deep learning approach. So you can, I think you have done the post detection. Okay, so post detection can be done with the help of YOLO V5. Okay, today I'm going to show you this particular YOLO V5. Okay, so YOLO V5, I think post detection supports or not. Let me see, guys. See, instead of YOLO V5, what you can do, you can use something called detect on true. Okay, detect on true. So this is another amazing framework from Facebook. So with the help of detect on 2, you can perform this object detection then segmentation as well as post detection. See, post estimation, post detection, anything you can perform. So I will suggest go with this particular detector too. So this is like very powerful, you can say framework. Even it is having a model view with a different model architecture. Let me show you. So this is, let's say, this is the object detection baseline. This is instance segmentation baseline. This is key point detection baseline. This is panoptic segmentation baseline, and it is also having post detection baseline also. Okay, so you can use this particular framework. Okay, if you want to create that particular application. Even I have this particular things actually in the syllabus. So in this particular series, I will be also covering how we can use this particular detector tool. Okay, on top of the custom data. Yeah. All right. So data collection, I think you have to do. I think you saw that how we can collect the data set. So it is already available over the internet. So first of all, try to see over the internet whether this kinds of data set is available or not. So let's say if you want to like collect this kinds of sign language data. So what you can do, you can search for sign language. Okay. Data Kaggle. So Kaggle is also having this kinds of data. So this is MNIST data, but I don't want the MNIST data. I want American Sign Language finger splitting. Okay, let's see this particular data. So you have to find, okay, based on your requirement, you have to see based on your requirement, you can download the data. Okay, so you can also refer this particular data. Even there is another website called RoboFlow. Okay, let me show you this particular website, RoboFlow. So RoboFlow is a amazing platform actually they have developed, and it can support all the, let's say, computer vision tasks you'll be performing in future and all. Okay, so you can create an account in the RoboFlow. So I already have the account, so let me log into the account. So here actually we can get the data also. You can also train your model. You can also annotate your data. Everything can be done here. Okay, I'll also show you the data annotation part with the help of RoboFlow in this particular session today. Okay, see guys, this is the website of this particular RoboFlow. Now RoboFlow having one particular actually a platform called the universe. Okay, so if I go to the universe, so universe actually will get all difference, all kinds of actually data. Okay, whether it's related to object detection, whether it's related to image classification, or let's instance segmentation. Okay, anything data actually will get here. So here you can see it is having object detection, classification, instance segmentation, key point detection, and semantic segmentation. Okay, and it supports all the model YOLO V9, YOLO NAS, okay, V8, V5 detector, all the model it supports already. Okay, so you can use this particular platform. Now let's say you want this particular sign language data. Okay, so you can search for this particular sign language data. So sign language, if I search here, now it will search over the entire universe. See, these are the sign language data actually it is also having. So based on your requirement, you can select the data. Okay, let's say I want to select this particular data. I will click here. Now you can directly download this particular data. Okay, for this, what you have to do, there is a like button called download dataset. Now if I click on the download dataset, now you can directly download this particular dataset as a zip file. Okay, see, download as a zip file. Now you have to select the format. Okay, like which format you want to download this particular data. So you have to select the format based on the model you are selecting. Let's say today I will be using YOLO V5. Okay, YOLO V5 model. So for this, I will be selecting this YOLO V5 PyTorch. So this is the format you have to select. Then you have to download it. Okay, if you just click on continue, it will start download that particular data. Okay, but I'm not going to download this particular data because I'm having my own data. That particular data will also show you the annotation, and I'll tell you how we can download this particular data and how we can use. Okay, whenever we'll be doing the fine tuning of that particular model. Fine. So it's not like that RoboFlow is having lots of data. Okay, it is having around, as you can see, see that many of data set actually it is having. Okay, and 350 million images actually you are having, and see, this is the number of the fine tuning models are available on the RoboFlow platform. So it's a cool actually website you can refer. Fine. Okay, so that's how we can collect a different data. So after collecting the data, you have to prepare the data. Prepare the data. So whenever I'm talking about prepare the data, that means you have to perform something called data annotation. Data annotation. Okay, data annotation means, let's say whenever you are doing this kinds of object detection. Okay, so let's say this is my image. So let's say here I'm having one object. Let's say I'm having one cat. Let's say this is the cat. Okay, so let's say you want to detect this particular cat. First of all, you have to annotate this particular object. Okay, let's say I'll create a bounding box. Okay, bounding box, and I will assign one label. Let's say this is a cat. Okay, so that's how actually I have to teach my model. Okay, before passing into the raw image to my model, first of all, I have to teach my model. That means this particular image, okay, this particular image is the X data. That means X input, and this particular label you have assigned. Okay, that means this annotation you have done. That means this particular bounding box, this is your Y. Okay, now let's say this is your model. So you will give this particular X data as well as the Y data. That means the label, that means the bounding box annotation, and your model will predict something. Okay, your model will predict something. It will see with the particular original Y you are having. With respect to that, it will calculate the loss. Okay, based on the loss, it will perform back propagation. Okay, back propagation to the CNN. Okay, convolutional neural network. That's how actually it will learn. Okay, it will learn that particular object. Okay, whether it's a cat, whether it's a dog, or whether it's any kinds of object. Okay, present in that particular image. Okay, so this is the idea. So that's why data annotation part is super important task. Okay, in the field of object detection, or whether it's a image classification wise, I already told you we have to maintain the folder structure, and you have to also perform the data annotation in the segmentation task as well. Okay, there we perform polygon annotation. I'll tell you what is polygon annotation as well. Okay, yeah, fine. So once my data preparation is also ready, now what I have to do, I have to prepare my model. Okay, for the training. So once model preparation is also done, I'll start the training. Start training. Okay, so once training is completed, then what I have to do, I have to evaluate that particular model. Evaluate. Okay, model. Once evaluation is done, I'll be do the inference. Okay, inference on test data. Okay, then finally you can create a application. Okay, application on real time you can also create. Second step means you have to prepare the dataset. You have to perform the data annotation. Okay, Lincoln. I'll tell you the data annotation how it can be done. So we will be using RoboFlow to do the data annotation. Okay, because I am having the raw images. See, currently I'm having the raw images. So this image, if I give to my model, so my model will get confused what kinds of image I'm providing. Okay, because I want to detect this particular object. Okay, this particular hand gesture. But my model doesn't know I want to detect this particular hand gesture. So before passing this particular image to my model, I have to annotate this particular part. Okay, then I will tell my model this is the annotation. This is the actually like point from this particular image I want to detect. Okay, so this is called data annotation. Yeah. So first of all, let's see the data annotation, how it can be done. Okay, so I'm going to use this particular platform called RoboFlow. So I think I already showed you. So you should have one RoboFlow actually account. Okay, so make sure you create a one RoboFlow account. So there, what you have to do, you have to create a new project. Okay, so let's create a new project. So you can give the name. So let's say this is object. Okay, detection demo live. Okay, so this is the name. And here you have to give the annotation group. So if you're not giving the annotation group, it's completely fine, you can skip, but let's give one annotation group. Let's say how many images we are having 6 different levels. Okay, hello, then I love you, no, please, then thanks, and yes. Okay, so these are the level actually we are having, so we can give only hello here. Okay, hello. Now you have to select the task you want to perform. So I already told you it supports actually different tasks. You can also perform classification, instance segmentation, and key point detection. Okay, so I'm doing here object detection task. So first of all, I need to select this particular object detection. Okay, this particular task. Okay, it can also perform different tasks. Semantic segmentation you can also perform. So let's select this object detection. Then I'll create this particular project. Okay. Okay, so hello is already used in this particular projects. Okay, so what I can do, I'll go back. First of all, I have to remove some of the project. Okay, because there actually I also already used this particular hello gesture. Okay, that's why it's coming like that. So let me remove them. So I'll delete this particular project. Then I'll also delete this particular project. Okay, sign related, I think I don't have anything. Okay, now I think I can create a new project. Give the name, let's say object detection demo live. Annotation group, let's say hello. And select the object detection one, and let's create the public project. Now see guys, my project has been created. Now you have to drag and drop your image here. Okay, you can either select the folder, I can select the file. Okay, but I'll drag and drop all the images. So I'll press Ctrl A. Okay, and I'll just drag and drop here. So I'm having 30 images here. Okay, 30 images I'm having in this particular folder. But whenever you are training your own model, okay, actual, let's say whenever you want to train your, let's say actual model, that time you should have more data. Okay, 30 images won't be working. I'm also having, see, I already have the data. It is already annotated for me. So let me show you. See, in the train folder, I'm having lots of images. Okay, I'll also share this particular images with you so that you can try. But try to collect your own images, okay, to get a better accuracy, because this is my images. Fine. Yeah. So now I already uploaded the data. Now what I have to do, I have to click on save and continue. Okay, now I will start labeling manually. So you can also perform auto labeling. You can also hire someone from the RoboFlow team. So you have to pay for them actually. If you want to hire them, they will do the data annotation for you. So you can also start RoboFlow labeling. So here you can hire someone. You can also manually label your own data. Okay, so I'll be manualing my own data because I don't want to take the premium subscription. Okay, so I'll be going with the manual labeling here. So I'll click here, manual labeling. Now here I will assign the image. Now see guys, these are the image, and I'll start the annotating. Okay, start the annotation. Okay, now what I have to do, see, I have to annotate this particular object. Okay, let's say I want to detect this particular part. Okay, this is hello. Okay, hello guys, sir. So for this, first of all, select the bounding box tool. Okay, right hand side you will see bounding box tool. So I'll select this particular bounding box tool. Now here I will start the annotation. See, that's how you have to select this particular part. And the more correctly you will be selecting, the more, like you can see, your model will be learning. Okay, in a good way. So now this is hello. I'll just click on save. Okay, it's done. Now I'll go to the next image. Now again, this is hello. I'll annotate. I'll click on save, enter. Again, I'll go to the next image. This is also hello. I'll save, enter. Then again, I'll take the next image. This is also hello. That's how you have to complete for all the images actually you are having. Okay, so let's do it quickly. Now see, I love you is coming. So I'll select this particular part. And this is I love you right now. Okay, so you have to write I love you. I love you. Okay, I love you. So save, enter. Now again, I'll go to the next one. So this is also I love you. Okay, the next one. This is also I love you. Next one, this is also I love you. So I'm doing quickly. That's why you can see this annotation is not good. But whenever you are doing your own annotation, make sure you are doing in a good way. Okay, because I have to complete for all the images, that then I can show you like how to save and all. Okay, now this is for no actually. So this is no. Now this is please. You have to write please here. Yes, annotation need to done manually for each image. Okay, that's why annotation is like very costly task. But there are some automation actually tools nowadays. You can see it can perform auto annotation, but again you have to manually observe that. Okay, in my YouTube channel I already created one video. Let me show you. how to perform auto image annotation with the help of this particular tool. You can refer this particular video, I think, if you want to learn about auto annotation. So here is the auto image annotation. Okay, auto distill. So this tool actually you can use. This is also one tool RoboFlow has developed. Okay, so you can refer this particular video. So this is my YouTube channel. Okay, so I think done for please. Now it also complete. Now this is thank you. Okay, so this is for thank you gesture. Now this is yes. Yeah, almost done. I'm having only 2 images. Okay, completed. See, all the 28 images I have completed the annotation. Annotation is about labeling the images and setting the bounding box right. Yeah, so you are like correct. So here we are you can say locating that particular object. Okay, I want to detect. I'm teaching my model. Okay, so this is the object you want to detect. Okay, my model will learn. Then if I give any test data, then it will able to identify that particular object. Okay, I want to detect. Now once it is done, I'll go back. Now see, all the image has been annotated. Now I'll add all the image to the dataset. Now it will automatically perform the 10 test split for you. You don't need to manually perform it. Okay, now I'll click on the add image. All right, now I'll create a new version. If you want to perform any processing, okay, you can perform. Otherwise, I will continue. You can also perform the augmentation, data augmentation. If you want to perform, you can also do it. Otherwise, you can continue. Okay, now let's create the data. Okay, now dataset is ready. Now you can train with RoboFlow as well. RoboFlow having their own training platform, but again, you have to take their premium subscription. But by default, if you have created free account, you will get some of the credits. So I have 2 credit left, so I'm not going to train with the RoboFlow. I'll do the custom training. Okay, so here I'm going to export the dataset for this. Okay, now you need to select the format. So I already told you I'm going to use YOLO V5. Okay, YOLO V5. Like you can say model. Okay, so that's why I'm going to use this YOLO V5 PyTorch. Okay, this is the format you have to select. Now you can download this particular data as a zip file. Okay, now I'll click. Now see, it is downloading the data as a zip file. Okay, now it has downloaded. Now if I open up my folder, download folder, now if I just unzip this particular folder, you will see my data is ready. So inside that, see, this is the data. Now you can also remove this particular readme and this readme file. It's not required. Now this should be the folder structure. Okay, you can also remove this particular test and valid, no issue. Okay, but this is the final folder structure. So inside images, I'm having all the images. Okay, and inside labels, actually I'm having all the annotation. Okay, see, these are the annotation. Let me open it up. So these are the annotation. Okay, so these are the coordinate point of that particular object. Okay, you have annotated, and this is the label of that particular object. Okay, now if you want to see the object names and their order, you can also see that. So there is another file it has created called data.yaml. Okay, let me open this particular data.yaml. See, this is the training testing image location. Number of classes you are having, we are having 6 classes, and all the 6 classes name. Okay, hello, I love you, no, please, thank, and yes. That means whenever it is predicting 0, that means it is predicting hello, because it is following the index order. Whenever it is predicting 1, that means it is telling I love you. Okay, then 2, 3, 4, 5. That's how. Okay, this is the order. You can also remove this part, it's not required. Okay, so only this part is required. Okay, now let me close it. So this should be the folder structure. Now what you have to do, you have to zip this particular file. Okay, you have to make a zip of this particular file and you have to upload inside a GitHub. Okay, let me show you. I already uploaded this data in my GitHub. You can also read the data from the GitHub. You can directly like upload in your, you can say Google Colab. Okay, anything you can do, but I already uploaded this data inside my GitHub because so that I can use later on also. Okay, even you can download from my GitHub also. So let's say I've uploaded. Now there is a repository I'm having called branching tutorial. Inside that I'm having this particular data. So sign language zip file. See, this is the data I've already uploaded. Okay, inside my GitHub repository. Now, if you want to get this particular link, just right click on the view raw and copy the link address. Okay, and this is the complete link of the data. Okay, now if you hit this particular URL, it will start the downloading of that particular data. Okay, so this link I'll be utilizing, and I will download this particular data and I'll be training my model on top of it. Okay, yeah. So this is the data annotation part and data preparation part. Now we have completed these are the things. Now we can prepare the model, okay, for the training. Okay, so I already told you I'm going to use something called YOLO V5. So let me show you YOLO V5 official repository. Let me close these at the tab. I think it's not required. So YOLO V5, if you search over Google, so this is the official GitHub you will get, and this is for Alterytics. Okay, Alterytics like team has developed this particular YOLO V5 model, and this is not only model, this is also a framework. Okay, see, they have also created a framework. They have also created a GitHub repo on top of it. Now if you want to use this particular YOLO V5, you have to clone this particular repo and you have to set up this particular repo, and you can like do any kinds of task here. Okay, now see, you can read about this particular YOLO V5. YOLO V5 is a world's most loved vision AI, representing Alterytics open source research and for vision AI methods and encompassing development. Okay, so this is the state of the art model. You can see the model comparison. So YOLO is having different model variant. YOLO V5 is there, 6 is there, 7 is there, 8 is there, 9 is there. I'll show you all of them, okay, because this is in the pipeline. So today I'm showing YOLO V5, tomorrow I'll show V6, then 7, 8, and so on. Okay, all the YOLO model I'm going to show you how we can use it. Okay, now they have also given the tutorial notebook. They have also given the installation guideline, how we can install and all, everything they have given. Now left below you will see the model view. Okay, this is the model checkpoint. So it is having different model variant. As you can see, YOLO V5N, that is the nano model. This is the smallest model. This is the medium model. This is the large model. Okay, this is the X large model. That's how if you go ahead, you will see model size is increasing as well as the inference time is also increasing. Now let's say I want to get a quick inference. Okay, let's say I want to get a faster inference and I want to take a smaller model. That time I will go with these are the model: nano, small, and medium model. Now if you want to take a, let's say if you want to achieve a good accuracy, okay, that time you can go with a bigger model, but their inference time would be increased. Okay, make sure you are like handling these are the thing. Okay, whenever you are doing any kinds of projects. In case we are doing augmentation, then science gesture may get different. Let's say if the hello, no, it will apply some of the, let's say, augmentation technique. Let's say it will change the image, let's say brightness, image contrast. Okay, image, let's say, I mean flip. So that's how actually it will perform the data augmentation. Okay, sometimes it will do the cropping. Okay, it will zoom a little bit, it will zoom out a little bit. Okay, this is the data augmentation task. So in this particular, you can say experiment, I'm going to use this particular model, YOLO V5S model. Okay, I'll tell you how to download this particular model. So you don't need to manually download. Whenever you will be like, let's say, hitting the training command, at that time you only just need to define the name. It will automatically get this particular model. Okay, then I have to change some of the configuration of that particular model. I'll tell you how to do it. All right, so now let's open up that particular notebook. So I already implemented one notebook for you. See, this is the notebook. So in this particular notebook, I have already like written the code, how we are gonna do the custom training and all. Everything is there. I'll share this particular code with you, so you can also try with different data. Okay, so you don't need to perform with the signed data. You can also perform with the any other data set. Only the changes you have to do, I'll tell you what are the changes you have to do. Okay, and you will get this particular resources in the dashboard itself. And also let me share you this particular notebook link in the chat. If you want to try with me right now, I'll copy the link and here I'm going to paste it. All right. So the first thing you have to select the GPU. Okay. So let's select the GPU. So change runtime type. So I already selected the GPU. Now click on save. Now I'll connect this particular notebook. Okay, my notebook is connected. The first thing I have to clone this particular YOLO V5 repository. Okay, this repository I have to clone. So for this, just click on the code and copy this particular link address and try to paste it here. Okay, git clone I'm doing. And after that, I'm just going inside this particular folder called YOLO V5. Okay, then I will able to see these are the folders and file. Okay, let me clone and let me show you. See, cloning done. Now if I refresh left hand side, you will see this YOLO V5 has been cloned and all the files and folder I can see right now. Okay. Now what I have to do, I have to install this particular requirements. Okay. All the, let's say, requirement packages I have to install. So these are the requirement packages actually you have to install. Okay. Now to install this particular requirements. So first of all, let me change the directory. Check the directory currently. See, I'm inside YOLO V5. That means I'm inside this particular folder. Now I can easily access this particular requirements and I can install. See, this is the command to install the requirements. Okay. After that, I'm just importing some of the library. I'm testing the version of it. Okay. Now let me install and let me check. So once installation is completed, you will be able to see the torch version and CUDA version actually you are using here. Is it available with TensorFlow? No. Okay, if you are using YOLO V5, you have to use PyTorch. Because the repository they have created, they are using PyTorch here. Okay, if you see everywhere, they're using PyTorch, not a TensorFlow. Now, see, installation is completed. Now, let me check the directory again. So I'm inside YOLO V5. Now, what I have to do, I have to download this particular data. Okay, my custom data. Now, I already showed you how to collect this particular URL. Okay, I already uploaded my data in my GitHub. So this is the GitHub URL link. Okay, this is my data link. Okay, this is the data link. And I'm using curl command. Okay, curl command. Curl is a Linux command. With the help of curl command, you can download anything. Okay, from a URL. So here is the command I'm writing. But before that, I'm going inside the content directory. Okay, and inside that, I'm just downloading this particular zip file. Okay, then I'm unzipping it. Then I'm removing that particular zip file. Okay, now let me show you my data. So it's done. Now if I refresh, now see it has downloaded my data and all the folders and file I can see. See, I am having all the images. Also, I'm having the labels. Okay, as well as this particular data.yaml. Okay, as you can see. Now you can open up any image also here. So let's open up one image. So this is the hello image. Okay, this is the hello image. Okay. Now we are successfully download the data. Okay, you can also manually upload here. You can also manually unzip it. It's up to you. But I have kept as a link so that if you are using my notebook, you can directly get the data. Okay, from this particular URL. Okay, and whenever you will be, let's say, creating end-to-end application, that time actually you will be downloading the data from a URL or let's say from a S3 bucket or GCP bucket. Anywhere you can download the data. So I already took couple of sessions, okay, on the end-to-end implementation. Let me show you. If I go to the YouTube iNeuron channel, so here if you go to the playlist, so here I already took lots of end-to-end projects. Okay, end-to-end object detection project implementation. You can refer this particular playlist. Okay, there I already showed you how to perform the data ingestion. Okay, how to perform the data then data validation, model trainer, model pusher, everything I have written as a component. Even I already showed you Jenkins CI/CD deployment. Okay, there. Okay, you can refer this particular playlist if you want to learn about end-to-end implementation, okay, of any kinds of object detection project. Then you can refer this particular you can say playlist. Fine. Okay, now I have to test this particular data.yaml. Like, let's say what are the content actually I'm inside. I have inside this particular data.yaml. So for this, you can execute one particular command called cat. Okay, cat is a Linux command. If you're like executing cat command on top of any kinds of file, it will show you the content inside that particular file. Okay, now if I open this particular file, so inside that particular file, I'm having these are the content. Okay, now if I want to see that on the Jupyter notebook, I can execute this particular cat command. Okay, cat data.yaml. Now you see it is printing all that information inside that particular file. Okay, now I have to define the model configuration and architecture. Okay, for this, see by default, if you see inside YOLO V5, I'm having the models. Okay, models, and these are the model configuration. Okay, let's say I'll be using this particular model YOLO V5 s.yaml model. If I open this particular model, see this is the model architecture and this is the model backbone. But here if you see NC, that means number of classes is equal to 80. Why it is 80? Because it is trained with, okay, it is trained with something called Coco data. Okay, Coco data set. And Coco is a benchmark data set. Okay, benchmark data for object detection. Okay, for object detection. So you can search about Coco data over the internet. And Coco is having 80 number of classes. Okay, 80 number of classes. So this is the Coco website, and here you can see the Coco dataset. Okay, so these are the object actually it is having. So you can also visit their website and you can also see the dataset. So actually it is having 80 number of classes. Okay, 80 number of classes. But in this particular example, I'm having only 6 classes. Okay, let me show you. I'm having only 6 classes. See, NC parameter is equal to 6. That means these are the 6 classes I'm having. Now what I have to do, first of all, I have to change this particular model configuration, okay, based on our task, our requirement. Okay, because here we are doing the transfer learning approach. We're picking up that particular pre-trained model. On top of that, we are just training our own data. The way actually perform as our image classification task as well. I think you remember we just downloaded the VG16 model, and at the last layer, I think I saw that it was having thousands neuron. Okay, thousands layer. Thousands neuron. Okay, thousands like number of classes, because it was using ImageNet dataset. But here, if you are using object detection model, and object detection model is trained with Coco dataset, and Coco dataset having 80 number of classes, and that number of classes I have to change with my own classes, which is nothing but 6. Okay, so this 6 parameter I have to set there. So how to set it? So first of all, I'll be extracting this particular number of classes from the data.yaml file. Okay, for this I am just using YAML package and I'm loading this particular data.yaml. I'm extracting this particular number of classes. Okay, now see it is 6. Okay, it is right now it is 6. Okay, now what I have to do, I'll load this particular file YOLO V5 okay, and I want to see the content inside that. Now see, it is having 80 number of classes. Now I have to change this particular 80 number of classes. Okay, how to do it? So first of all, copy all the content. Okay, copy all the content inside that. Copy everything. Okay, then execute this particular magic cell. Okay, then after that, paste everything here. The content you have copied from that particular file, paste everything here. And instead of writing the number of classes is equal to 80, just give number of classes. Okay, this particular variable, because I already collected this number of classes from here. Okay, now this variable will be replaced here. That means it will automatically convert to number of 6. Okay, then after that, I'm just writing this particular file again as a custom underscore YOLO V5.yaml. Instead of changing the original file, I'm just creating a copy of this particular file and I'm changing the number of classes. Okay, now let me show you. Now if I refresh, see now custom, see this is the file I have created right now, custom underscore YOLO V5 s.yaml. See, now it has become NC is equal to 6. Previously it was 80. Okay, now it has become 6. 80 number of classes means it maximum capacity of detecting objects. Yeah, it can detect 80 number of objects. Okay, 80 number of different objects. Okay, if you see in the Coco data, we are having 80 different objects. Okay, but here we are having 6 different objects. In the research scope, is there research scope in object detection? Definitely there are lots of research scope inside object detection. So you can work with this particular algorithm side if you're, let's say, good with the mathematics and all. You can bring up with a different, let's say, new architecture. Okay, so that it would be state of the art. On top of that, you can publish a paper. Otherwise, you can also research on the application level. You can, let's say, this sign language application is already available. If I show you sign language, okay, sign language detection, okay, detection paper. Okay, so there are so many paper people has published, okay, with different approach. So you can also create a best approach, and you can also submit your own paper. See, state of the art approach, sign language detection. So this is the paper they have published. Okay, you can read this particular paper, and you can learn about what kinds of tools and technology they are using. Okay, how they're coming up with the state of the art solution. Okay, based on that, see, they have published the paper. They're also using video camera and all to collect the images. Okay, so that's how we can also build this particular system in an efficient way. You can get a higher accuracy. That time you can also publish a paper on top of it. Okay, that is also possible. So there are definitely lots of research scope you will see inside the object detection. Okay, I think Monica, you were asking this particular question. All right, so now we have successfully changed the model configuration. Now we can start the training part. Okay, we can start the training part. Now to start the training, here is the training command. Okay, so first of all, you have to go inside YOLO V5 folder, and inside that you have one file called train.py. Let me show you. So this is the file called train.py. Now if I open this particular file, so this file contains all the code related training. Okay, you don't need to write manually. So everything they have already written. So that's why I personally love this particular YOLO V5, because everything is already available. I just need to plug in my data, and everything I can run, okay, from this particular notebook, and it will work for me. So I don't need to manually set up everything. Okay, everything can be automated. See, all the code they have already written. So you don't need to like modify this particular code. Okay, just keep it as like that. Only you just need to set some argument. Okay, see, first of all, you have to define the image resolution. Okay, image size. So if you check my image size, so it's like, let me show you the image size. So if I go to the properties, details, so this is the resolution. Okay, 640 times 480. Okay, that's why I kept this particular size. Okay, 460. Okay, 416. But let's say if you're having HD image at the time, you can also keep 1080. Okay, 1080 you can also keep. Okay, otherwise you can also keep 720 you can also keep. Okay, that's how you can see, give the image size. Then you can define the batch size. Okay, like number of batches actually it will take the image during training, and number of epoch. Let's train 100 epoch. Okay, I'll train 100 epoch just to get a good performance from the model. But 100 epoch is not enough. You have to increase this particular epoch size. Then I need to give the data.yaml location. Okay, so this is the data.yaml location, because inside data.yaml I'm having all the folder location where my data set is present. Okay, number of classes I'm having and all the classes name. So this particular location you have to give. So copy the path and give it here. Okay, then you have to give the model configuration. The model configuration we have created. So it is inside YOLO V5 models, and we have created this particular custom underscore YOLO V5 YAML. So copy this particular path and give it here. That's it. Okay, so once it is done, you have to also give the model name, which model you want to use. So I already told you I'm going to use this particular YOLO V5 s.pt model, and it is already available in the model view. So copy the name, okay, and give it here and just add .pt. Okay, it will automatically download. Then what would be the output folder? There actually it will like save my model, and it will save the artifacts and all, like all the laws and matrices I can see in this particular folder. Now once it is done, now let's start the training. Now, first of all, it will download the base model, then it will load that particular model, and it will train on top of my data. You can open the Coco website, Lincoln, and you can see all the like images, okay, available inside Coco dataset. Now see guys, training is going on. So epoch has started. So currently it's 0 epoch is running. So it will take some time. Let's wait. Okay. So if you are using premium Colab, so it will training will happen quickly. And this is the box losses, classes losses, and MAP score you can see. If MAP score is increasing, that means your model is learning. If his loss is decreasing, that means your model is learning. Okay. So if you have any kinds of query in between, you can ask me. So training is going on. Let's wait. So currently 34 epochs out of 100. So let's wait. And see, left hand side, it has created one runs folder. Okay. Inside runs folder, it is saving all the logs. So YOLO V5 results, and see, this is my final model base.pt, and these are the logs. Okay. That means my result.csv, then conversion metrics. I'll tell you. Okay. I'll show you all the graphs and all. First of all, let training be completed. Should we learn V5, V7, other YOLO updates? Yeah, definitely we should learn. And tomorrow I'll show you the YOLO V6. Okay, then after tomorrow V7, 8, and 9. Because 9 is the current version, okay, of the YOLO. Okay, 81. In 20 more epochs is remaining. Let's wait. Okay, my 100 epochs is completed. Now I got my final MAP score, as you can see. And all the MAP score are close together. That means everything is running. All the classes is running fine. Okay. Now also let me evaluate the model. First of all, I will launch the tensor board and I will see all the logs. Okay, different logs, all the matrices and everything I can see from here also. Now it will launch the tensor board. See, this is my tensor board, and here you can see your F1 curve. This is the F1 curve. This is the precision curve. This is the recall curve. Okay. Then you can also see the matrices. That means the results. Okay, but it's like very smaller graph, so I can also launch in a bigger graph. So let me also do it. So this is the code that you can execute. So it is having one result.png file inside train folder, YOLO V5s. See, results.png. So inside that it has saved all the matrices, okay, in a graphical representation. Now let me show you. This is the final metric you can refer. So this is my training box loss. That means if epochs is increasing, my loss is also decreasing. Again, training box loss, epochs is increasing, loss is decreasing, loss is decreasing. Okay. Then MAP score, precision recall is increasing. Okay. If epochs is increasing, precision recall is also increasing, MAP score is also increasing. Okay. That means this 6 graph, it should be like, you can say, decreasing. Okay. So this loss should be decreasing always, and MAP and precision recall, okay, it should be increasing. And if you look this kinds of graph, that means your model is learning better. See, initially it was some zigzag issue because initially it was like doing some random images, and it was like learning, it was trying to learn. That's why you can see some zigzag issue. But once my model got actually after 50 epochs, okay, see the learning was pretty good here. Okay, so that's how you can actually evaluate your model, whether your model is learning better or not. Okay, if model is not learning, that time you will see this MAP is not increasing, even loss is not decreasing. Okay, it would be a saturation point that time. Okay, so this is the metric you can see. Now you can also see some batch images, like ground truth images. Okay, like how my image will look like. Even also you can see some batch images. Okay, these are the batch images. And see, YOLO V5 by default, it will perform data augmentation technique. Okay, in the backend, see, now it has performed data augmentation also with my different image. See, sometimes it has changed the brightness. Sometimes it has changed the color of my image. Okay, sometimes it has combined all the 4 images together. Okay, this is called data augmentation. Okay, and by default, YOLO V5 will apply this thing in the runtime itself. Okay, yeah. Now after that, I'll see my model. So model is available inside this particular runs folder, train YOLO V5s and wait. Okay, inside wait, this is my model base.pt. So this is my final model. Okay, this model actually I have trained. Now you can also download this particular model. If you want to create any web application, you can use this particular model. Okay, in future. Now let's say if you want to learn how to create the web application, you can refer this particular playlist. Okay, I already showed you this playlist. You can refer there. I showed you how we can create the web application and how we can convert this project as an end-to-end pipeline. Okay, everything I have already explained here. Now what I have to do, I'll be performing some detect, okay, on top of my test image. Now I think you remember I am having some test image. So inside test folder, I'm having some testing image. Okay, now let's test my model on top of my testing image. Okay, so for this, I'll be executing this particular command, okay, called detect.py. Inside YOLO V5, I'm having this particular file called detect.py. So this is the file called detect.py. And they have already written the code about detect.py, like how it will detect, how it will load the model, everything they have written. Okay, so no need to change anything. Only you just need to specify some of the parameter. So the first parameter, you have to give the model name. Okay, the model you want to use. So this is the model I want to use. So this model is available in the runs folder, inside train folder, inside YOLO V5, inside wait. Okay, inside wait, I'm having this particular model called base.pt. So copy the path and mention it here. Mention it here. Okay. Then you need to give the same image size I have given in the training. Okay, like 416. Then confidence score, like you want to train your model. If like you confident about 50%, this image is a, let's say, hello or any other object, that time you can show, otherwise you don't need to show. Okay, this is the confidence score you can set. And source is equal to test data. Okay, so as you can see, this is my test data, this is my test data location image folder. So this is the location actually I'm giving. Now it will pick all the images one by one and it will predict and it will save inside the runs folder. Okay, now let me execute and show you. See, it has performed all the testing. Now if you want to visualize the image, so what you can do, you can go inside YOLO V5, refresh, and go inside runs folder. There is a folder you will see called detect. Inside that you see the experiment. Now see, this is your detection. Okay, now if I open the hello, now see guys, it has detected hello with the confidence score of 0.90. It is 90% confidence this object is a hello. Now let's open any other image. Let's say I love you. See, it is 81% confidence this image is I love you. Now also let's open the no. It is 74% confidence this is a no. Okay, no gesture. Then I'll also open up for the please. Now see, it is 92% confidence you are trying to say please. Then I'll also open up for the thanks. So it is 88% confidence you are trying to say thanks. Then also yes. That means all the level it is predicting successfully, guys. See, it is 91% confidence you are trying to say yes here. Okay, that means it is performing very well. Okay, although I trained only 100 epoch, but you will see the confidence score is like very high. Okay, very high. Although I said 50% confidence, I was telling my model, if you are 50% confident, if you're predicting correct, that time show, otherwise no need to show. But I saw that it is more than 50%. Okay, 50% correct, it is predicting everything. Okay, now what you can do, you can also perform on top of the real web camera. So you can also launch up your web camera there. Actually you can also show the hand gesture. It will also detect in a real time. It is also possible. And if you want to learn it, so please refer this particular series. So at the last series, I think last session, so you can follow this particular session called user app. Okay, user app. So here I was discussing about how we can like load the model and how we can also load our web camera And with the help of web camera, how we can also do the real-time prediction. Okay, there actually I already discussed this part. You can refer this particular lecture. Okay, so that's how actually we can train any kinds of object detection model, okay, with the help of YOLO V5 on top of the custom data. Okay, now you can use any kinds of data from the RoboFlow universe. So let me go to the universe. So here you are having different data. So let's say you want to perform object detection, so select the object detection. Now see guys, these are the data set you are having for the object detection. So you are having facial expression data, fish data, then you are having this particular data, okay, booster data, then animal data, basketball data, okay, face data. You can pick up any kinds of data and you can train the object detection model on top of that. Okay, so I'll give you one task actually. So pick up any kinds of data set from the RoboFlow and try to train one object detection model on top of it. Okay, so this should be your task. So please try to explore this particular task, and if you are able to do it, so definitely you can train any kinds of object detection model, okay, with the help of YOLO V5. And this is like very easy to use framework, okay, over the internet. How to detect from a video? So you have to execute the same command, only you just need to give the source is equal to 0 here. Let me show you. In the detect command you are running now here, but it should be running on your local machine. Okay, Colab it won't be working because Colab can't access your web camera. So make sure you are running from the local machine. So this source is equal to, you have to give 0. 0 means the camera ID. Okay, it will launch up your web camera that time. So in this particular video I already discussed this part. This video you can check it out. Okay, so fine guys, I think the session was good and you were able to learn these are the things actually how we can perform custom object detection on top of our custom dataset. Okay, so tomorrow I'm going to show you the YOLO V6 one. Okay, like how we can use YOLO V6. So if you already know YOLO V5, YOLO V6 is like slightly different. Okay, all the things would be remain same, only some of the functionality would be slightly different. Okay, I'll tell you. Okay, how to set up and all, I'll tell you each and everything. Okay, so with that guys, I think end the session for today. So let's connect tomorrow and try to learn the YOLO V6 as well, okay, for the object detection. So thank you so much guys for joining the session. Bye everyone, take care. So in our previous session we have already seen like how to perform these kinds of object detection task with the help of this YOLO V5. And there I already told you I'm going to use all the version of the YOLO, let's say YOLO V6, YOLO V7, V8 and V9, because V9 is the current one. Okay, like it is like came recently. So we'll be exploring all of them and we'll be learning on top of the custom data training actually, like how it can be done and all. Even we'll be also seeing like how to perform the data annotation, because this is the most hardest task in the field of computer vision. So there you have to like take care about your data. Okay, I think I already showed you like how we can perform data annotation with the help of RoboFlow and all. There are so many tools and technology you can use. There are some, let's say, GitHub repository is also there. You can directly install that particular tool in your system, and you can also perform the data annotation. I'll tell you today that particular tool, what tool actually you should use. If you don't want to use RoboFlow at that time, you can go with this particular tool. Okay. So in this particular video, what I will show you, I will show you the YOLO V6 one. First of all, I'll give you the introduction of the YOLO V6, and I will show you some comparison of the YOLO V6 and YOLO V5. Okay, like what was the benchmark actually they have came up with. Okay, what was the accuracy, what was the performance they have came up with. Everything I'll tell to show you. Then we'll be starting with the practical implementation of this particular series. Okay. So what I will do is, first of all, let me show you the resources. Previous resources actually will get. So if you want to get the previous resources, so make sure you have one account, okay, in our website. And here what you have to do, just go to the community program, and here you will see my community series called Computer Vision Hands-on. Okay, just click here, click on the export. Now here you just need to first of all log in with the account. So let me log in with my account. So this is my account. I think I can select. Yeah. So after that, if I go to my courses, and this is the course. Okay, so here if you see, all the resources has been updated. So today is day 4, till day 3 everything is up to date. Even resources is also available in the resources section. So if you don't have the resources and if you're looking for the resources, so you can get the resources from here. Okay, yeah. And if you want to, let's say, get this particular course link, so it is also available inside this particular video description. So if you just go to the live section in our YouTube channel, and if you open up this particular, let's say, video, and in the description section actually will get this particular link. Okay, so from there also you can open this particular link and you can enroll for this particular course. Okay, and it is completely free. Okay. All right. So first of all, let me give you some idea about YOLO series. Actually, my YOLO series has been become like more famous in the market. Okay, let me first of all give you some idea. Then I think we can start with the implementation. So YOLO V6 is nothing but it's just a next generation object detection algorithm. Okay, so whenever I'm talking about next generation algorithm, so here you will get some brief idea about YOLO, like what exactly this YOLO is. One of the most popular waste project in computer vision is YOLO. You only look once. Okay, the full form of this YOLO is you only look once. YOLO is an efficient real-time object detection algorithm first described in the seminal 2015 paper by Joseph Redmond et al., YOLO divides an image into grid system, and each grid detects the objects, okay, within itself. It can be used for real-time inference and require very few computational resources. Okay, I'll tell you what is this particular image into grid system. Okay, because how this thing is working apart from the traditional, let's say, object detection algorithm. So what we used to use in the traditional object detection algorithm, and what was the problem there. Okay, so I already have one image, I'll tell you. Then they are telling also, so this is a next generation, it's a state of the art algorithm, because you can also perform real time inference, okay, with the help of this particular YOLO algorithm, because you will see like very quick, like you can see inference speed there. So let's say if you want to perform real time object detection, so that if you open up your camera, so if you're using, let's say, some other object detection algorithm, let's say first RCNN, or let's say RCNN, okay, so these are the algorithm that if you're using, you will see will face some of the lagging there. But whenever I'm talking about YOLO, okay, so YOLO would be like very fast. That's why they're also telling it requires very few computational resources. Let's say if you are also performing the object detection on top of the CPU machine, that time also it would be very faster inference, okay, speed. You can test it. Even I think I will show you uh, in future also, like how to open up the camera, and there actually how we can perform these kinds of real-time object detection task. Okay, so now let's see what is the next. So object detection before the YOLO. So as I already told you before, let's say YOLO, what we used to use, okay, in the field of this particular object detection. So before YOLO, the two-stage object detection architecture dominated in the field. It used to region-based classifier to locate the areas and the pass them to the more robust classifier. Okay, while this method gives the accurate results with high means average precision, but it's uh, uh, very resource incentive and require many iteration in the operation. Okay, as you can see, initially actually we used to propose something called region based classifier. Okay, so what it used to do, it was to locate that particular objects, okay, and it was to pass that particular object to the robust classifier. Okay, robust classifier. So for this actually it needs like very resources intensive. Okay, very resources, that means you need higher resources there. Okay, and require many iteration in the operation. That means it will look for that particular object. Okay, for this actually you have to iterate that particular image again and again until you found that particular object. Okay, so this is like very time taking task. So that's why researchers proposed this particular YOLO algorithm. And how this thing is work. So YOLO suggested a different methodology where both stages are conducted in the same neural network. First, the image is divided into the cells, okay, each having an equal dimension, okay, regions of s times s. Then each cells detect the locates an object it contains with the bounding box coordinates relative to the coordinates with the object level and probability of the things being present in the cell, because each cells works in own and it can process the grid simultaneously, reduce the required computational power and time needed to train the inference. In fact, YOLO architecture achieves the state of the art results beating other real-time object detection algorithms. So see what they are proposing. They are proposing this kinds of neural network that divides the image into cells. Okay, as you can see here, I'm having the image. So first of all, it will divide that particular image into cells, different cells, and each of the cells will detect that particular object. Each of the cells will try to detect that particular object, whether something is present in that image or not. Okay, that's how actually it is doing kinds of multiprocessing. Okay, multiprocessing, and it is trying to detect that particular objects. Okay, that's why it's like very fast, and it's like it needs like very less computational power, because each of the cells is working, okay, to detect that particular objects here. So this is the main idea of this particular YOLO. Okay, YOLO series, entire YOLO series, whatever YOLO actually you can see from YOLO V1 itself till YOLO V9. Okay, everywhere actually they are using these kinds of concept, but they're tweaking that particular architecture with different let's say, I mean, with different layer, okay, with different let's say anchor box and all. Then they are came up with this particular version of that particular architecture, okay, but the working mechanism would be remain same in the internal architecture of each and every algorithm you will be using in the series of YOLO, okay. But it can be YOLO V5, V6, V7, V8 and V9 and so on, okay. So this is the complete idea. Now, what is the version does YOLO have? So as I already told you, YOLO has let's say it is having, let's say, different versions. So it is having V1, V2, V3, V4. But V1, V2, V3, V4, okay, people don't use nowadays because it has been deprecated. Okay, people will start using this particular YOLO version from the YOLO V5 nowadays, because YOLO V5 having, let's say, a very, let's say, huge community support and all. But if you open that particular YOLO V4, okay, you will see it has been almost deprecated. So people stop working on that particular let's say repository and all. So you might face lots of difficulty. Even you have to use something called this one actually. There is separate library actually you have to use this particular YOLO V5, YOLO V7, YOLO V4. But whenever I'm talking about YOLO V5, it's like very easy to use because it has already one repository from Alternative. Okay, with the help of that particular repository, we can easily use this particular YOLO V5. And the release date of this YOLO V5 May 2020. Okay, so this is the release date. And GitHub repo I already told you, but no paper was released, okay, for this particular algorithm. Now, what is YOLO V6 exactly? As I already told you, so YOLO V6 was inspired by the original one-stage YOLO architecture, and thus was bravely named YOLO V6 by the author. Okay, though it provides outstanding results, it's important to note that YOLO V6 is not a part of the official YOLO series. YOLO V6 is a single state-of-the-art object detection framework decided into the industrial application with hardware friendly, efficient design and higher performance. It outperforms YOLO V5 in detection accuracy and inference speed, making the best version of YOLO architecture for the production application. Okay, so see, it was not published from the official YOLO series. Okay, so some other organization published this particular actually YOLO V6, and this is like very state of the art detection framework. Okay, it outperforms than your YOLO V5, okay, in the detection accuracy and its inference speed. So it is more faster than your YOLO V5. Even you will also get like more higher accuracy, okay, with respect to your YOLO V5 here. Now it is the best version they are telling, okay, of the YOLO architecture for the production application. Let's say you want to build production grade application and you are worrying about the speed and accuracy. That time you can go with this particular YOLO V6 instead of YOLO V5, okay, because it will give you like best performance here. Okay, so this is the complete idea. Now, as I told you, YOLO V6 having, let's say, different architecture. Okay, so I think you already saw. If I show you that YOLO V5, okay, if I show you the YOLO V5, I was talking about the model Zoo because it is having different architecture. So see, this is the model Zoo. So it is having YOLO V5N, YOLO V5S, then YOLO V5M, then L, okay, then X. So these are the model variant actually it is having. So similar wise, we also have the model variant, okay, in this particular YOLO V6. So we are having different models. So we have nano model, okay, we have smaller model, we have bigger model. I'll tell you YOLO this V6 repository. I will show you there. Actually, I will show you different model variant actually we are having. So if you are using nano model, okay, so it is achieves, let's say, 35.0 MAP score. That means mean average precision score on the COCO VAL 2017 dataset with 1242 FPS, okay, on the T4 using TensorRT, FP16 for the BS32 inference. Okay, so this is the performance of this particular model. So there is another model called YOLO V6S model. That means this is the smallest model. Okay, so it achieves around 43.1 MAP score on the COCO VAL 2017 dataset with 512 FPS on the T4 using TensorRT FP16 for the BS32 inference. Okay, so this is the performance of this particular model. Now let's say if you are creating a very lighter application and you want to also, let's say, deploy this particular application in the edge devices. That means, let's say you want to deploy that particular application in the microcontroller or let's say smartphone. That time you can go with this particular nano model. Okay, because this is like a very smaller model. Although this MAP score is less, but if you see here, this inference time is like very high here. Okay, they're telling 1242 FPS. Okay, so 1242 FPS. Just try to remember 1242 FPS actually will get on the T4 using TensorRT FP16 for BS32 inference. Okay, but whenever I'm talking about this S model, that means smaller model, so it achieves actually around 43.1 MAP score. But again, the FPS was like less than your nano model only 512 fps, okay, on the T4 using TensorFlow FP16 for BS32 inference. So that's how actually you can select the model based on your requirement, based on your hardware requirement. You can go with this particular model, okay. So that's how actually we usually select the model. Now let's say you are working in the field of medical domain. There is speed actually that much of, like, you can say it is not matter. You are worrying about the accuracy mode. So what you can do that time, you can go with bigger model, because you will be trying to achieving, let's say, good performance from the model. Okay, you will be trying to achieving, let's say, higher accuracy from the model. That time actually you don't need to use this particular nano model, okay. So that time you actually just go with the large model, or let's say a medium model. You have to go with this particular model. But let's say if you want to perform real-time object detection and you are worrying about the let's say in speed, that time actually you can go with the lighter model, okay, based on the fps you can see here, okay. So this is the complete idea. Now here if you see, two graph I have kept on the single image inference and video inference, okay, of this particular YOLO V6 series, as you can see. So as I told you, YOLO having, there's a different variants. So YOLO V5, okay, YOLO V5s, YOLO X, then YOLO V6 is also there. Now see here, so YOLO V6 is performing better, okay, on the single image inference, okay, as you can see. So this is the speed, okay, and this is the COCO, that means MAP score, and this is the YOLO V6 model. As you can see, your MAP score is also increasing and FPS is also decreasing here. But whenever I'm talking about other model, let's say efficient date model, as you can see, this FPS is that means increasing, that means frame per second is increasing, and your accuracy also decreasing, okay. Accuracy is also decreasing, sometimes it is also increasing. That's so with the help of this particular graph we can try to understand this YOLO V6 is working fine, okay, with respect to other model. As you can see, efficient net, YOLO V5, okay, YOLO V5s, okay, N model. So this model is performing well. Now whenever I'm talking about the video inference, so here also YOLO V6 is performing well, because as you can see, this is the, they are using V100 GPU, and this is the FPS, okay, this is the FPS, and this is the MAP score, as you can see. So FPS is less, around as you can see, this is the FPS 1500, and this is the MAP score. That means FPS is, that means speed is also high and your accuracy is also high, okay, whenever I'm talking about this YOLO V5 YOLO V6 model, okay. So that's how actually you can see the comparison with different model with respect to this particular graph. And this is the COCO object detection, okay, they are performing on the detection task, okay, not any other task. So it is only can perform detection task. But there are some other YOLO V series as well we'll be learning in future. We can also perform semantic segmentation as well as the classification also, it can be performed, okay, both it can be done. Now these are some benchmark, okay. So as you can see, whenever you are using YOLO V6 N model, that means nano model, so this is the pixel size of the image, and this is the MAP score around 30 to 35, and this is the speed, okay, 0.3 per 0.5, okay, on the V100 GPU. Now as you can see, this is the speed on the T4, okay, this is the speed on the T4, and this is the parameter of the model. So it is having, let's say, 4.3 million parameter, okay, and this is the flop. Now you have also YOLO V6 tiny model, again, and this is the size of the resolution, and this is the MAP score you can see. And similar wise, you also have another model called YOLO V6s model, okay, and this is the benchmark of this particular model, okay. So you can see the comparison of the all model, like which model is working fine, which model you should take, okay, based on the speed and parameter, okay. If you see here, this model is having more parameter, around 17.2 million parameter this model is having. That means this model is bigger than these two model, okay. Now you can see the difference between YOLO V5 and YOLO V6. So this is the comparison, as you can see. So this is the YOLO V6 performance, and this is the YOLO V5 performance, okay. Now I can show you one thing actually. So let's say I collected some of the results, okay, of the YOLO V6 results as well as the YOLO V5 results. Now here if you see here, this YOLO V6, okay, YOLO V6 is performing this particular object with higher confidence score. As you can see, it is performing this particular person as 0.93, okay. This, like this algorithm is confident, 93% confident this is a person, and 82% confident this is a tie, again 91% confident this is a person, okay. But whenever I'm talking about YOLO V5 model, as you can see, this model is telling 67% confidence this person is this is a person, and only 68% confidence this is a tie, and as you can see 88% confidence this is a person, okay. That's how we can see here. Whenever I'm using this YOLO V6 model, okay, so it is performing better than your YOLO V5. Okay, because here I'm getting higher confidence score. Okay, most of the cases. Now let me show you another image. So see, this is another image, and this is the YOLO V6 result, and this is the YOLO V5 results. As you can see here, confidence score is like very high, but here confidence score is low. Okay, so this is the complete idea you can talk about. Now here some of the images actually you can see. Now what is the main difference between this particular YOLO V5 and YOLO V6? If you see this training mechanism would be remain same only. The way actually we trained our YOLO V5 model, the way actually we annotated the data, all the things would be remain same. Only some of the format will be, let's say, different. Okay. And what is the main difference of this particular YOLO V6 and YOLO V7? Okay, the main difference, as you can see, we can clearly see that YOLO V6 detects more objects in the image and has higher confidence about their level. Okay, the biggest difference is YOLO V5 uses YAML file, whereas the YOLO V6 defines the model parameters directly in the Python file. Okay, I'll tell you whenever I'll do the configuration, let's say modification, that time actually I'll show you. It used actually one Python file, but whenever I used YOLO V5, okay, there actually I've used to change one YAML file. I think you remember in the configuration I had my model configuration. Inside that particular configuration, I used to change that particular model configuration. That means let's say number of classes we are having and all, right? So this thing actually will be performing in the Python file in the YOLO V6. Okay, so this is the main difference of this particular YOLO V6 and YOLO V5. Okay, yeah. So I hope now you got some understanding on the YOLO V6, like why the YOLO V6 is like so popular and what is the difference between YOLO V6 and YOLO V5. Okay, now what I have to do, let me show you the training process of this particular YOLO V6 on the custom data, then things would be much clear. But before that, I just need to show you the data annotation, like how to prepare the data for this particular YOLO V6. So for this, again, I'm going to use this particular RoboFlow, okay, roboflow.com. So make sure you have one account here. So I already have the account. So what I will do, I'll just try to sign with my account. And here I'm having some sample data. Okay, so let's say this is my sample data I'm having. So these are some data actually I collected. Like this is the industrial data, as you can see. So people are wearing helmet, gloves, okay, footwear, jackets, and all. So I'll be showing you like data notation with respect to this particular data. But whenever I'll be training my model, I have another data called this the same data set called sign language, because this data set I already annotated for the YOLO V6. Okay, as you can see. So this is the same sign language data I'm going to use, and this is already annotated for me. Okay, as you can see, the label is already annotated for me. So I'm going to use this particular data to train the model, but I'm going to show you the data annotation part with respect to this particular data. Okay, so first of all, let's upload this particular data. But before that, what I have to do, I have to remove this particular project because I already created this project before. So delete, and this is the project ID. I'm going to delete it. Now helmet, I will be also deleting this one. Just a minute. Okay, I think I don't have any like this kinds of data. Now what I will do, I'll create a new project. I'll name it as YOLO V6. Okay, YOLO V6 live demo. Annotation group you can write. So let's say this dataset is having, let's say, helmet. So I'll give helmet at the very first object. Now object detection I'll be selecting, and let's create a public project. Now you have to upload your data. So for this you can drag and drop. So let's upload some of the images. So I'll only upload, let's say, 10 images. Okay, I think 10 images is fine. Yeah, so only 10 images. Let's upload and see, okay, how this data annotation can be done. Or else I think I can take some more images. Okay, so these are the images actually I can take, and these images also I think I can take. Okay, now let me upload them. So I have uploaded 16 images here, but make sure whenever you are collecting your all images, okay, it should be more than 16. Okay, now how to collect the data, I already showed you. You can also use RoboFlow Universe. It is also having different object detection data. So let's say you want to perform object detection. So select the object detection from here, and you can see there are so many data. Okay, based on your requirement, you can download the data from here also. Okay, but if you don't have any data, if you have collected your own data and if you want to annotate it, so you can use this RoboFlow annotation tool. Okay, so I already uploaded my data. Now I'll save and continue. Okay, now let's start manual labeling. I'll assign the image. Okay, now let's start the annotation. All right. Now here I'll be selecting this particular helmet. So make sure you selected this bounding box tool. Okay, bounding box tool I'll select. First of all, I'll annotate the helmet. So this is helmet, enter. Then you can also annotate this particular globs. So this is nothing but globs. Okay, then I'll go to the next image. Now again, this is a globs. I'll go to the next image. So again, I can see this is a globs. Okay, this is also a globs. The next image. So this is helmet. Then this is globs. Okay, you can also detect this particular jacket if you want. So this is nothing but jacket. You can also detect the footwear as well. Okay, if you want. So this is the footwear. Footwear. Okay. Now this is also footwear. And I'll go to the next image. So here also I'm having the helmet. Then gloves. Okay, then this is the jacket and the footwear as well. Okay, let's go to the next image. So again, helmet. Gloves I'm having also. So this image resolution is like very low resolution. I collect it quickly. That's why it's a low resolution. But whenever you are collecting your image, make sure you are collecting high resolution image. Okay. Just to show you, I collected these images. Okay, I downloaded from Google itself. Okay. Now go to the next image and this helmet. That's how you have to complete for all the image. Okay, you are having here. So this is gloves. Again, this is a gloves. So I'm also having the jacket. Okay, then footwear. Then I'm also having, let's say, helmet, gloves, gloves. Okay, and jacket. Footwear I can't see, so I don't need to annotate it. So I'll go to the next image. So again, let's detect helmet, gloves, and gloves. And I also have the jacket. Okay. Now I'll go to the next one. And again, I can see the helmet and gloves. Next image. So helmet and gloves. I go to the next image. So helmet and gloves. Then again, helmet I can see and gloves. Here I only can see the globs. So this like object, okay, if you see it is like blurred, so you can also skip, otherwise you can annotate, but I'll skip this particular blurred, okay, blurred object, so I won't be detecting. Now again, this is a helmet and this is the gloves and this is the jacket. Now the last image, so this is the helmet, this is the gloves, again this is the gloves, and jacket also we have, so we can also I think detect the jacket. Okay, so all the image is completed. Now what I have to do, I have to go back and add all the images to the dataset. Now you can also perform 10 test split. Okay, it will automatically perform if you're using RoboFlow. You don't need to do it manually. Now let's add the label. Okay, now what you have to do, you have to create a version of the data. Now after that, you have to, let's say if you want to perform pre-processing, you want to, let's say, do the oriented resizing operation, you can do it. Otherwise, you can continue here. Okay, let's click on continue. Let's see if you want to perform augmentation. Okay, different data augmentation you can also perform here. So augmentation is there. You can also perform data augmentation. So I won't be performing any augmentation. I'll skip this part. And now you can create the data set. Okay, now let's create the data set. Now it's creating. Okay, my dataset is ready. Now I need to export the dataset. I click on the export, and now you'll be selecting the format. Okay, which format you want to save the data. Now, as I already told you, I'm going to use this YOLO V6. Okay, so as you can see, YOLO V6 is already there. Previously, I used YOLO V5. Now I'm going to use YOLO V6. Okay, see, YOLO V6 is there. So select the YOLO V6 format and try to download the zip file. Okay, I'll click on continue. So it will zip and download for me, and I'll tell you the dataset format. See, this download has started. Now let me open up my download folder. Okay, this is my download folder. I'll go inside, and this is the data it has downloaded. Let me unzip. Okay, now if I show you the data, now see guys, this is the data. Okay, now you can also delete this particular to readme file. It's not required. So here I'm having the image. Okay, inside image, I'm having three different folders: train, valid, and test. Okay, inside training, I'm having all the training images. Okay, and inside valid, I'm having all the valid images. Inside testing, I'm having all the testing images. Now similar wise, I'm also having another folder called labels. Okay, inside labels folder, I'm having again three different folder: train, valid, and test. Okay, and it will contain that annotation file with respect to all the images. Okay, so now see guys, this is the annotation file. This is the txt annotation, but means this is the YOLO annotation. Now if I open any particular txt file, you will see that particular coordinate point here. Okay, see, this is the coordinate point, and I think this is the globs because we are having two globs in this particular image. This is the two coordinate, and this is the label. Okay, label of this particular glob. Now if you want to see the label like 1 to 3, like what is the 1, what is 0, what is 2. Okay, if you want to see that, so for this you have to open this particular data.yaml file. Let me show you. So there is a data.yaml file. Now let me open it up with the help of notepad++. Now see guys, this is the location of the image. Number of classes I'm having 4, and this is the name. Okay, that means first of all, 0 is the footwear, 1 is the glove, 2 is the jacket, and 3 is the helmet. Okay, so that's how actually you can see the level because this is a list. Now this is the data actually it has prepared. Now similar wise, I also prepared another data for this particular like you can say video. I'll be using the same sign language data because here I'm having lots of images. Okay, and I already annotated. I'm going to use this particular data to train my model. Now if you see here, I'm also having the same folder structure. Set training image, I'm having all the training image, and inside labels I'm having all the labels. Okay, as you can see, inside labels I'm having all the txt annotation labels. Now similar wise, I'm also having another this particular things called a YAML file. Okay, as you can see, if I show you this particular YAML file, and here also I've written the same thing. Okay, number of classes and all. Now one parameter you have to provide here. You can also give it, otherwise you don't need to give it. Okay, recently you don't need to give it, but previously when you used to use this particular YOLO V6, that time we used to provide this particular statement called is coco is equal to true or false. Let's say here we are not using any coco data set. Okay, so that's why I'm just written as a false. Okay, because this is a YOLO annotation, it's not a coco data set. Okay, that's why it should be false. And if you're using coco data set, it should be true. Okay, coco dataset will be using in the detectron 2. I'll tell you how to use detector 2 along. Okay, there actually I'll show you. Okay, how to annotate for the coco instance. Now this is the dataset format. Now you have to zip the data and upload in the same GitHub. Okay, I already showed you how to upload in the GitHub. You can upload in the GitHub. Otherwise, you can also directly import in the notebook file. It's completely fine. So this is the data annotation with the help of RoboFlow. Okay, now there are some open source tool as well. RoboFlow also open source, but it is also having the paid actually subscription as well. Let's say if you want to take the paid subscription, you can also take. But let's say you don't want to upload your data to the RoboFlow at that time, you can go with some let's say open source tool called Label-IMG. Okay, so Label-IMG another tool for the data annotation. If I show you, but you have to install this particular tool in your system. Okay, so this is the official repo. So Label-IMG is nothing but it's a labeling tool, and there actually see you will get this kinds of interface and you can annotate the data. Okay, so you can also perform the same bounding box annotation. So you can go with their like readme file and you can try to understand how to set up, because they have already given all the like guideline. First of all, create an environment, and based on the operating system you have to execute the command. Let's say if you're using Windows, in Windows actually you can install via pip. Okay, first of all, create an environment. There actually you just try to install this particular Label-IMG and try to launch the Label-IMG. Okay, so that's how you can see that particular tool. So this tool actually you can use if you want to perform the data annotation locally. Okay, yeah. So now what I will do, my data is ready. Now let me open up a notebook quickly. So I'll open up a Colab notebook. So I'll create a new notebook here. So I'll be naming it as YOLO V6 custom training. Okay, so make sure you selected the runtime as GPU. So I'll click on the runtime. I'll select the T4 GPU and save it. And let's connect the notebook. Okay, so here the first thing, what I have to do. First thing will be installing some dependency. Okay, so let's install some dependency. So here, just let me write install some dependency. So first of all, let me show you the YOLO V6 GitHub repo. Okay, so this is the GitHub repo of the YOLO V6. So this is the organization Meituan. Okay, Meituan. This is the Chinese organization. They have proposed this YOLO V6, and this is the repository. Okay, as you can see, everything is written in Chinese. Okay, but yeah, English I can also see. Now see, this is the benchmark actually graph. Okay, all the different YOLO version benchmark, as you can see. Even they have also given the paper link. If you're interested learning the paper and all, you can open the paper. You can try to understand. And this is the benchmark. Okay, this is the benchmark, mobile benchmark, and this some command they have given like how to use them and all. So this is the model Joe, guys. Okay, so as you can see, here is the model Joe. YOLO V5 LS. Okay, so this is the model Joe. So now let's see if you want to get this particular weight. So if I open it up, so this is the complete link of this particular weight. Okay, now see it has started downloading, but I won't be downloading. I'll cancel it. I'll go to the yeah, GitHub once. Okay, so I'll be cloning this particular repo, then I'll be installing the requirements. Okay, then I'm going to use this particular YOLO V6 okay in our project. So how to do it? So I'll open up my Colab, and here first of all I have to clone that particular repo, and I have to install the requirements. Okay, so for this is the code I have already written. So here is the code, guys. So first of all, I'm doing the clone operation of this particular repository. Okay, so click here and copy the link address and clone it. After that, go inside the YOLO V6 folder and install the requirements. Okay, because as you can see inside YOLO V6 folder, I'm having this particular requirement.txt. Okay, now if I open the requirements, so these are the requirement you have to install one by one. Okay, so these are the requirement you have to install one by one. Okay, so now let me install. So what I will do, I'll click on install here. So it will take some time. Let's wait. Okay, then I'll show you the further process what you have to do. And if you want to get the notebook link, so let me also share. Even I will also give this resources in the resources section. Okay, in the dashboard, you will get from here also. So this is the link. It is installing NVIDIA CUDA NNN. Okay, CUDA NNN, because it needs the CUDA to train the model and all, because it will train on my GPU, and it needs actually CUDA. Okay, CUDA toolkit and all. So everything is installing here. So in between, if you have any query, you can ask me. I'll try to answer, because installation is going on, so it will take some time. And one thing actually we'll see, if you compare like both notebook, your YOLO V5 and YOLO V6. So you'll see that in YOLO V6, actually you have to write very less line of code. Okay, very less line of step actually you have to perform. So I'll tell you. Okay, after the installation, I will download the data. After that, I will download the model, change the configuration, start the training. That's it only. Okay, it is almost done, I think. Let me check. Okay, so installation is completed. Now the next step, what you have to perform, you have to download your custom data. Okay, so here I think I can write, so I need to get my custom data. Okay, so what you can do right now, you can directly upload your data you have downloaded, that zip file. Okay, that zip file actually you can directly upload. Either what you can do, you can also upload in your uh, GitHub. Okay, so for me, I already uploaded the data in my GitHub, so this data set is available in my GitHub. Okay, so this is the link of my GitHub. So this is the complete link. Okay, so here this data set is available. Now I'll be downloading the data from here only. So for this, I'm using curl command. Okay, and I'm downloading the data, and after that, I'm unzipping that one. So let me download. Now see, if I refresh, see my data set is present right now. So if I show you my data, now see guys, this is how I downloaded my data. Okay, now it is there. Even I also have this particular YAML file. Okay, that means everything is ready. Now what I have to do? Okay, next step, what I have to do? I have to download the pre-10 words. Okay, so let's download the pre-10 words as well. So here I can comment out. So download the pre-10 words. So as I told you, it is having different pre-10 words. Okay, in the model view. So if I show you, so this is the complete model view. So it is having different model. Okay, N model, that means nano model, S model, small model, medium model, large model. Okay, N6 model, S6 model, M6 model, L6 model. Now I'm going to use this particular model called YOLO V6S model. Okay, this is the model I'm going to use. And if you want to use this particular model, so you can use the link of that particular model. Okay, so let me show you. So here is the download code. So first of all, you have to go inside YOLO V6, and inside that you have to download this particular model, and this is the link of the model. How to get the link? So you can just right click and copy the link address. Okay, copy the link address. Now if I show you this particular, and this is the link. Okay, complete link. So this link you have to copy and paste it here. That's it. Okay, now if I execute, see, it will download my model in the YOLO V6 folder. I think it is downloaded. Connection GitHub, HTTP send, awesome, found. Okay, retrieving the connection object and saving to YOLO V. Yeah, so now if I show you, see, YOLO V6 model has been downloaded. Okay, that means it's working fine. Yeah, so let me check this particular link once, whether the model is available or not. Yeah, so model is there. Yeah, so that means everything is working. Now next step, what I have to perform, I have to start the training. Okay, so here let me just write down. So now I can start the training. See, this is the step only. So we just prepared the custom data, and then I'll directly start the training. But before that, you have to change the configuration. So to change the configuration, now go inside this particular YOLO V6, and here you will get something called configs. Okay, and click on the configs. Now here you will see different configuration. Okay, different configuration of your model. Okay, now here which model I'm using? Okay, I think you saw that I'm using YOLO V6 model, V6S model. So now I need to find out this particular configuration. So this is the configuration YOLO V6 V6 fine-tune.py, V6 fine-tune. Yeah, so this is the configuration I'm going to use, YOLO V6 fine-tune.py. Now let me open it up. Now here only one change you have to do. You have to remove this particular path. Okay, wait path, because I'm inside YOLO V6 folder only, so I don't need to give this particular path. Okay, I'll remove it and everything will remain same. I'll press Ctrl S. Okay, that means save. And this is the backbone. Okay, if you want to also tweak this parameter, you can tweak, but I won't suggest, because this is the research, let's say, parameter they have came up, and they're telling if you're using this particular parameter and all, you will get the good performance. Okay, so until you don't have architecture level ideas, you don't need to change this particular thing. Okay, only change this particular path only. After that, I will close it. Now here I will be giving the training command. So this is the training command. Okay, now let me show you. So in training command, what I'm doing, I'm giving one command. Let me show you. Just a minute. Just a minute. Yeah. So here, here is the, first of all, I'm going inside this particular YOLO V6 folder. Okay, and inside that I'm executing one command called Python, and inside that you will see one folder called tools, and inside that I'm having one train.py. Okay, as you can see, train.py is there. So this is the file will help you to start the training. Okay, now if I open this train.py, all the code is already written here. Okay, all the code is already written. Okay, inside train.py. So you don't need to write anything. So you can use it by default. So you don't need to write anything here. So I'll be using this particular file. After that, you have to prepare the batch size. Okay, the batch size actually you want to take. So you can take based on the machine configuration. Here I'm using pre-collab. That's why I've taken 16 batch size. Now you have to pass the configuration file. The configuration you have changed. So it is available inside config folder. Okay. And this is the file name called YOLO V6s finetune.py. Okay. So this is the file name. So this location I have given here. Okay. Inside config, I'm having this particular configuration file. Then you have to pass the data. That means the data.yaml path. As you can see, this is the data.yaml path. And here I'm having all the location of my data. Okay. Like what this image is present and all. Then you have to set the device. Device is equal to 0 means you want to access the GPU. Okay. Because it's also support multi GPU training. See, they have already given the command. So this is the single GPU training. If you're using single GPU, only you just need to give GPU is equal to device is equal to 0. But let's say if you want to perform multi GPU training, at that time you can give like your GPU ID, let's say 0, 1, 2, 3, 4, and so on. Let's say if you have multi-stack GPU in your system, that time you can play with the ID. Let's say you want to use how many GPU, you can give the ID. Okay, 0, 1, 2, 3, and so on. So I'm using single GPU here, so that's why I've given like 0 here, and epoch is equal to 50. Let's train only 50 epoch and try to see whether I'm getting that any output or not. Okay, but it's not recommended whenever you're training your actual model. At least start with 1000 epoch. Okay, and try to see the accuracy. Now let's start the training and see whether it is able to train my model or not. So let's do it. So first of all, it will load the architecture, load the data, and still start the training. Okay, I got one error. Cannot sim config layer common.py. Let me check the error, guys. On GPU training argument content data. Okay, let me copy the error. I'll check on the Google. Okay, let me check. I think this is the version issue. So kindly they have changed the version, but it was working for me. I don't know. So here they're telling release for those who got the error, just try to get the new updated weights from. Okay, so let me open this particular weight. Assets. So this is the weight location YOLO V6 SPT. Okay, so this is the weight. I'll open it up in a new tab, and this is the cancel it just a minute. YOLO V6 S6 SPT model. I'll copy the link. Just a minute. And let me download the weights again. Just a minute. This is the data. And here I will comment it. So this is the previous version of the model. Now let's take that latest version of the model and see. So now I'm inside which directory? Let me check. pwd. Okay, I'm inside V6 folder only. Now let me download the model. But before that, I need to remove that particular model. I downloaded this model. I'll delete this particular file. Okay, now let me get the model again. So this is downloaded, I think. Let me refresh. Yeah, now what I will do, I'll start the training. Okay, now let's see. Okay, now it has started training. Okay, so issue was like they have changed the version of the model and all, because the model actually I was using previously, it was this is the version. Okay, 0.1.0. Okay, because at the very first when they released that particular model, I was using that particular version, but currently they have changed the particular version. Okay, 0.4.0, and I got to know from the release history. Okay, so that's how actually you can debug anything. If you're getting any error, you can search about the error and you will see lots of solution you will get. Okay, so I'll add this particular solution also. So here I think I can add this solution. Before the training, I can add the solution so that if you're facing any issue later on, you can refer this particular solution. See, training is going on. So 5 epoch, 6 epoch. So it will train 50 epoch around. So let's wait. Now in the YOLO V6 folder, it will create a folder called runs. Okay, inside runs, it will save all the artifact. See, this is the experiment 2 going on, and this is the weight. Okay, experiment 1, because experiment was failed. Okay, that's why it has created experiment experiment 0 was failed, that's why it has created experiment 1. Now if you again execute, it will create another experiment. Okay, that's how it track the artifact version. Now this is my model base.pt. I'm going to use this particular model for my inference. Then after this, I will show the evaluation part as well, how we'll get the evaluation metrics. We just comment out evaluation. For evaluation, you have to execute this particular command. So 25 epoch out of 50. Let's wait and complete. And if you're using Colab Pro, that means V100 and A100 GPU, so you will see quick training would be happen. But I'm using a T4 GPU, and this is free, and this is the utilization of the GPU RAM and all. Okay, as you can see. Okay, 47, 48 epochs out of 50. So I think it would be done in one epoch. Yeah, so training completed, and now we can see the evaluation. See, so to check the evaluation, first of all, here you have to execute this particular command. So inside tools, uh, you have eval.py, okay, evaluation.py. If you check inside tools, you have evaluation.py, and you have to give the data location again. And here you have to pass the weight, okay, you have trained. So this is the weight I have trained. It is available inside experiment one. Okay, so I'll give experiment one. Okay, and base.pt and device is equal to 0. Now if I execute, see, it will show me the evaluation. That means it will utilize my model. Okay, right now the model I have trained. Okay, see, this is the average precision I got. Okay, this is the average precision I got. Now what I have to do, I have to inference. Okay, I have to inference. Now if you want to check that particular evaluation matrix, so inside train, it has created validation. Now see, this is the prediction.json. Okay, it will give you all the accuracy and all. Yeah, but if you don't if you don't want to see that, you can or directly see the inference. Okay, you can also open that JSON file. You can try to understand the losses and accuracy you got. Okay, now I'll finally do the inference. Okay, on top of my test data. So here, let's do the inference. Okay, first of all, I will upload one. I will upload one image here. Okay, so let's upload one image. So hello.jpg, let's upload image. Inside train, I am having one image called hello. Hello, hello, hello. Where is hello? I think I can check inside the validation. Yeah, hello. So this thing I think I can take. So I'll just try to drag and drop. Now I'll rename it. I'll keep it only hello. Hello.jpg. Okay, now let's load this particular image. So it should be hello. Okay, so no such file hello. So I need to give the proper location, I think. Yeah, so this is the hello image. Now let's do the inference, okay, on top of the model I have trained. So this is the inference command, guys. So you have to just execute Python tools infer.py, give the weight. So it is having experiment one, and this is the weight, okay, base.cqpt, and image is hello.jpg. Okay, so here you have to give the full path of the image. So sorry, I think I have to write copy path hello.jpg and dataset.yaml. Okay, so now let me execute. Now inference image has been saved. If you want to render it, so this is the command you can execute. Okay, now this hello inference is present inside YOLO V7, YOLO V6, inside drons, inside inference, and inside experiment. Okay, this is the hello.jpg. This is the final prediction. Okay, now if I open it up, see it is detecting as hello. Okay, see detecting hello with the confidence score of 74%. Okay, now if I open it, if I show you, if I render on the notebook, we can also see the inference image. See guys, okay. So that's how we can perform on top of the testing images. Whatever user is giving any kinds of image, you can perform the testing on top of it. Okay. So that's how actually you can do our custom training with the help of YOLO V6 on our custom data. And I hope you will like this particular session actually. If you have liked it, please share this particular session with your friends and family so that they can also learn. Can you share the link of the dataset? Dataset link is already given in the notebook. Who is asking Gaurav, as you can see here. So here is the dataset link. Okay. I already shared this particular notebook in the chat. So let me again share. Otherwise, you will also get the resources section. Okay, just check out our resources section. There actually you will get. Okay. So with that, guys, this is all from this to this session. So tomorrow I'll be explaining about YOLO V7, how we can perform the object detection with the help of YOLO V7, and we'll be also training one custom model. Okay, on top of our custom data. So with that, guys, thank you so much for watching the session. Okay, and let's connect tomorrow. Okay, and bye everyone. Take care. Bye. So today in this particular session, actually, we'll be learning about YOLO V7. Okay, and this is the state of the art object detection algorithm, as well as they have already created the GitHub on top of it. So we'll be exploring this particular GitHub, and we have already seen like how we can perform object detection with the help of YOLO V5, YOLO V6. Okay, and we have seen like how we can annotate our custom data with the help of different tools and all. Now, in this particular video, I'm going to show you the entire YOLO V7 like technique, how we can use it in our projects, how we can create our object detection project on top of it, and how we can utilize our custom data, okay, for the fine tuning purpose. Let's say I will be picking up one like a state of the art model of the YOLO V7, and that model actually I'll be trying to fine tune on top of the custom data. But before starting with the session, first of all, I will give you a brief introduction of the YOLO V7, like what is exactly this YOLO V7, and what is the, let's say, performance of this particular YOLO V7, why it is better than your YOLO V5 and YOLO V6. Then I think you will be getting some idea about this particular YOLO V7. Even I will also show you the research paper of this particular YOLO V7. There are so many blogs actually people have already written on top of it. Let's say if you want to deep dive in this particular YOLO V7, if you want to understand the architecture and everything, you can also get from there also. Now, before starting the session, what I will do, first of all, let me show you the resources where you will get all the resources I have shared so far, because today is day 5 and we have covered so many things. So let me show you where you will get all the resources. So for this, please visit our website called iNeuron.ai, and inside that, make sure you have one account, and after that, just go to the community program, and here you will able to see my course called this one actually. Let me show you, computer vision hands-on. Now if I click on this particular course, let's say explore, now make sure you have logged in with your account. So I already have the account, I will log in. Otherwise you have to create one account and you have to enroll for this particular course, and this is completely free. Now let me enroll for this particular course, and here I will open up with this particular email address, because I have already enrolled this course in this particular email. Okay, so now here I will go to the courses, And this is the courses, and here you will see all the videos, all the resources has been already updated. And you will also find the assignment and quizzes. So let's say if you want to explore about the assignment and quizzes, let's say if you want to evaluate yourself whether you are learning correctly or not, so you can attempt these are the assignment and quizzes. So everything you will get in one place. Even if you see all the resources I have shared, it is already available inside the dashboard. All right, guys. So now I think you got the understanding of this particular dashboard and everything. Now, first of all, let me give you some brief idea about YOLO V7. Then I will start with the practical implementation, how we can use this particular YOLO V7. We'll be also seeing that particular GitHub repository. We'll be doing the setup and all. Even today also, I will show you the annotation part, how we can perform the data annotation with the help of RoboFlow. All right. So here, what I will do, I'll open up this particular presentation I have prepared for you. See, guys, there is another blog actually you'll get on this particular YOLO V7, and this is completely amazing blog actually I got. And here, if you see everything, like they have explained about this particular YOLO V7, like how it is performing better than your YOLO V5 and YOLO V6, and see the detection actually. I mean, example they have already given. Then they have also given the model variant, actually different model variant. See, if you have very complex, let's say image, let's say in this particular image you can see there are so many objects, okay, so many colors and so many, let's say, gesture and everything, right? Still it is able to figure out that particular person in a correct way. As you can see, this image resolution is not a, you can say, easy image. Actually you can see there are lots of actually image like features you can see. Let's say this one is there, like building construction is going on. So there are so many things in the image background, but still it is able to find that particular person, okay, with the help of this particular YOLO V7. And if you see, the confidence score is very high. So 78% confidence, this is a person. Then 87% confidence, this is a person. Then 89% confidence, then 35% confidence, because this person is almost hidden. As you can see, it's not completely like visible, but still it is able to trying to detect that particular object. So you can use this particular YOLO V7. Let's say if you have very tiny object present in that particular image, you can still use that one, and you will get good accuracy, good performance, okay, from the YOLO V7. And some of the times actually you will see your YOLO V5 and YOLO V6 may fail in that particular case. That time you can start with this particular YOLO V7, because they're claiming that one, if you have very tiny objects in that particular image also, it can still able to detect that particular objects. Okay, this is the complete idea. Now they have already given the GPU performance, and see, uh, I was talking about that particular smaller object present in the image. Now if you see here, this is like very I mean, like bigger images. As you can see, they have collected like with the help of drone. I think drone captured image. Now on top of the actually this one, actually on top of the floor, actually you can see there are some employee they are working, and still it is able to detect that particular employee. Okay, as you can see, and it is also detect this particular bench. So if I open this particular image in a new tab, and if I zoom this particular image a little bit, just a minute, let me zoom. See, guys, it is detecting this particular bench as well. Person. See, still this person is getting detected. Okay, although this person is like very smaller object, it is still able to predict that particular person. And the confidence score, you can see it's like pretty good. Okay, almost it's pretty good. So yeah, so we can export this particular YOLO V7. We'll be learning like how we can do on top of our data. Then we'll be I think understanding. See, this is another image. So this is a satellite image, I think, and they are detecting this particular aircraft, okay, on the, I think yeah, so this is the aircraft. And again, this is the masking. You can also perform like masking with the help of YOLO V7 as well. I'll tell you in the GitHub repository whenever I'll be visiting. Then you can also perform something called this one. See, night object detection. So this is a night image, still it is able to detect this particular object, so in a good way. Then hmm. So these are the thing, and this is the benchmark, and all they have already given all the comparison of the YOLO V7, YOLO R, YOLO V5, all the comparison they have already given. Now what I have done, I have just taken some of the screenshot on this particular presentation so that I can explain how this model is performing and all. So as you can see, YOLO V7 is nothing but it's a fastest and most accurate real-time object detection model for the computer vision task. The official YOLO V7 paper, named the YOLO V7 trainable bag of freeby sets new state of the art for the real-time object detector, was released in July 2022 by Chien Yo Wang, okay, then Alexi, then Hong Yong, Leo. The YOLO V7 research paper has become immensely popular in a matter of days. The source code was released and open source under the GPL 3.0 license, a free copyright license, and can be found in the official YOLO V7 GitHub repository. I'll tell you why you will get this particular uh, like repository of the YOLO V7 official GitHub YOLO V7. There actually you can clone that particular repository and you can use this particular amazing algorithm. Now, as you can see, there are some different model variant actually will get in the YOLO V7. So there are three major model actually they are considering called YOLO V7, YOLO V7 Tiny, and YOLO V7 W6. Now let's see what is YOLO V7, what is YOLO V7 Tiny, and what is YOLO V7 W6. As you can see, YOLO V7 is the basics model that optimized for the ordinary GPU computing. Let's say whatever GPU you are having, whatever GPU actually you are using, let's say in your Google Colab or let's say in your system. So it is optimized with respect to that particular GPU. And there is another model called YOLO V7 Tiny, is a basics model optimized for the edge GPU. So let's say you want to work with the edge devices. So you have very small devices, let's say microcontrollers and Raspberry Pi and all. At the time, you can use this particular YOLO V7 Tiny model, and this is optimized for the edge GPU. They're already telling this is optimized for the edge GPUs. And suffix tiny of computer vision models means that they are optimized for edge AI and deep learning workloads. Okay, that means let's say if you're working in the field of robotics and all, there actually you have to deploy this particular model in the edge devices, because let's say you want to like implement a robot. That robot can detect any kinds of objects and it can recognize that particular objects. That time actually you have to deploy this particular model in the edge devices. That's whatever microcontrollers, Raspberry Pi, or let's say Jetson Nano you are using, you have to like mention that particular model in that particular edge devices. So for this you have to use this particular tiny model. And there is another model called YOLO V7 W6, is a basics model optimized for the cloud GPU computing, such as cloud graphics units. Then you can see here running applications handle massive AI and deep learning workloads in the cloud with the GPUs that are deployed on the local user device. So basically, what they are telling, this is a like very bigger model. If you are having, let's say, cloud-based GPU, let's say A100, B100 GPU, if you are using, or any other GPU you are using, at that time you can go with this particular model, and this particular model will give you like very high accuracy. So although this model would be a little bit let's say inference wise it will be a little bit slower than your tiny model and YOLO V7 model, but still you will get like higher accuracy. Let's say you are working in the medical domain, there you are worrying about the accuracy a lot, and you are not worrying about the speed of the model. That time you can go with this particular model so that you can get a higher accuracy, so that your model might not miss anything. Whatever you are trying to detect, everything will try to detect, but make sure your annotation should be perfect in that particular case. Let's say if your object is very small, you have to annotate that particular object in a good way, then your model will able to learn whether there is any object or not. Whenever I was doing the data annotation, I think I showed you. So today let's take a very, let's say smaller object data set and try to like annotate that particular data. Okay, then I think this should be more clear. Fine. Now next, see what is the next. So yeah, I already given you the introduction of the YOLO V7. So YOLO V7 is nothing but it's a very fastest and state of the art object detection algorithm, okay, of the YOLO series. Now, as you can see, the performance of the YOLO V7 in the object detection. So they have trained with like say different model, as you can see, and this is the parameter of the model, this is the size of the model, and this is the average precision of the model. Now, most of the cases actually, if you see YOLO V7 is performing well. Okay, as although they are using tiny model, still they are able to let's say achieve a 52% AP score. That means average precision score. And whenever I'm talking about YOLO V7, the base model, they're acquiring 67% average precision. And whenever they're using this W8, I think, let me check this particular weight. I think they haven't mentioned this W8 here. Okay. Now, right hand side, you can see this particular image, and here you can see the benchmark. So they're using YOLO V5, Scale YOLO V4, YOLO X, okay. Then PP YOLO E, YOLO R, and YOLO V7. Now, most of the cases actually you can see they are performing on the V100 GPU, and your time is increasing. That means time is like FPS is increasing and accuracy is also increasing if you're using this YOLO V7 model. As you can see, this is the average precision it achieves with the higher inference speed. Okay, as you can see. This is the graph. Actually, it will give you all the understanding of the YOLO V7, why it is better than the other model. And they are telling YOLO V7 is 120% faster than other model. Okay, as you can see, this is the actually your frame per second speed, around 28 frame per second speed, and they're getting actually around 50 actually, yeah, 57% actually average precision. As you can see, as I already told you, 57% average precision it is acquiring. Okay, can you share some industries and application of this model? There are so many application you can actually build. Let's say you can build a vehicle detection. You can build, let's say, in sports industry, they are using this particular algorithm to detect that particular player and balls. If you see, they will be doing real-time tracking, real-time, let's say, detection of that particular players and balls, so that they can get all the data. So it is already used, okay, in the industry. So you will be utilizing the detection technology to perform this kinds of tracking task, because first of all you have to detect that particular objects, then you will be applying the tracking algorithm. Fine. Now let's explore the paper of this particular YOLO V7. So what I will do, I will just open this particular paper. So this is the paper link also I have given. So this is the official paper of the YOLO V7, and the name of the paper is Trainable Bag of Freebies Sets New State of the Art for Real-Time Object Detector. Now these are the author, and as you can see, this is the abstract of the paper. Whatever things I told you in that particular presentation, everything they have mentioned here. And this is the same benchmark, let's say, graph I already showed you. They are testing on V100 GPU, and they introduce this particular model. Okay, so see, this is the model architecture. They're using VoVnet, then CSP VoNet. Okay, they're using different network, okay, in this particular architecture. But see, the working mechanism are same only. The base model actually you have seen of the YOLO, they are applying this cells wise detection. It will first of all convert your image to the grid, and each of the grid will try to predict whether there is an object or not. The base concept will remain same, but on top of that, they're adding some more custom layer. They're modifying that particular custom layer, and they came up with this particular architecture. Because if you already work with, let's say, image classification, or let's say convolutional neural network, you already know how we can define our custom CNN architecture. Yes or no? We define our custom CNN architecture, and when we define our custom CNN architecture, so we can modify like lots of things. So let me just write down some of the point. So whenever, let's say, we're working with the convolutional neural network, so convolutional neural, that means CNN. Okay, CNN. So what we do usually, first of all, we define the conv layer. Okay, conv 2D layer. Okay, conv 2D layers. Then we play with max pool. Okay, max pool layer. Max pool, max pooling layer. All right. Then we have different layers. Actually, if I search any kinds of CNN architecture, let's say if I search for VG16 architecture, VG16 architecture, so you will see different layers are there. So if I open this particular image, yeah, so as you can see, this is the architecture overview. So they are using conv layer, that means convolutional neural network layer, pooling layer, that means max pooling layer, or let's say average pooling, whatever things actually. I mean, they're also using there. Some of the architecture will be using max pooling, some of the architecture will be using average pooling, some of the architecture will be using mean average pooling. Okay, that's how they'll be using different pooling layer as well. Then see, some of the actually layer is having more convolutional layer, some of the layer is having less convolutional layer, and at the end they are also using something called dense layer. Okay, that's how they are implementing the entire complete this particular convolutional architecture. That means this particular architecture will help you to extract the features from the image. All right, this is the idea. 3D for video. Yeah, so let's say if you are having 3D image, so nowadays actually we are also having 3D image. Let me show you. We are also having 3D image. So for 3D image also, we are having the convolutional layer also. See, this is the 3D image. So if I can open one 3D image, see, this is another 3D image, as you can see. So there is another actually layer you will get called conv 3D, conv 3D keras. See, that's how actually your layer will look like. That's how your architecture will look like. So it will have 3 channel that time. Okay, it will have 3 channel that time. See, because it is having 3 axes whenever I'm talking about the image. So let's say whenever I'm talking about 2D image, so your image would be look like that. So you're having here X and Y. But whenever I'm talking about 3D image, so your image will look like that. So let's say this is X-axis, this is X-axis, and this is Z-axis, this is Y-axis. Okay, that's how. So let's say this is X, this is Z, and this is Y-axis. So inside that you will have that particular image. Okay, let's say anything. It would be like, let's say I can draw one image. I can draw one box actually in 3D space. Okay, now you can see there is a depth also. This is called depth. Okay. So if you want to let's say work with this particular 3D image, at that time you can go with this com 3D layer in Keras. It is already available, com 3D. See, that's how you can import. So basics of this convolutional layer like idea is needed if you want to work with this particular custom architecture and all. So you should know what is padding, what is stride, everything. You should have the idea, otherwise things would be much difficult for you whenever you will be defining your custom architecture for this. And this 3D like image computing is it is like very let's say computationally expensive, because it is having, let's say, 3 dimension. So whenever you are extracting the feature from the image, so it needs like lots of computational power. So there you should have good GPU computing power, otherwise things would be much slower. But whenever I'm talking about 2D model, 2D image, at a time this is like very easy to extract the features from the image, because it is already having X and Y feature only. Fine. So that's how actually you can see the paper. They have already written everything. So if you want to deep dive in this particular architecture, you can go with the paper, because paper will give you the entire understanding of the algorithm they are using. See, so all the benchmark, everything they have given, even the reference also they have given. And yeah, so everything they have given. All right. Now let's try to see the data format for this particular YOLO V7, because for the YOLO V5, YOLO V6, we have seen the data format, like how we can prepare our data format. But for YOLO V7, there should be slightly different whenever you are preparing the data. Let me show you how this data format will look like. So I already prepared the data for you. So let me first of all download from the URL. Yeah, so this is the URL, and here my dataset is available. So it is getting downloaded. So once it is downloaded, let me unzip and show you. All right, so this is the format of the image. So this is the folder structure. So you have to prepare the folder structure like that. So basically, first of all, you should create a folder called image. Inside that, you will be getting your validation and training image. So see, this is my validation and training image. So I'll be using the same image actually I annotated before, that sign language image, but you can use any image here, because this image actually I already have the annotated with me. That's why I'm going to use this particular image, but you can go with any other image also. It's completely fine. Now this is my image, this is my training image, and this is my validation image. You can see this is my validation image. Now with respect to the training image and validation image, again you have to create another folder called labels, the way actually you did for the YOLO V6 as well. Now inside that you will have the all the annotation, okay, all the txt annotation. And what is this txt annotation? This is the annotation file we'll be generating through the RoboFlow. I think you remember we used to annotate the image, right? And this is the annotation file will generate by the RoboFlow. All right, and this is the label name. That means this is the class name, and this is integer encoding form. And if you want to understand what is five mean, what this 5 is telling me, so you can go to this particular file. Let me show you. You can go to this particular file called classes dot names. Okay, I think this is the file structure. Let me open in a notepad. Yeah, classes dot names. Okay, the name should be classes dot names, guys. Okay, classes dot names, this should be the extension. Now here you have to define this particular labels in a order wise. Let's say I got to know there is a five label written in that particular txt file. Now just count 0 1 2 3 4 and 5. That means that image was telling it's a yes image. I was trying to say yes in this particular image. That is the complete idea. Yeah, I'll share the link with you. No need to worry. I'll share everything in the resources section. And even whenever I'll do the coding, at that time I also give you the notebook link. Fine. So now let me close it and see. And you need to create two more additional file called training.txt, train.txt, and validation.txt. And this should be completely empty. There should not be any content. Okay, this should be completely empty because I need it later on whenever I'll be preparing my data, because here I'll be extracting all the image location and here I'm going to save. See, this file is completely empty. So this is the folder structure you have to prepare, and your data should be in that format. Now what you have to do, you have to zip this particular data and upload in a GitHub, or you can upload in a Colab notebook, and from there actually we'll be using this particular data. But before that, let's see the annotation part, how we can perform the annotation. So I'm going to use one data set from the RoboFlow universe. So let me open the RoboFlow first. So let me close this at the tab. So I'll be opening the roboflow.com. So here I'll sign up with my account. No, if you're using RoboFlow, you don't need to manually do it, Monica. RoboFlow will automatically do it for you. I think I already showed you, right, in the RoboFlow platform. But let's say if you're using this particular tool called label IMG tool. So there you have to manually prepare the folder. So this is another tool for data annotation, bounding box annotation. Fine. All right. Now what I'm going to do, I'm going to open up my RoboFlow, and here what I will do, I'll go to the universe. First of all, get one tiny data set from here. So I will take like smaller object so that I can also show you how to like annotate the smaller object from here. So let's say I'll be using like one data. Which data should I use? Basketball players. Just a minute. Let me figure out one good data. Maybe basketball image should be good, because here I need to annotate the players. Okay, and players should be smaller objects. So let's open this particular data, and I'm going to export this data. So here is the export, download this particular data, and download it as a zip file, and let's continue. I will only download the image. So for this, what I will do, I'll select the YOLO V7. Okay, YOLO V7 format. Now let's download. Now see, it is getting downloaded. So once it is downloaded, let me show you. Now see, basketball data has been downloaded. Now let me extract. Extraction is completed. Now if I show you, so this is the data format, the format I told you, but they haven't kept that train.txt and validation.txt. These two files you have to create by your own. So they will only give you the folder, like training folder. Inside that you have the image and labels. Okay, that's how they will give you. Now here, if I open the image, as you can see, so we are having different images of the player. So let's open the player image. Let's say we are having different image of the player, and like it is like very smaller. Even we have also handball and all, right? So let's upload this image in my RoboFlow and try to see how we can perform the data annotation, okay, of this particular smaller object. So what I will do, I will use my validation data, I think, because here you will have like less data points. Only 18 images is there, right? So let's upload some of the images from this particular folder. Then I can start the annotation. Yeah. See, this image actually they have collected from the television. Okay, so television, like they have taken the screenshot, I think. Television or computer, I think they have taken the screenshot from the video frame and all, right? So that's how they have collected this particular image. Now what I will going to do, I'm going to upload this image in my RoboFlow platform. So let me do it. So I'll open up the RoboFlow, and here I'm going to create a new project first of all. Give the project name. So let's give anything. Let's say YOLO V7, YOLO V7 demo. This is the project name. Annotation group. Let's say I want to detect the player. Okay. And make sure you're selecting object detection because we are performing object detection, and create a project. After that, I have to drag and drop my image. So let's take, I'll be taking, let's say 5 to 6 images because there are so many objects. So it will take time. I think let's take 8 image, I think, or let's say 10 image. 10 image is fine. So I'll try to quickly drag and drop. Now I'll click on save and continue. But make sure whenever you are uploading your own data, and you have to upload the entire data you are having, entire folder. I'm just taking 10 example because I just wanted to show you here. Otherwise it will take time for me. Now let's start the annotation. I'll start manual labeling. You can also do the auto labeling. They are having their auto labeling tool as well. But you have to take their premium subscription that time. But I don't want to take the premium subscription. I will be going with the start manual labeling. Now assign the image. Now I'll start the annotation. Now see, I'm having different players. Now what I have to do, I have to create the bounding box tool and detect this particular player. So this is the player. Make sure you are doing in a perfect way. See, this is not perfect. So what I will do, I'll delete it. Again, I will select. Again, I'm going to annotate. So the more perfect annotation you'll be doing, the more like good learning your model will be. So now this is a player. Enter. This is also player. Enter. If you want to detect the ball also, you can also detect this particular ball part. So this is nothing but my ball. Save. Now here is the player. This is player. See, this is the referee actually. If you want to detect the referee as well, so you can assign as a referee, because referee will have any other colored dresses. Okay, if I show you, player having different, let's say colored dress, and referee having different colored dress. Let's say you can also differentiate. Let's say this is a white player, or let's say player 1, and this is a player 2. That's how we can also annotate the data. But all the like person I can see here, I'm considering as a player. Okay, in this particular example, that's it. Now here I'm going to detect this thing as a player, and this part also. I'm doing it quickly because I want to complete all the 10 images I'm having here. Otherwise it will take time. So whenever you are doing, so make sure you are doing perfectly. Done. Now if it is done, now click on the next and start annotating on the next image. So this is player, and this is the referee. I will ignore the referee. I'm not going to annotate. So this is again player. This is also referee. And this is a player, and this is also player. And there is another player I can see here. So this is also player. Fine. So once it is done, I will go to the next image. So here is the player. This image actually I won't be picking up this object because it's not visible properly. I can take this particular object. This is also player. And I'll go to the next image. So here is the player. And here is the player. This is also player. Now let me just complete all the 10 images quickly. So I'll consider just some of the part of the image instead of annotating all of them because it will take time. Let's say it is completed. I'll go to the next image and here I can annotate. So after the session, you can try with this particular data, guys. Everyone, you can try with this basketball data with the help of YOLO V7. But I already have the annotation of my sign language. That's why I'm going to use the sign language. But the process will remain same. Only you just need to change the data. That's it. Do we need to annotate only the object which we need to detect? Yes, correct, Monica. Let's say you want to only detect player, not the ball, or let's say not the referee. That time you have to only detect the player. It's up to you which particular object you want to detect. Let's say I want to detect the smartphone only. That time I'll be only annotating the smartphone part in that particular image, not any other objects. Fine. Because in a image actually there would be lots of objects, so you are not supposed to detect all the objects in that particular image. Whatever things you want to detect, only you just need to annotate that part only. That's it. This is the idea of the object detection. Do you need to annotate it every images? Yes, you have to perform for all the images, okay, but having here. Now let's say this is my last image, so I'll complete the annotation here also, and we are done. Now what I have to do, I have to go back and I will add all the images in my dataset, and it will automatically perform trained validation and test for you. So now click here. Does okay, I got another question. Does how does the model know that only players need to be detected? uh, is it by the uniform, and what if the crowd wearing the similar clothing would be the detecting as well? No, see, whenever you perform the, let's say, annotation, so if I open up one image, so let's say whenever you perform the annotation, so most of the object you can see it is located at the middle position of the image, because if you see the annotation I have done, most of the like image is located at the middle position. As well as if you see this player is moving, okay, player is moving, let's say this image gesture is changing. But if you check the audience here, so they are just sitting down on the background, so it won't be considered. So your model will automatically get to know by the annotation file you have done. Okay, you want to try to detect this particular part, that means the player present in that particular image. And if you check out this player wearing a different actually uniform, okay, then your other audience they are sitting here. Why are we going to use YOLO V7 instead of YOLO V9? Okay, so Carla actually were asking this particular question because if you don't know, we have started computer vision hands-on series, and here we are exploring everything, not only YOLO V8 and YOLO V9. We have started from YOLO V6, sorry, YOLO V5, then we completed YOLO V, if I show you YOLO V6, then today we are learning YOLO V7, tomorrow we'll be learning YOLO V8, and after tomorrow we'll be learning YOLO V9. All the series will be exploring. Carla, got it? So it's not like that I'm going to only use the YOLO V7 and YOLO V8 and YOLO V9. It's not like that. So you can check out our YouTube channel. So in the live section, or if I go to the playlist, maybe you'll see the, yeah, so computer vision hands-on. See, we have started from the image classification with the help of TensorFlow. Then we have also seen the PyTorch. Then object detection using YOLO V5, V6, today's V7. Got it? Now let's create the version of my data. I don't want to perform any pre-processing. I will skip this part, continue. And augmentation I don't want to do, continue. And let's create the data. Now I'll export this particular data, download as a zip file, continue. All right, my data has been downloaded. Now if you unzip that particular data, you will see the same folder structure. That's how you have to prepare the data for the YOLO V7. Okay, one thing I haven't done, I have to export for the YOLO V7, not V6. So this is the YOLO V7. V7 PyTorch. Make sure you are selecting this particular format, YOLO V7 PyTorch. Then download as a zip file. That was my mistake, sorry. Now it will download that particular specific folder structure for you. Now let's see how we can utilize this particular YOLO V7 and how we can perform the custom training on top of it. So for this, what I'm going to do, I'm going to open up a Google Colab. I will create a new notebook. Just a minute. All right. So the first thing what I have to do, I have to name this particular notebook. Let's say this is YOLO V7 custom training. And I will connect my GPU here. Then let's connect the notebook. So the first thing what I have to do, I have to clone the YOLO V7 repository. Okay, so let's say this is my official repository of the YOLO V7. So I'll open it up. And this is the official YOLO V7 repository. And Wong Kin Yu, I don't know how to spell, but this is the guy or organization, they have proposed this particular uh, GitHub repo. Okay, and you can see they have already given everything, and these are the baseline. That means these are the models you can use. So it is having different model. I think later on they have published some other model as well, and they have already given the guidance how to use it and all. So you can export here. Now what I'm going to do, I'm going to quickly install this particular YOLO V7. First of all, I have to clone it. So to clone it, so this is the command you can execute. I already written. So here I'm going to paste it. Now let me clone. So it is cloning and it is installing the requirements. Okay, inside that I'm having the requirements. So all the requirements is getting installed right now. And again, it's like very easy to use. So you have to write some of the command and you can start the training. I'll tell you, but some of the configuration you have to do. After that, everything would be ready. So once installation is done, you have to download your data. So I already have the data in my URL. So here is the data. So it will download the data and it will unzip it. So here I can write your custom data. So it is getting downloaded. Let's wait. Okay, I have to restart the session. So let's start the session. Okay, now I think restarted the session. Now what I can do, I think I can download my data right now. Now what I have to do, my data is downloaded. Now if I show you my data, see data is downloaded. Now the first thing what I have to do, I have to collect the image location. See all the image location I am having in the image folder, all the image location, that means all the image path. Let's say this is the path, complete path of my image. So this path I have to collect and I have to extract this path and receive in the txt file. This is the complete idea. So let's do it. So for this I have written already one script. First of all, you have to import ways. Then let me just comment it out, prepare image path in a txt file. So here we are doing the, so let me delete this part. Prepare image path in a txt file. First of all, I need to import ways. After that, I have to define the folder path. So let's say this is my folder path. So this is my folder. So this is my image folder. Inside that I'm having the train folder, as you can see. So I will just copy the path and here I need to mention. And similar wise, I also need to do for my validation folder. I have done. Now let me execute. Now with the help of this particular path, I will extract the entire path of the image. So first of all, let me change my directory to content. Now I'm going to execute this particular snippet. So basically it will open up the txt file. It will take all the path. It will take all the path one by one and it will save inside the txt file. Now see, if I open up the txt file, so by default it is completely empty. There is nothing. So if I also open up the validation txt, it's completely empty. There is nothing. So now once I will execute this particular snippet, you will see all the path would be saved automatically. Now let's say if I execute, now see done. Now if I open the training.txt, now see all the path has been saved from my training image and this is the complete path. So your YOLO V7 always take the complete path of that particular image. Otherwise, sometimes you will get path issue, path error issue. So that's why this is important. Whenever you are training the model, you have to define the path in a correct way. The entire path you have to give here. And this script will automate this your process. Okay, so it will automatically take the path and it will save in the txt file. That's it. Then you have to also do it for the validation image. So this is the validation image. Now if I open the validation txt, now see all the path has been saved one by one. All right. Then next, what you have to perform, you have to download the pre-trained weights. Okay, but before that, if I show you my YOLO V7, and inside that you are having one data folder. Now inside that you are having this coco.yaml. So this particular file I have to change with my custom label I am having. Let's say number of classes I'm having 6, and all the label I have to mention like hello, I love you, yes, everything I have to mention. So for this, I'm going to create a copy of this particular file. So this is the command you can execute. cp command. Now if I refresh, now see guys, a custom YAML has been created. Now inside custom YAML, I have to mention my custom. I have to mention my custom code. Okay, now let me show you what thing you have to mention here. So this is the custom code. Now here you have to specify the txt file location. Now this is my txt file location. I'll copy the file, copy path, and here I can mention. So this is my train.txt and this is my validation.txt. Number of classes is equal to 5 and all the classes I have given. But again, it's another image. Actually, I think I have to mention for the this object. So hello, I love you, yes, and please, thanks. Okay, let's copy. So here I think I can mention. So first of all, I'll mention hello, then I love you, then no, then please, then thanks, then yes. Then I will remove it. And number of classes I'm having 6 right now. Yeah. So now I'll save it and I'm going to start the training. But before that, I have to get the model first of all. So let's get the model. So to get the model, you have to execute this particular code snippet. This is the code. So here I'm giving the model location I want to use. So how will get the model location? So go to the repository and here's the model view. Let's say I want to use this particular model. Just copy the link address. I'll come here, copy the link address and try to mention it here. It will download the model in the YOLO V7 folder. See, it is getting downloaded. Now if I refresh, go to the YOLO V7 and here is the model, guys. YOLO V7 PT. It has been downloaded. Now I can, what I can do, I have to change the configuration file. Okay, let's change the configuration file as well. So inside configuration, if I show you, inside CFG, I have this particular training configuration. And there is the model I'm using called YOLO V7 YAML. This is the model I'm using. Now if I open it up, now here if you see, I have to change this particular parameter NC is equal to 6 and everything will remain same. But I'm not going to change this particular original file. I'm going to create a copy of the file first of all. Let's create a copy of the file. And if I refresh, now see, it will create a copy of the file in that same training folder, custom YOLO V7. Now I'll open it up and here I need to mention number of 6. That's it. Now I'll save it and close it. Once it is done, now I can start the training. So begin the training. So here is the training command. So if I show you, so inside YOLO V7, you are having one file called train.py. See train.py, because if I show you my current working directory, so if I just execute pwd, so I'm inside my current working directory called YOLO V7. Now inside YOLO V7, I'm having this train.py. And inside train.py, they have already written all the code related training, how to perform the training and all, everything they have given. So I'm going to execute this particular file, batch size I have given, and configuration I have given, the configuration I created, that custom YAML in that particular training folder, I think, remember. And number of epoch, I said 100 epoch. So let's train 100 epoch only, or else let's take around 50 epoch because it is going to take time. Now here I have given the data, that means the custom data YAML I created inside the data folder, this custom YAML. And here I have given the weight, like which particular model you want to fine tune. So this particular model I want to fine tune. Then device is equal to 0. That means you want to perform GPU training on a single GPU training. Now let's start the training. So it should work. Let's wait. See, my architecture has loaded and it is starting from the epoch. So epoch has started. That means training has started right now. Now it will take some time. It will train 50 epoch. Then I think I can show you the prediction. I think I could have used my premium GPU instead of this free Colab because it will take time. Okay, so 2 epoch is going on. So let's wait for some times and then I think I can show you the prediction. If we are changing the model layers, in which part we will do the changes? It is not recommended to change the model layer, Monica, because and the model they have trained, they have already given. You can only change the let's say some parameter of the model. So if you want to change, just go to the configuration training, and here is the model configuration. All the anchor box, all the backbone. Here you can change convolutional layer. max pooling. Okay, everything you can sense here. But you should have architecture level understanding. Otherwise, you can't do it. Okay, so 8 epoch is going on. So let's wait. I think I can train 50 epochs, then I can show you. And left hand side in the YOLO V7, you will see it has created one folder called runs. Let me show you. And inside runs, it will save all the artifact. So see, runs folder has created the same thing. Like all the, let's say YOLO we have explored, every YOLO will create the runs folder. And inside runs, it will save all the artifact. See, this is your weight, final weight, base.pt. And these are all your matrices and results. I'll show you the results and matrices once this training is done. First of all, let's wait for the training. And if you want to get this particular code, let me share the notebook. Otherwise, I will also share in the resources section. So here is the link. The next code, what you have to write, you have to evaluate. That means the inference code. So this is the inference code. detect.py, and here you have to specify the model you have trained. The model you have trained, that means the base.pt from the runs folder. And here you have to give the testing image. That means what is the source actually you want to test. Let's say I will give one image called hello, and I'll try to predict it. Then you can also visualize that particular results. Okay, for this you can execute this particular code. So let me upload one image in the YOLO V7 folder. Upload. I'm going to upload one image. Hello image. Okay, let's say I'll upload this particular hello image. Now let me rename it. Now this is the image I uploaded. So this image I'm going to test. 20 more epochs are left. After that, I can test the model. And what should be your task? So you can use this particular data, this basketball player data, and see this data is already annotated. You can directly download and you can use it. And on top of the data, actually you have to train this particular YOLO V7. So you can try this part. Or let's say if you're having some smaller object you want to detect, you can also use YOLO V7. You will get the good accuracy. Can you show the display inference coding part? Yes, so this is the coding of the inference. So here I'm using globe, and I'm also using something called image, okay, from the IPython kernel. So with the help of that, whatever image actually it will predict, I'll try to render on top of the Jupyter notebook. That means on top of the Colab. There is nothing. 41 out of 50. Now this is the memory utilization. So it is using my GPU RAM a lot. Almost 13 GB it has utilized. Okay, so two more epoch left. Then after that, we'll test the model. We'll detect the source image I have here called hello.jpg. So here is the hello.jpg I uploaded. Okay, should be hello. Should be capital H. So it's done. You can see all the MAP score and it is learning better. for all the classes. Now finally it has saved all the weights in the runs folder. The runs folder, I show you the runs folder. Inside that all the artifact has been saved. See, all the artifact results, everything, it has been saved. See, this is the final results. Okay, loss and accuracy. So you can export the same thing. Now what I will do, I'll quickly do the inference on top of the hello image I have given. Now if I refresh, it will create another folder called detect. Inside that it will save that particular detection image. Done. Now if I refresh, I will get that particular image. Now if I open it up, see, it is detecting hello. Now if I show this particular image also, now see, this is the hello image. This is the final detection. Now you can place any kinds of image and you can do the detection. See, although it in 50 epochs and still the accuracy is like great. Fine. This is the power of YOLO V7 you can utilize, and you can try with different data set. So yes guys, this is all from my side, and from this particular session today. Today we have explored the YOLO V7, and next class we'll be learning about the YOLO V8 custom training as well as the YOLO V9 custom training on top of the custom data. So I hope you like this particular session, guys. If you have liked this particular session, so please subscribe to our channel and share this channel with your friends and family so that they can also get to know this kinds of community session is going on, and it's completely free. How can we save the model on our Google Drive? So you can download this particular model now. From here you can directly download. So let's say this is my model. In the runs folder, in the runs I'm having the model. Let's say in the train experiment wait, so here you can download it. See, there is a download option is there, download. So you can download it, you can upload in Google Drive, you can use in your local machine, anything you can use. Yeah, thank you Monica, and thank you everyone for joining the session. So yes guys, this is from my side. So bye everyone, take care, and I'm going to end the session right now. Thank you. Okay, I think I'm audible, guys, to all of you. So welcome to today's session. Actually, so today actually we'll be exploring one amazing object detection algorithm called YOLO V8. So as of now, we have seen different object detection like framework and algorithm. Like we have started from YOLO V5, we have explored YOLO V6, as well as we have also explored YOLO V7. So today I'm going to show you how we can utilize this particular YOLO V8, and we'll see that why YOLO V8 is so popular and why it is like so powerful than your YOLO V7 or YOLO V6. Okay, any other let's say you have learned so far. So that's actually we'll be also exploring the YOLO V9 one in the next class. So YOLO V9, I think this is the latest one. So we'll be also exploring this part as well. So first of all, what I will show you, I'll show you the dashboard, like where you will get all the resources whatever we have done previously. So for this, make sure you just go to our website, and here just go to the community program. And if I go to my courses here, so let me show you. So this is my courses called Computer Vision Hands-On. Now go to the courses and make sure you have signed up with your account. If you don't have any account, you just need to create one account. After that, you will be enroll for this particular course, and this is completely free. So for me, I have already enrolled for this particular course. I'll go to the courses section. So today is day 6, and think till day 5 everything is up to date. As you can see, day 5 everything is up to date. So this was the last session I took of the YOLO V7. I was discussing the YOLO V7, how we can train this YOLO V7 on top of the custom data. And here is the resources as well. The resources actually I have already shared in that particular session. Now here what I will show you, first of all, I'll show you the YOLO V8, like what is exactly this YOLO V8 is, and I'll show you the comparison. I will show you the benchmark of this YOLO YOLO V8. Then after that, I will start with the training part. So for this, actually, I'm going to refer this particular RoboFlow blog. So I think you know already we are using RoboFlow throughout this entire series actually for the data annotation and all. So RoboFlow has also their blog site actually. So they have written different blog on the all the let's say object detection task actually we are having, or let's say any kinds of image segmentation, key point detection, whatever things actually you want to do, you can search here, you will get all the blog here. So you can refer this particular blog and you can also read it out, you can also try it out, okay, on your Jupyter notebook, and you can try to implement anything. So here is the blog actually they have written called YOLO V8. So YOLO V8 is nothing but it's a state-of-the-art object detection and image segmentation model created by Alterytics, the developers of YOLO V5. Now I think you remember I was showing the YOLO V5 example. So there I was using YOLO V5 GitHub actually, you can see. So this is the YOLO V5 GitHub, and the same like YOLO V5, okay, proposed by the Alterytics, this particular organization, okay, and this organization is also proposed this particular algorithm called YOLO V8. That's why they're telling created by Alterytics, the developer of YOLO V5. All right, now we can also go to the GitHub of the Alterytics. So this is the official GitHub of the Alterytics, and they have different product actually. So see, this is the current one, YOLO V8. This is the current one, and you can see the benchmark and everything. So they have already given. Okay, so you can go ahead with this particular GitHub and you can try to understand and see these are the contributor actually. So it is like huge contributor here. Now if I show you the last commit, so last commit was 16 hours ago only. So this is like very active research. Let's say if you are having any kinds of issue, if you're having any kinds of issue, just try to create an issue here. So it would be quickly resolved. See, it would be quickly resolved. So that's how actually you can track this particular open source contribution. Okay, let's say if you want to add something in this particular contribution, you can also add, you can create a pull request. See, some of the pull request has been already created. So different pull requests already created, they will verify from their end, and if it is fine, they will accept your pull request and you will be also become a contributor in this particular repository. Okay, that's how this is completely open source research. They're also telling if you know anything, if you want to add something extra in this particular repo, you can feel free to add it, right? So yes, you can export. Now let's see what is the next. So YOLO V8 is state of the art object detection and image segmentation model created by Alterytics. The developer of YOLO V5, YOLO V8 launches on January 10, 2023. So 2023, 10th January, this model was proposed. Now, what are the features actually it is having? A new backbone network, a design that makes easy to compare model performance with other older model, the YOLO family, a new loss function added, a new anchor free detection head. Okay, so these are the new technology they have added in this particular algorithm. And let me tell you, this particular YOLO V8 can be also used for the classification task, for the object detection task, and for the image classification task. For the image segmentation task. So these three tasks actually you can perform with the help of one particular algorithm. Okay, I think I was discussing about what is the classification, what is the detection, and what is the segmentation task, right? Now let's see if you want to perform all the tasks together, or let's say if you want to perform any kinds of task with the help of this particular YOLO V5, YOLO V8, you can feel free to do it, because it's also support classification, it also supports detection, it also supports this instance segmentation as well. Okay, I'll tell you how it can be done. I'll like at least take one particular demo, like how we can perform the classification. Basically I'll be doing the inference on top of the trained model, but if you want to do the custom training and all, at a time either you can refer the RoboFlow blog, either you can refer the GitHub repo they have shared with you. Okay, so see, there are different things actually they have proposed. Let me show you. They're also telling here YOLO V8 documentation, full documentation, valid train and deployment. If I open it up, and apart from that, they have also given like the command actually you can utilize. So everything they have given here. Okay, even they have also given the tutorial notebook. Let's say if you're interested, you can also open up the tutorial notebook and you can try to understand. Okay, see, task you can perform detect, then you can perform segment, you can perform classification. Okay, uh, see, they have also added the pose estimation as well. Okay, so this is the new one they have added. Now there is another one, OBB, that means oriented bounding boxes object detection. Okay, this task actually you can also perform. Oriented, see, this is the oriented detection, as you can see. Okay, this can be also done. So 1 2 3 4 5, so this 5 tasks actually you can perform with the help of one particular model. So this is like amazing, right? So I'll tell you how to like change this particular task and how to do different like you can say projects and all. Okay, this will be very much clear. So this is the official documentation from the Alterytics of this YOLO V8 documentation, entire documentation. You can visit and you can try to see how it can be done. Okay, see, they have already given all the command, all the Python code and everything. Okay, you can test it out. Now guys, what I'll do, I'll go back, and here you can see the YOLO V8 performance, a benchmark on RoboFlow 100. So RoboFlow 100 is nothing but it's a data set. Okay, benchmark data set. So this is the performance actually they achieved. We benchmarked on YOLO V8 on RoboFlow 100, and object detection benchmark that analyzes the performance of the model in task specific domain. RoboFlow 100 is a method of effectively assessment extent to which model can be generated to access the different problem statement. Now YOLO V8 and YOLO V versus YOLO V5, you can see we found that YOLO V5 scored 80.2% MAP score on RoboFlow V100 dataset compared to 73% 73.5% mean score of the YOLO V5. That means you can see the accuracy they have achieved here. Now this shows that YOLO V8 is a significantly better at domain specific task than Alternatics YOLO V5. This one predecessor or whatever they have like developed. We compared YOLO V5s and YOLO V8 in the analysis. Now you can see YOLO V5 performance on the benchmark on Coco dataset. Now it is having different model. Actually, it is having YOLO V8 N model, S model, M model, L model, and X model. N model means this is the nano model. S model means this is the smallest model, and M model means this is the medium model. This is the large model. This is the X large model. That's how you can see the size of the image, size of the pixel. This is the MAP score. This is the speed of the CPU and GPU. This is the parameter size of the model, and this is the flop, okay, of the model. Now you can see this code snippet and all. You can try to execute in your Jupyter notebook. Okay, that's how they have written one amazing blog. You can refer this particular blog. Okay, RoboFlow blog. Now I'll be using another blog. So this is the blog, guys. So how to train YOLO V8 object detection on a custom data set. With the help of this particular blog, I'll be training one particular model. That means on my custom data, I'll be training this particular YOLO V8 model, right? So they have already given all the steps like how to perform the data annotation and all. I think I already showed you how we can perform the data annotation with the help of RoboFlow. So there actually we need to upload the data, then we can start the annotation. Now see all the steps they have given. So I already prepared one notebook for you. So I'll try to show you how it can be done. But before that, let me show you the demo of the YOLO V8. It is having two different mode. One is like SDK mode, another is like command line mode. With the help of command line, you can also do the detection, classification, and segmentation. And another way you can do with the help of Python SDK. That means you can also write the Python code. You can also do the classification, detection, and segmentation. So both I'm going to discuss. So first of all, I'm going to open up a Colab notebook. Let me open up a Colab notebook. Then here I think I can show you everything. And these resources I will share in the same dashboard actually I've showed you. So from the description itself, you will get this particular course link. You can enroll and you can get the resources from there. Now what I'm going to do, I'm going to name this particular file as YOLO V8 CMD. That means I'll show you the command interface first of all. YOLO YOLO I think yes, it should be YOLO V8 CMD. Okay, CMD demo. Now make sure you change your runtime to GPU. T4 GPU saved. Now I will connect this particular notebook. Now let me just write down some of the things so that you can note it out. Yeah. So modes actually it is having three different modes: the train mode, validation mode, and predict mode. Let's say you want to do training, at the time you will be using training mode. You want to only validate your image, at the time you can use validation mode. And let's say if you want to only inference that particular image, or let's say you want to do the prediction, at the time you can go with prediction mode. And task you can perform, I already told you, we can perform three different tasks: detection, segmentation, and classification. They have also added key point detection and oriented object detection as well, but I haven't added here. This part you can explore from the documentation or the RoboFlow blog itself. Now data format can be different task type. That means whatever task actually you are performing, based on that your data format will be different. Okay, now most of the time whenever you are doing the detection task with the help of YOLO V8, the data format should be the same as you did for the YOLO V5. Okay, I think in YOLO V5 also you annotated the data, and I already showed you the format of the data. The same format can be applied in the YOLO V8 as well. Okay, so these are the things actually you have to note it out before starting with the YOLO V8. Now the first thing, the installation. So installation wise, they have already given the commands like how to install this particular YOLO V8. So as you can see here, so if you want to use this particular YOLO V8, you have to install this particular library called Alternatics. Okay, with the help of pip install, you can do it. So let's copy this command. I'll open up my Colab notebook, and here I'm going to install the library. Okay, then I'm going to access this particular YOLO V8. So let me just write down, this is the installation. Okay, we are doing. So it will take some time. Once it is done, then I will start with the command line demo. Okay, how we can perform the detection. First of all, I will show you. Then we can do the next thing. So installation is going on. In between, I will download one data. So this is the data, guys. So this is the image actually I'm going to download, and this image actually I'm going to give it to my model. Okay, so I'll save this particular image. So this is a dog image, I think I can save. Okay, I think installation is done. Now what I have to do, first of all, I will upload this particular image here. So let's upload this image. So I'll upload. This is the dog image I downloaded. So here is the image. I will upload it. So the first task I will show you the detection, how we can perform the detection with the help of command line. See, it's like very easy to use. If you're using YOLO V8 with the help of command line, easily you can do the detection. Let me show you how it can be done. So if you want to perform the detection, so first of all, you have to execute one command, YOLO. They have already given the command here. See, YOLO predict model and source images. Okay, and you want to perform the mode. What kinds of, let's say, task you want to perform. So let me show you the command how it can be done. So just write YOLO. Then first of all, you have to specify the task you want to perform. So here I want to perform the detection task. So that's why I'll be writing the detect. Okay, detect, because I have already noted out everything. See, task, detect, segment, and classification. So if you want to perform detection, you at the time you need to write the detection. So here I have written the detection. Now mode is equal to, I want to only do the prediction. Okay, predict, not the training and not the validation. I only want to do the prediction. Then model, which model you want to use, you need to specify the model name. Now here you have different model. Let me show you. It is having different model in the model view. YOLO V5 series, this is the, but I want the YOLO V8 model view. So let me just find around that particular things. YOLO V documentation, YOLO V5 model, YOLO V8 model view. So here let me just write YOLO V8 model. Okay, model view. Now maybe I think we can get it from here. I think somewhere they kept the model. YOLO V8 detect documentation. Let me open the documentation here. Detection model. So yeah, so this is the model view in the documentation. So see, it is having different model, N model, S model, medium model, large model, and X large model. So I'm going to use this particular model, nano model. Okay, so you just copy the name and open the notebook, and here just try to specify. And after that, you just need to write the PT. That means I want to download the PyTorch model. Okay, that's why I've given the PT.pt. Okay, so once it is done, I also need to give my source image. Okay, source is equal to, so this is the source image. I'll copy the path, and here I need to specify this is the source image. Okay, then once it is done, you also need to define one parameter called save is equal to true, because it will also create a folder. Inside that, it will save that particular detection. Save is equal to true. Now this is the command actually, true, I think. Yeah, so everything is fine. Now if I execute this particular command, okay, if I execute this particular command, you will see it will automatically perform the detection for me without writing any kinds of code. With the help of command line interface, I can easily do it because I have already installed this Alterytics package. Okay, now let me just install it. Let me just execute and show you whether it is able to detect or not. Okay, I'm getting one error, no such file and directory YOLO V7 PT. Okay, so I think I need to download the model, or I think I can give like that. Now let me try. Okay, I think I have to download the model first of all. So if I want to download, just a minute, guys, let me check. Mm, okay, so why it's not working? Because the name should be in a smaller character. Okay, that's why it's not working. So I have to give a smaller character like that. It should be in a smaller character. Okay, now I think it should work. It will automatically download the model. Okay, I don't need to download it. See, now it is downloading this particular model, and after that it will do the detection on top of it. Now, one question I'm getting, could you please provide the GitHub repo for source code for all the previous session? So I already told you, Atal, you were asking this particular question. So you have one dashboard. Okay, so this is the course dashboard. You can find this particular dashboard link in the YouTube live description section. Okay, so see, this is the dashboard, computer vision hands-on. So please enroll for this particular course. This is completely free. Okay, you just need to create one account and need to enroll for this particular course. And here you will get all the resources. See, as well as the video, even with the resources, everything I have shared. Okay, you can get it from here. Everything is in one place only. Okay, my detection is completed. Now if I refresh the page, now see, one runs folder has been created. Now if I go into the runs folder, detection, okay, and here is the prediction and here is the prediction, guys. Now let me open this particular prediction. See, guys, amazingly it has detected all the object present in this particular image, right? See, it has detected the dog. Now let me open this particular image in a new tab. Now, yeah, now I think you can see that. See, it is detected this particular dog. It is also detected the particular person, and there is a small car. You can see small car. It's not like very, I mean, visible in a good way, but still it is able to detect that particular object. Okay, it's like amazing model. You can see and see the confidence score. Like it's pretty amazing, right? So that's actually with the help of just one particular line we executed, and we are able to do the detection. Okay, now let's say if you're creating any kinds of application, you don't need to write so many codes. If you want to only execute from the command line interface, you can do it like that. Okay, so this is the detection demo. Now let's also see that segmentation one. So I'll write here how to perform the segmentation one. Segmentation. Segmentation one. Segmentation. Yeah, iNeuron segmentation. Okay. Now segmentation wise, I'll be copying the same command only. Only I just need to change the mode here, task and mode. So here, task wise, I will be doing the segmentation. So here you need to write segment. Okay, segment, and predict is mode is equal to predict, and model. Now you want to use the segmentation model. So it is also having the segmentation model. Let me show you. So go to the documentation. Now I'll go to the segmentation right now. So segmentation is having different models. See, YOLO V5N segmentation model, S segmentation model, M segmentation model, L segmentation model, and large segmentation model. Now I'm going to use this particular nano segmentation model. Okay. So again, I need to copy the name, and here I just need to provide this particular name. So this is the name you have to write in a smaller character. So here is the name. Model is equal to YOLO V8N segment.pt. This model I'm going to use, and I'm going to use the same image. Actually, I'm having here, as you can see, this dog and person image, and save is equal to true. Now, if I execute this particular command again, so you will see I'll get the direction again. See, it's done. Now, if I refresh, now this model has downloaded. Now, if I go to the runs folder, now see it has created another folder called segment. If I go inside the segment, predict, and this is my final prediction. Now, if I go open up this particular image in a new tab, see guys, amazingly, it has segmented out my object as well. Okay, see. Now car is not able to segment out by because segmentation is like very costly task. So here if you see, this is my dog, it is segmented out, it has applied the mask on top of it, as well as this is the person. Okay, the entire mask you can see here. Okay, now let's see the classification as well, how we can perform the classification with the help of this particular YOLO V8. Now again I'm going to open up my Colab. I'm going to close it. Now here I'll show you the classification task as well. Classification. And two more tasks actually you have to explore by you. So these two tasks actually you can do pose detection and oriented bounding box object detection. Okay, these two tasks actually you can explore from your end. So for this you can refer RoboFlow blog. RoboFlow blog has having different things actually. You can search here, you can also do it from your end. Now let's see the classification, how it can be done. See, for classification also I'm going to use the same command. Okay, I'm going to use the same command. I'll copy the command and here I need to paste it out. Now here instead of task segment, you just need to write the classify, because I have already written here everything at the very first. You have to do the classify. Then after classify, mode is equal to, it should be predict model. Now see, if I want to do the classification, now I'll be using the classification model. Again I will go to the documentation, go to the classification. So it is having also classification baseline. See, these are the classification baseline. Now let's select one model. So I'll be using the same nano model, CLSPT. So here I just need to write inside the model. I'll change the model name. Source is equal to, let's use one single image, because if I want to do the classification, I should have only one object in particular image. Okay, so I'm going to download one cat image. Okay, cat image from the Google. So let's say this is the cat image I'm having here. So I think I can utilize this particular image. Okay, I think this would be good. I'm going to download, and this is cat. Now let's upload this particular image here. Upload, and here is the cat image. Now I'll copy the path and I'll mention it here. Okay, now let me execute and see. Done. If I refresh right now, if I go to the runs folder, now see, classify has been created. Now inside that, prediction, and this is nothing but my cat. Okay, see, tiger, cat, we cat. Now see, it is also giving the spouse of the cat. See, different variant of the cat also. So tabby cat, it is like it is having confidence score 0.32 confidence. Tiger cat 0.20 confidence. Then Egyptian cat, Egyptian cat actually 80%, 18%. Lens cat, plastic bag. Okay, see, these are like very low confidence. That means this is not a like actual class. Actual class is like tabby. Okay, tabby. If I search for tabby cat. Okay, see, this is the tabby cat. So this is the uh, cat variant. Okay, this is the tabby cat. So it is perfectly classifying this particular things. This is tabby cat because this is the confidence score, higher confidence score here. Okay, tabby cat 32% confidence. This is a tabby cat. Okay, so that's how you can perform the image classification as well. Okay, so this is the command line interface demo. Okay, now let me show you the Python SDK demo as well. So here let me just comment out. Let's see, if you want to also perform with the help of Python SDK, you can also do it. Python SDK. So for this, actually, I'm going to show you one particular code snippet. Yeah. First of all, you have to import the YOLO from the Ultralytics. So you just need to write from Ultra. Okay, Ultralytics import. You have to import the YOLO. Okay. After that, you have to first of all load the model. Okay, so let's load the model. So model is equal to, okay, model is equal to, I'm going to load one detection model. Let's load the detection model, and same thing also can be applied for the segmentation and classification also. Okay, so I'm going to give the same like detection model name. So here is the model name. I think you remember detection This is the detection model, I think. YOLOv6 Yeah, this is the detection model name. I'll copy the name, and here I'm going to paste it out. Okay, this is the model name you have to specify here. Now once model you have loaded, now you can do the prediction. Okay, so here you can write model dot predict. Okay, and inside that you need to provide the image actually you want to do the prediction. So now what I'm going to do, I'm going to use this particular dog image. Okay, this particular image I'm going to again use. So I'll copy the name, copy the path. No, sorry, this is the dog image. Copy the path, and here I have to mention it out. Okay, so once it is done, if I execute right now, you will see the detection I'll get here. See, all the detection I'm getting. All the detection I'm getting. See, this is the image, and this is the detection actually I'm getting. Different detection actually I'm getting. And if I show you below, see, this is the inference actually I'm getting. Now if you want to visualize this particular image, you have to use like supervision, RoboFlow supervision. So there is another actually library they have developed, supervision, or you can also use OpenCV. You can also plot this particular image. So if you're doing with the help of Python SDK, you have to write this at the code manually. Okay, but if you're doing for the CMD, okay, you don't need to write this at the code. So this is the idea. Now we can explore the SDK part. So they have also given the tutorial of the SDK, how to perform with the help of Python SDK. See, this is the CLI. The CLI I showed you, and this is the SDK ones. Okay, SDK ones I already showed you. So this is the training one. You can also see the validation and all. So that's actually you can refer the documentation and you can learn, because documentation should be the best thing to learn of any kinds of technology. So okay, so you can refer this particular documentation, and apart from that, you can also refer the RoboFlow blog. Okay, they have also already written the blog and all. Now we'll be starting with the custom training on the custom data, like how we can train this particular YOLO V5, YOLO V8 on our custom data. Okay, with the help of this particular RoboFlow blog, actually we'll be referring there. How to create this particular Colab code file into an end-to-end object detection projects. Okay, so if you want to learn end-to-end object detection project we need, so you can refer our community series. So if you just go to the playlist, I have already taken one end-to-end projects on the object detection. Let me show you end-to-end object detection. Okay, see this particular playlist you can refer. So here I already created the entire pipeline. Okay, see 7 days session was there. So everything I have showed you from the project setup itself. I also showed you Jenkins CI/CD deployment, okay, on the AWS cloud. You can refer this particular series, okay. All right. Now let me close some of the tabs not required. Now we'll start with our custom example. All right. So first of all, what I will do, I will show you the dataset, how we can prepare the dataset for the YOLO V8. So again, you can go to the roboflow.com. Sorry, it should be roboflow.com. And here you can sign in with your account. I already have the account. I'll just sign in. Okay, it's loading. Let's wait. Okay, fine. Now you can go to the universe and you can choose the data you can use. So you can choose any kinds of data. So I'll go for object detection. And there are so many data set, guys. So you can refer the data. Student data is there. Hands project is there. Project segmentation. Yellow. Okay, so this is another data. I'll show you one annotation part at least. So let's say garbage. Okay, this is the garbage data actually. So you can also use the garbage annotation, but I don't want to use the garbage. So Let's say you want to detect this particular food, like let's say can, okay, drink can and all. I will use this particular data. Maybe it should be good. Yeah, so I think I can use this particular can data. So this is a lychee, okay, lychee data set. So only let's say lychee drinks. So let's say if you want to only detect the lychee drinks can, okay, you can use this particular data. So I'll only take one demo data set from here. But whenever you are doing your own task, make sure you are giving your own data. So first of all, here what I will do, I will download this particular image. So I'll go to the full project, and here I'm going to export these are the image, okay, export dataset. Okay, so these are the image I'm having. So now I think I can export, select all, and clone. I can also clone, I can also download it. Okay, so let me clone it. Clone selected image. Now I'll be cloning inside my new workspace. Yeah, Buppy, inside Buppy. And here you can create a project. Select a project. So which project I want to select. Or else what I can do, I can download the image. I think that would be better. Just a minute. I'll go back. Let's use this data. I think I can. Why download option is not coming? Just a minute. Or else I think I have some image, okay, on my system. Let me check. I think I can utilize those as the image. Yeah, so I can utilize these are the image, okay. So here what I will do, go to the training. Yeah, so this image actually I can utilize. So I'll minimize. I will go to the workspace, and here I'm going to create a new project. Okay, so here but previously I already have it. I need to remove it. Just a minute. So I'll go back. Okay, why I can't go back? Just a minute. Let me close and reopen it again. Mm, roboflow.com. Sign in. So annotation part I already showed you multiple times. So the same way you can perform the annotation. But I'm just going you some brief idea on this. So let's say I'll remove this particular project. All right, now you can create a new project. Give the name. So let's give YOLO V8 demo. Annotation group. Let's say you can write worker. Okay, workers. Now here I'll create the project. Now here you can upload the image. So let's say I'll take some worker image. Okay, so let's take this these 6 images only. Okay, just to show you the demo. Now I'll save and continue. Then after that, I will start the manual labeling. Now you can select the bounding box and you can select the worker. So this is worker. Go to the next image. This is also worker. This is also workers. All right. Now this is also workers. And this is also workers. Last image, this is also workers. Done. Now once it is done, just go back and add the data into image. Now add the images. Now create the version, continue, and again click on continue and create the data set. Now here I will export the data set. Now here you have to specify the format. Okay, now you want to use, let's say, YOLO V8. Now see guys, you want to use the YOLO V8, so select this particular one, YOLO V8. No need to select oriented bounding box, only will be selecting the YOLO V8. Okay, this one. Now download the data as a zip file. Continue. I just wanted to show you the data format, how it will look like. That's why I have done the annotation. Now see, it will start the download. Now download is done. Now I will go back to my download folder and let me show you the data. Extract all the image. And this is my image folder. Now you can remove this to readme file. It's not required. And see, this is the same folder format structure as you did in your YOLO V5 as well. Okay, this is my image and this is my labels. Okay, that means txt annotation. And that's how we have the testing and the this one data as well, data.yml. Inside data.yml you will have the location of the data. Let me show you. This is the location of the data. Now you can remove this part. It's not required. Okay, yeah, now I'm only having one particular object called workers. Okay, that's why. Now I'll close it and now I'll show you the training part. Okay, because I already have the annotation of this particular data, I'll share with you. So let me just show you that particular drive I'm having. So guys, this is my Google Drive. So inside that, actually I already have my data. So let's say this is my data. Okay, inside that I have my training images. Okay, see, these are my training images. Okay, and this is my testing images. And also I have my validation image. Okay, so everything I'm having the same market data. So now what I have to do, make sure you copy this particular data.yml file outside of this particular folder. Okay, here outside of the data folder. Now here I already have one notebook. So this is the notebook I already prepared for you. Okay, so this is the notebook I prepared for you. Now here I already showed you the same thing, like how we can use the SDK and all, how we can do the classification, okay, then detection and all. So I'm not going to do it again. So I'm going to first of all connect my notebook. Manage session. First of all, I have to terminate the previous one. Then I will be connecting this one. See, what is oriented bounding box? So you can go to that particular task, see oriented bounding box, and see the example. See, your object should be oriented, Monica. Okay, it should be oriented. See, it's not a like a straight image. It's a oriented image. That time you will be using orientation. Okay, because if you see, if you perform oriented detection with the help of a simple detection model, you will see it won't be detecting in a perfect way. But if you're using oriented model, that time it would be detecting perfectly. You can also see the tutorial of it, how it can be done. Now it's connected. Now if I check my GPU, so I think I got Tesla T4. Yeah, Tesla T4. Now here, first of all, specify the location of my content. Now I'll install the Alternative first of all. So I'm executing the same command, and here I'm specifying one version. Okay, specific version I want to install. Yeah, top view you can talk about, Monica. Okay, you can read the documentation. You will get the idea of what are the views actually you can consider in the oriented one. Now in the RoboFlow tutorial also they have mentioned the same thing, how it to perform the object detection, and see the same way I have also done the data annotation here. Okay, now I'll open it up. Okay, my installation is completed. I think okay, still it is going on. Let's wait. Yeah, it's completed now. Now I'll import all the library and I'll try to test. Okay, now see it's working. Can you tell the advantage of YOLO V8 over the YOLO V7 tiny model? I already given you the introduction, Monica. The very first I was comparing all the models here. Okay, so here I've already given the like introduction, so maybe you can missed out. So YOLO V8 is better than your YOLO V7 because they have introduced so many things in the YOLO V8. Fine. Now I already imported the library and it's working fine. Now first of all, let's test one image, okay, whether it's working or not. So I'm going to execute the same command, detection predict. I'm going to use the same model, and source is equal to the same image, dog images, but I'm not downloading from the RoboFlow. See, this is the URL of the image. So this is the complete URL of this particular image. Okay, so I'll download this particular image and I will do the detection on top of it. Okay, and save is equal to true. Now let me do it and see whether everything is fine or not. Let's say once I install everything, I just wanted to test it whether everything is working fine or not. Then I will start with my custom training. Done. Now if I refresh, see runs folder has created. Now if I go to the runs folder, detection folder, predict folder, and in the dog.jpg, see all the detection I can get here. See, that means it's detecting perfectly. That means everything is working fine. Now if you want to render this particular image, so you can execute this particular command. See, it is rendering now right now this particular image. Now you can also do it from the Python SDK. I already told you. Now let's say if you want to do the Python SDK, so this is the code you can execute. First of all, you have to initialize the model. After that, you have to do the prediction on top of the which image you want to do the prediction, and you can also specify the confidence score. Okay, like what is the confidence score you want from your model. Now this is the bounding boxes. Now this is the results, confidence score, and this is the classes. So these classes, like 0 means this is a, I think, person, 16 means this is a dog, and 20 means this is the car, 2 means this is the car. Okay, that's how you can see different classes. Now I can start with my custom training. Okay, so if I want to do the custom training, so I think you saw here I kept my data in my sent by Google Drive. Okay, see here my data set is available. Okay, now if I want to use this particular data, first of all I have to mount my Google Drive. So this is the code for it. So let's mount my Google Drive. Now connect to my Google Drive. I'll give the permission. So this is my ID, and let's continue. Now I need to delete two things in the data folder. So it will create one cache file. Okay, here because previously I already trained, that's why this cache file should be there. Let me remove it first of all. I think somewhere I saw that particular cache file in the training. Yeah, label.cache. Okay, this one I will need to remove. And the validation also. This thing I had to remove. Now I think everything is fine. Now I'll open up. Now see, I like mount my Google Drive. Now if I can access my Google Drive content. See, whatever things I'm having inside my Google Drive, I can access. Now this is the location of my folder. This is the location of my folder. So let me redirect to this particular location. It is having inside my courses and YOLO V8. Okay. Now I just copy this particular location and I have just pasted here. That means I want to change this particular directory to this particular directory. Okay. That's why I've given the location here. Now let me change that directory. You can also train with large amount of image. Okay. Now for this you have to take with Colab Pro Access. There you will get more RAM, more space and all. But here I'm using free Colab. That's why I'm using less images. And I want to cover in the live session because I don't have that much of time to show you the large amount of data training, right? That's why I've kept sample of images here. Now I redirect to my folder. Now what I have to do, first of all, I will be yeah, so now I'll be training. Okay, I'll be training my model. And see, to train the model, one line you just need to execute. Okay, see, YOLO command, task is equal to detect, mode is equal to train. Now I want to do the training. Okay, training, not a validation, not a prediction. I want to do the training. Model is equal to, I want to use this particular model, S model. I already showed you the model view. Data location, data, this data.yaml location, this particular data.yaml location, it will automatically load this particular data. Then number of epoch, I want only 1025 epoch. Image size, image resolution you can give, and plot is equal to true. Okay, plot is equal to 2. And another thing I can give this particular statement, save is equal to true. Because it will create the artifact and it will save everything. Save is equal to true. Now let me execute and see whether it is starting the training or not. So it will take some time, guys. Let's wait just a minute. How do we decide the number of epochs needed to train the model? It's just an assumption number. At least you should start with 1000 epoch. Okay, it's recommended. But here I'm taking 25 epoch because I want to show you the quick training. That's why. Okay. And let's say if your accuracy is not improving, loss is not decreasing, although we have said let's say 1000 epoch, it will automatically stop the execution. So you don't need to worry. You can also start from 10,000 epoch also. So once it will see that your model losses is not decreasing, accuracy is not increasing, it will automatically stop the execution and it will see the model. So it's not a big deal. So you can set any number here. See, now my epoch has started. That means my training has started right now. Now if I go here and you can refresh. Now see, runs folder has created. Now inside runs folder, you will have all the models and everything. Now let's wait for 25 epoch, and after that I will show you the prediction as well. Now you can try with your own data. So you just need to place the data in the Google Drive the way I showed you. Now we can do the training on top of that. Epoch number 9 is going on right now. So in between, if you have any query, guys, you can ask me. Any query do you have? And how is this particular series, guys? Is it helping you really in the field of computer vision and all? Like whenever I'm talking about hands-on, practical and all, is it helping you guys? Because all the, like say, tasks we are exploring one by one. Is it possible to use GitHub as well with the Google Colab? What is the size limit the GitHub offers the Google Drive is? You can use Google Drive. Okay, GitHub it's not recommended. But if you want to share the data and all, you can use the time you can use Google Drive. Now see, my training is completed. Now it has also created the runs folder. Now inside runs folder, if I list down, now see these are the files and folder it is created. Now if you also want to see the confusion metrics, you can also plot it. This is the confusion metrics. You can also see the losses and accuracy. This is the losses and accuracy. And you see my model is learning better from this particular graph. Actually, you can see. Now you can also see some batch images. So these are some batch images. Actually, you can see. Now I can do the validation. Let's say I want to see the accuracy of my model. Okay, whether it is performing well or not. So for this, you can write execute this particular valid command. Okay. Now YOLO task is equal to detect, mode is equal to valid. Now I want to perform the validation. Okay, with the help of the model I trained, this base.pt model. Okay, on top of my testing data. Now let's start the validation. Why do we need to train the model? Since we are already importing the pre-trained model. See, inside the pre-trained model, you won't be having these kinds of object. Okay, the object actually we're trying to train. Let's say the sign language, or let's say this helmet, then footwear, gloves. Okay, so these are the object is not present. That's why we're training on top of that pre-trained model without custom data anil. So this is called transfer learning. Now see, this is my final average precision I'm getting, mean average precision. That means this model is performing well. Now I can inference with my custom model. Now see, the same command I'm executing, YOLO task is equal to detect, mode is equal to predict. Okay. And model is equal to, now I want to use my model. See, instead of giving their model, now I'm giving my model location, the base.pt model. And this model is available inside runs folder. So if I show you the runs folder, detect, now inside that I am having my model. Okay, inside train, inside weights. So this is my model. This is my model base.pt. So this model you can download and you can use it. Okay, so this is my train model. I'll go back. Now this particular model I'll be using confidence score. I want to set, let's say 25%. If you 25% confidence, that time you can give me the detection. And source image, I'm giving my source image. Okay, so inside test data, I'm having my source image. Let me show you inside test, inside data, inside test image. Okay, I'm having my some testing images. Okay, see some testing images I'm having. So these are the images actually I'm giving. Okay, one by one. Now let's run this particular statement. Now it will take all the images one by one and you will do the detection and it will save inside the runs folder. See, detection is happening. I already did it. Okay, results, you can check it out. I already showed you how we can predict on top of the pre-trained model. Okay, without fine tuning. Now see, it's done. Now if I plot it, all the detection, you can see the detection. See, it's detecting perfectly. So this is helmet, goggles. Goggles are, see, I only trained 25 epochs. That's why some mistake actually you can see. But if you trained around, let's say, around 300 epoch, or let's say 400 epoch, you will see it will learning better. Okay, now still see it is able to give me the detection. Fine. So that's how actually we can perform the custom training on top of our custom data. Okay, with the help of YOLO V8. And it's like very easy to use YOLO V8. Either you can use with the help of command line interface, either you can use Python SDK. And there are so many support and all. There are so many blog and all. There are beautiful documentation you can refer. Let's see if you are creating any kinds of projects. Okay, on top of it. Now, what you can do, you can explore the pose estimation, this particular task, how we can perform with the help of YOLO V8. Okay, see these are the pose model are available. And you can also try this particular oriented bounding boxes object detection. Okay, this particular task actually you can perform. So this should be the task for you guys. You can explore, and if you're able to explore this particular task, if you want to do it, okay, so definitely you will get the entire idea. All right, Fine. So yes, guys, this is all from my end. I hope you got it, like how we can do it and all. And if you like this particular session, so please share this particular series with your friends and family so that they can also get to know these kinds of tasks actually. They can also perform. Yeah. So with that, guys, I will end the session, and next class I will show you the YOLO V9 object detection task. All right. Okay. So do you have an object detection course using TensorFlow and available can be executed on the time? TensorFlow you can use for object detection also, but it would be very like installation would be very hectic task. Yeah. Yeah, guys. So thank you so much for joining the session. So let's conclude the session right now and connect in the next class. Thank you, everyone. Bye. Take care. So let's start with the session. So in our previous session, actually, we have completed till YOLO V8. So we saw that how we can perform like custom training on top of the YOLO V8 model, and we used our custom data there. Even I already showed you how we can use this particular YOLO V8 with the help of this particular command line interface as well as the Python SDK. So both I already explored. Now in this particular session, actually, what I'm going to do, I'm going to use something called detectron 2 for the object detection task. So if you don't know what is detectron 2, I'll tell you, I'll give you some brief idea of the detectron 2. Then we'll be performing custom object detection on top of the custom data. Okay. And this is one of the great framework you will find in the field of object detection, image segmentation, as well as the key point detection. So multiple tasks actually you can perform with the help of this one particular framework. I'll tell you the official GitHub repo. And this detectron 2 actually is the research from Facebook AI. So they have developed this particular framework, and it supports actually your detection backbone, segmentation backbone, as well as the key point detection backbone. Okay, so these multiple backbone actually it supports, and it has one amazing model zoo. You can select any kinds of model and you can fine tune on top of that. Even you can also directly use that particular model if you want to only do the inference on your data, right? So I'll tell you each and everything, no need to worry. But before that, let me show you the like dashboard where you will get your previous resources and all. Okay, for this, first of all, I'm going to share my screen. Just a minute. Yeah, so I think my screen is visible. Now, if I go back and just go to the iNeuron website, and here just go to the community program. So inside community program, you will see my courses. So here is it. So computer vision hands-on. Now I'll click on export. So make sure you have logged in with your account. So if you don't have account, you can create your account. Otherwise, you won't be able to enroll this particular courses. And this is completely free. So make sure you enroll for this course. Then you will be able to see that particular course in your dashboard. So let me just log in with my account. This is my email. I'll log in with this particular account. And here is the course. And I think day 7, sorry, till day 6, everything is up to date, because day 6 we have completed this particular YOLO V8, okay, with our custom data. So if I click here, now if I go to the resources as well, see, resources is also available. Now we can get all the resources, all the video materials in one particular place, okay, which is nothing but your dashboard. So make sure you just log in with your dashboard and you can get everything from here. Now what I will show you guys, first of all, let me show you the detectron 2. Like what is exactly this detectron 2? So for this, I'm going to use this particular RoboFlow blog, because RoboFlow blog has already written one amazing blog on top of this detectron 2. Even they have already given the tutorial like how we can perform like object detection task on top of the custom data. Okay, see, this is the amazing blog they have written. All the like code, all the let's say sequence, they have given everything here, like how to annotate the data, how to prepare the data, how to install this particular detectron 2. Okay, how to, let's say, load the data, how to get the model, everything, all the steps they have given. Okay, so I already prepared one notebook on top of it. So I'll try to show this particular notebook, and I'll show you the custom training on top of the custom data. But I'm going to use some different data set. Here they're using blood cell data set. As you can see, this is the blood cell data set, but I'm going to use the card data set. Okay, card data set I'm going to use. I'll tell you how this data set will look like and how to perform the annotation and all. I'll tell you each and everything, no need to worry. So this is the blog actually you can refer. And now, first of all, let me show you this particular detectron 2. So detectron 2 is nothing but as you can see here, they have written Detecton 2 is a computer vision model zoo of its own, written in PyTorch by Pair. That means Facebook AI Research. Okay, Facebook AI Research Group. Detecton 2 includes all the models that were available in the original Detectron. So what happens actually? Previously, there was another version called Detectron. Okay, but this was like deprecated nowadays. People don't use Detectron, so they're using Detectron 2. Okay, instead of Detectron, this particular version. So that's why they have given all the models are available inside the Detectron 2, such as First RCNN, Mask RCNN, RetinaNet, okay, Dense Pose, as well as some newer model includes Cascade RCNN, okay, then Panoptic FPN and Tensor Mask. Okay, so these are the new model also they have introduced in this particular framework. Okay, now you can use Detectron 2 to the key point detection, object detection, semantic segmentation, Detecton to register the dataset in a COCO JSON format. Okay, I'll tell you the data registration part, how to perform the data registration in a Detecton 2. So this is a brief overview of the Detecton 2. So Detecton 2 is nothing but it's a framework. Okay, inside that you have one amazing model zoo, and inside the model zoo actually you have already all the tasks available. Let's say if you want to perform object detection, semantic segmentation, key point detection, anything you can perform with the help of one particular library. Okay, is this course free or paid? So this is completely free course. As you can see, I already showed you the dashboard. So here, if I go back, you can see here, this is completely free. Akash, you can enroll this particular course without like costing any money. Okay, now there's some key topic they have written. As you can see, machine learning framework. The original Detectron was written in Cafe 2, whereas the Detectron 2 has made switch to PyTorch, because if you see that Detectron, the previous Detectron, it was written in Cafe 2. But Cafe 2 is another, actually you can say, framework. They were written in that particular Cafe 2. Now Detectron 2, they have made the switch to PyTorch. They are using PyTorch here, right? This allows developer to take for more intuitive approach to test that change the model, because inside PyTorch, I think you know that you have lots of customization option. So that's why actually PyTorch is like more preferable in the research field. Let's say if you want to do some modification and all, you can do it because it's a lower level framework, and here you have all the configuration and all, so that you can modify with respect to your requirement. So that's why they are switched to PyTorch library instead of using Cafe 2. Now modular design, Detecton 2 modular design allows the maximum customizability possible. Developer can write custom implementations for any part of the object detection model, allowing the greater flexibility within the projects. Okay, why they're telling the modular design? So let me show you the official Detecton 2 website, GitHub. So Detecton 2 GitHub. So this is the official, yeah. So this is from Facebook Research, and this is the official GitHub repo. And as you can see, this is a modular, okay, modular fashion. They have written everything. So if you just go to any kinds of folder, let's say Detecton 2, inside that you will see all the components and all. That's how they're written in a modular fashion, everything, right? And they have already given one beautiful readme file. Let's say what kinds of tasks you can perform and all. Then how to set up this particular, you can say, Detecton 2 and all. Then here, if you see the model view, let me open the model view. And this is the model view actually. So here you have first RCNN backbone, object detection backbone, RetinaNet was already there. Then RPN first RCNN is also there. Instance segmentation backbone is also there. Okay. Then you also have key point detection backbone is also there. Panoptic segmentation also is there, right? So you have different tasks with different model, and these are the model guys available. Let's say I want to use this particular model, so I can or download this particular model directly. Even I can directly copy the link of the model configuration and I can download this particular model. Both can be done. Okay, I'll tell you how we can access these are the model. Okay, see, this is the model save in a PKL format. So with the help of this particular configuration, I can easily get the model, right? I'll tell you how to do it whenever I'll do the custom training and all. That time I'll show you. So this is the model view. I can see you can go through this particular model view and you can try to understand what kinds of tasks actually you can perform with the help of this particular Detecton tool library, right? Okay. So this is the official GitHub. I already showed you. So they have already written here. Now new model, they have already introduced new model inside this particular framework. I already told you. Now bringing the model to the production, Detecton 2 now contains an extra layer called Detecton Go. This makes easier to bring state of the art model in a production through features including the conversion of the cloud mobile devices, network quantization, and standard workflows. Okay, let's say you want to deploy your let's say model in a edge devices, or let's say smartphone. That time you can use this particular detector to go. So this is nothing but one library. It will help you to make your model quantization. It will help you to make your model smaller so that you can bring that particular model to the production. So whenever let's say you need faster inference in the production, at that time you can go with this particular detector to go. So they have already written about detector to go as well. I think somewhere it is there, detector to go. If it is not there, so you can search about detector to go, detector to go. Here is the detector to go. So you can export these particular things. I think not this one. I already explored this particular detector to go long back. D2Go, yeah. So D2Go. So this is the GitHub actually. You can refer. Okay, how we can perform the quantization and all, everything they have given as a sequence. Akash, you were telling I have a question, sir. Yeah, please continue, Akash. What's your question? All right, now let's switch to the custom training, you can say blog, and here let's try to see how we can do the custom training on top of the custom data, right? So first of all, what I'm going to do, I'm going to show you one notebook I have prepared. But before that, let me show you one Google Drive. So inside the Google Drive, I kept all the data, all the materials actually you need for this particular project. Everything I have kept here. So I'll share this particular link with you in the resources section. So from there, actually, you can download everything. And here I kept two notebooks. One is like custom training, one is like detector to setup. So you don't need to worry about this detector to setup because I already covered detector to setup inside the custom training notebook. So let's open this particular custom training notebook, everyone. Okay, so this is the custom training notebook. So here the first thing what we have to do, we have to install the detector 2. Okay, how to install the detector 2? So here is the guideline I have already given. So if you have this particular notebook, you don't need to worry about the installation and all. Only you just need to change your data. That's it. Let's say if you are working with any kinds of data later on, you can use this particular notebook as it is. Only you just need to change your data. This is the requirement. Now here, if you see, first of all, I am installing PyYAML library. Okay, why I'm installing PyYAML library? Because here all the models do, as you can see. So this is nothing but a YAML file configuration. As you can see, this is a YAML file configuration. Now let's say if you want to load this particular YAML file, you need this particular PyYAML package to load that particular YAML file. Then it will load that particular YAML file and it will load the model configuration. Then it will try to download that particular model. For this, I'm going to install this particular PyYAML library here, right? Then after that, I'm just checking my torch version and all. Then at the end, I'm installing my detector 2. And how to set up the detector 2? This is the command to set up the detector 2. Okay, what you have to do, go to the official GitHub, click on the code, copy the link address. Okay, and here you just need to paste it. Here you just need to paste it. Okay, that's how we can install this particular detector 2. Instead of cloning that particular repo and installing that requirement.txt, we can also install in that way. This is also possible. But if you check that detector 2 documentation, they are telling you have to install this particular detector 2 like that only. All right, now let me install because it will take time. Then after that, I think you have to restart your runtime. Then you will be able to use this particular library. And make sure you connected with GPU. Okay, so let me show you. See, I already connected with my GPU. So if you don't have GPU, just connect with your GPU first of all. Because here I'm using free Colab. I'm using T4 GPU. So make sure you are connecting with your GPU as well. So see guys, installation is going on. So it will take some time. After that, we'll be importing all the library and we'll be testing whether it's working or not. In between, let me show you the data. Or let's try to wait the installation. Then I'll try to show you the data set. So in between, if you have any question, guys, you can ask me. I'll try to reply all of your question. So let me write down what are the things we have covered so far. Just a minute. Okay, I got one question here. So Akash is telling, I want to become a successful data science. I want to career transition to data science, but I am unable to get a job in data science. What to do, I said. Okay. Akash, first of all, make sure you have the proper skill set. Okay. So whenever, let's say, you want to switch your career to the data science, so you should have knowledge on, let's say, all the technology like machine learning, deep learning, computer vision, okay, natural language processing. So if you have proper skill set in this particular technology and all, and with that, you should have some good projects with you. Okay. So you should have problem solving skills. Let's say if I'm giving you some problem statement, let's say I'm giving one object detection problem statement. Okay, I'm telling you, just try to detect the mobile phone. So that time actually you should have that much of knowledge, like how we can perform the object detection on top of the custom data and all, right? So if you have this kinds of like problem solving skill, if you have this kinds of let's say all the required skill set and all, definitely you will get a job. Okay, make sure you build one good online profile with your resume and all, and try to mention the projects actually you have developed, and it should be a good projects, not a dummy projects that actually you have taken from any platform. Okay, because I have seen like people will be taking dummy projects and they will mention in the resume, so this won't be working. So make sure you do some good projects. Okay, and if you are worrying about the projects, so no need to worry, just visit our YouTube channel. So in the playlist section, you will see we have already covered lots of end-to-end projects. See, DL end-to-end projects we have already covered. Then object detection end-to-end projects we have already covered. NLP end-to-end projects we have already covered. Okay, then data science interview preparation series is also already there. Let's say whenever you are attending the interview, what kinds of question they may ask, you can also get the reference from here only. You can prepare the interview from here only, right? Then you can see we have already covered the end-to-end machine learning projects is also already there, right? We have also covered the generative AI here also. Then we have also already covered the deep learning already there. Then MLOps course is already there. So you try to complete these at the playlist as well. Right, try to complete these at the playlist as well. And after that, you will see you will have more skill set. Okay, you will have more skill set. You will have more good projects in the resume. Then that time actually you just apply for the jobs. Okay, definitely you will get a jobs. I'm learning, still learning. Okay, so if you're still learning, then you have to take time, right? Because you are still in learning phase, so just take some time and try to prepare for it, right? Yeah, so no need to worry as of now, because try to first of all complete your learning phase. Then once your learning phase is complete, try to build the projects, try to solve different problem statement, then try to apply for the jobs. Okay, that's how things work. Okay, all right, so as of now we have covered image classification inside computer vision. That's why I'm just writing here image classification. Then we have covered object detection. Okay, object detection with the help of YOLO series we have seen. Today we are covering object detection with Detectron Pro. Okay, now from tomorrow we'll be starting with the object segmentation part. Object segmentation part. Segmentation. So here we'll be exploring Detectron 2, because with the help of Detectron 2 we can perform segmentation as well. Even I'll be also exploring this one, YOLO. Okay, with the help of YOLO V8 we can also perform the object segmentation. Both I will show you, okay, how we can perform the object segmentation. And I already given you the difference between detection, classification and segmentation. Okay, because I'm expecting you are pretty much familiar with the classification task right now. You can perform any kinds of classification task with the help of PyTorch and TensorFlow both. Okay, TensorFlow both. because I already showed you these two framework. Okay, then object detection wise, if I'm telling you just try to use YOLO series, you can use it because I already covered till YOLO V8. Then object detection with the help of detectron 2. Today I'm covering this particular task, and you will be able to complete this particular things as well. Then from tomorrow we'll be starting with the segmentation task. We'll be seeing some couple of segmentation tasks. Then after that we'll start with something called object tracking. Okay, object tracking. Object tracking. We'll be exploring something called deep sort. Okay, deep sort is an object tracking algorithm, and inside that we'll be using YOLO V5. Okay, for the detection task. So one by one we'll be exploring everything inside the computer vision, let's say hands-on, whatever actually we are having. Can you compare detector 2 versus YOLO model for the object detection? Yeah, so you can see the comparison. So YOLO is an algorithm. Okay, YOLO is an algorithm. This is a SSD based algorithm, single shot detector, Monica. Okay, but whenever I'm talking about detectron 2, so it's not a algorithm, it's a framework. It's a framework. Okay, with the help of this particular framework, what you can do, you can perform 3 kinds of tasks. The first task, you can perform something called detection. Second task, you can perform something called segmentation. Okay, segmentation. And third task, you can perform something called key point detection. Key point detection. Okay. And for individual task, actually, you have individual model. Let's say if you want to perform detection, at that time you can use faster RCNN backbone. If I go to the model view, so see, if I go to the model view, see, if you want to perform detection, at that time you have to use faster RCNN backbone. And these are the models are available. This is the faster RCNN backbone. But the model you used in the YOLO, that was SSD based model. That is the YOLO model. That architecture is different. This architecture is different. Got it? Now you also can perform object detection with the help of RetinaNet. This is another backbone. Okay. Then you can also perform something called fast RCNN. This is another object detection algorithm, right? Then let's say you want to perform instance segmentation. That time you have to use, these are the algorithm. Okay. You have to use mask RCNN that time, mask RCNN. All right. So these are the basics of computer vision. At least you should have had some idea, like what is mask RCNN, what is faster RCNN, what is RCNN, what is SSD, what is YOLO, right? If you have this kinds of understanding, so definitely you will be able to compare all the model, right? Yeah. So let's see the execution. See, execution is completed. That means we are able to successfully install the detectron 2 in our Google Colab. The same way you can also install in your local machine as well. Okay, if you have the GPU there. Now what I have to do, I have to import all the library and check whether everything is working fine or not. Okay, if something is not working, I have to install that particular things. Okay, now let me import all the things. See, I already imported all the things. That means everything is working. Now here I imported some of the necessary library, because going forward, whenever I'll be doing the custom training and all, right, at the time I need these are the utility library. I'll discuss each and everything whenever I will be using it. As of now, try to consider I have just imported some of the library. Okay, that is actually I need later on. Okay, so now what I have to do, I have to mount my Google Drive. Why I have to mount my Google Drive? Because you already know my dataset is available inside my Google Drive. And this is the location. Okay, this is the location of my data.zip. So first of all, I have to redirect to this particular location. I have to unzip this particular file. Then I can access my data, right? Now let me show you the data first of all, how this data will look like. See, this is the data actually I'm using. So this is nothing but a card data set. This is a card data set, okay? This is a playing card data set. Let me open this particular data and let me show you. See, so this is nothing but 9 and this is nothing but jack. So this kinds of actually label we are having. Basically, we are trying to recognize the card. Okay, what kinds of card it is? Let's say this is 10, this is king, right? That's how we'll be annotating this particular data. So we have different data set, as you can see. On our table, we have lots of playing card. So first of all, we have to annotate these are the image. Okay, annotate these are the image. How we can perform the annotation? I think you remember we can use RoboFlow for this. So let's use RoboFlow and do some annotation and see how we can perform the annotation. So I'll go to the RoboFlow website and I'll sign up with my account. And here I'm going to create a new project. You can give the name. So here I can give this is a card project. Let's say card project. Annotation group, you can give, let's say, king, queen, and all. I'll just only give king, because here we are having lots of you can say labels, right? But I just start with the king. Later on, if I need anything, I will add it. Now this is object detection. I'll select the object detection and create a project. Now after that, I have to upload the image. So let's upload the image one by one. So let's say I'll upload only 10 image. Okay, 10 image. Let's upload 9, 10. Yeah. So this 10 image I'm going to upload. Just a minute. Okay. Now save and continue. Now we'll start the labeling. Okay, manual labeling. So click on start manual labeling. Assign the image to you. After that, I will start the annotation. Now, if you don't know the name of the card, so what you can do, you can search on Google all name for playing card. So you'll get the list of the like playing card. So here I can open any website. I think there is a beautiful image is there. Just a minute. Playing card names, games, story. Playing card names. Play. Here I can write playing card name list. So I can take any image here. I think that would be better. I saw one beautiful website. They already given all the list of the playing card nickname. Just a minute. Yeah, so this table I can use, okay, to annotate my data. So first of all, let's open up my RoboFlow, and here you can see this is a J. Okay, now let's find a J here. So whenever you have the J, see this is J. Okay, initial this is J. That means this is a jack. Okay, the name should be the jack. So let's annotate with respect to the jack only. So here I will select the bounding box tool, and I will annotate this particular card. So make sure you are annotating in a good way. So this is nothing but this is jack. Okay, instead of king, here you have to write this is jack. And save. Now you can see 9. Okay, so 9. Let me see the 9. 9 should be as 9. Okay, so I'll write as a 9. So again, I'll take a bounding box, and here I will annotate this particular data. So this is nothing but 9. Enter. Okay, once it is done, I'll go to the next card. Now A. Okay, what is A? A is nothing but it's a, I think, yeah, A is nothing but it's a as. Okay, let's complete the annotation. So this is as act. I think act. We can call it as act. This is act. A C E act. Save. And what is K? K means it's a king. Okay, so let's annotate as a king. This is king. Done. Now go to the next image. And now here if you see again I have act. ACE act. Then I'm having 10. Okay, you can see 10 means it should be written in 10. Some of the card will contain a T, that means it's a 10. You can also write as a 10. Okay, so here I can write as a 10. It's a 10. All right. Now I'll again annotate. It's 9. And this is nothing but queen. Q means queen, as you can see. Q means queen. Okay, I can annotate as a queen. So I'm annotating randomly, but whenever you are annotating, make sure you are annotating in a good way. Make sure you are annotating the proper card. Otherwise, you will get a bad results. Okay, so it's a queen. Now let me check the next one. Again, I'm having 9. Then jack. Then ack and jack. Then 10. Then queen. All right. Then next image, I have queen and ack. Then 10 and ack. Then last image, I'm having 10 and jack. Okay, see all the images completed. Can't we label the image with numerical values? Yes, you can also do it, but whenever, let's say, you are detecting something, instead of showing the, let's say, integer level, you can show the proper English level. Okay, that should be appropriate, Monica. Okay, yeah. So now I will go back. Now add the images. Do the 10 test split operation. Now create a new version of the data. If you want to perform processing, you can do. Otherwise, you can click on continue. You can perform augmentation as well. I'll continue and create the data. All right, now I'll export the data. Now here you have to select the format. Which format you have to save this particular data. Now tell me here what we are using. We are using Detectron 2, and Detectron 2 supports actually COCO format. Okay, as you can see at the initial like introduction I showed you. Yeah, so Detectron 2 registered the dataset in a COCO JSON format. COCO JSON format. Okay, so I have to save the data in a COCO JSON format as well. So here I will click on the format. Now here if you'll see, I have different format. Okay, different format. So from this particular format, I'll be using something called COCO format. So this is the COCO format. Okay, COCO format, JSON COCO format, COCO JSON format, not a MML detection and COCO ML. You have to save it in a COCO JSON format. This one, the first one. I'll save it. Then I'll download as a zip file. Now it's downloaded. Now let me show you the data. I'll extract this particular folder. I'll go inside it, and here is the data. You can remove it. It's not required. Inside train, this is the data. Okay, now you can see here you are having different COCO. Okay, .coco format. Okay, different COCO format. Okay, so that's how actually you can also start the training. Okay, and what you have to do, you have to create another JSON file here. Let me show you my data set. If I go to object detection, this is my data. Now inside training, I'm also having that particular file. Let me show you. So this file actually I just moved here. This is the JSON file. Okay, I just moved here, and inside that I'm having all the information. If I open it with the notepad, so inside that I'm having all the image information. Okay, like what is my detection and all, what is the name of the image. So this is a JSON format, and this is nothing but the COCO format. Okay, so you can use both format if you want. Now what I will do, I'll upload this dataset in a Google Drive. So I already uploaded. Now I have to mount my Google Drive. So as you can see, this is the mounting code. Let's mount my Google Drive right now. because installation is completed and we are able to import all the libraries. Now I'll connect my Google Drive and I will take the data from here. I'll select my account. I'll continue. Continue. So mounting has been done. Now if we see, this is my drive. My drive. Inside that I'm having classes. And here I'm having something called detection to detection. Okay. So this is my folder location. I'll copy the path and here I'm going to give it. Okay, I already given. Now let me change the directory. Now inside that I'm having all the folders and files. Now see, this data.zip file is there. That means I'm inside this particular location and I can access this particular data.zip file. Now I have to unzip this particular file. For this is the command. Let's unzip it. And make sure you are doing this thing in your Google Drive. Okay, not my Google Drive. Otherwise it won't be working. Okay, this path actually you have to mention your path, not my path. Now see, unzip is completed. Now if I refresh here, you will see that particular unzip folder. Inside that I'm having the images. Okay, let me show you. So this is the JSON file inside training. I'm having my I only took the training images. Okay, instead of taking valid and test image, you can also upload the valid and test image. It's completely fine. See, these are my images actually here I'm having. Okay, now what I have to do? First of all, I have to go inside the detection2 folder. That means this particular folder. Inside that, I'm going to save everything. Okay, inside that, I'm going to save everything. That's why I'm going inside this particular folder. Now here, first of all, I have to register my data. So how to perform the registration of the data? So for this, you have to import this particular library called register Coco instance. See what is happening in detection2. Whenever you load your data, it will load as a metadata object. Okay, it will load as a metadata object because see, if you load your entire data in the memory, your memory space will occupy. See, if I show you my memory right now, so nothing is loaded in the memory. Okay, you can see nothing is loaded in the memory. So now if you load your data in the memory, so it will occupy all the space. Okay, but whenever you start the training, that time you will see, you will face something called memory error issue. So to prevent this kinds of problem, they have introduced something called registration in the data inside a detection2. That means instead of loading your data in the memory directly, what you have to do, you have to load as a metadata object. Okay, that's how you have to register your data. So during registration, you have to give a name of the data. Like what is the name actually you want to call later on. So as you can see, I have given any name, custom train 1. You can give any name here. You can give my name, your name. Okay, anything you can give here. I have given custom train 1. And inside that, I've just mentioned the, that means Coco format. That means the JSON format, which I'm having inside here. Output.json. Okay, as you can see, this particular location I have given here. So inside this particular info like file, I'm having all the image location, right? It will already load all the images from this particular file itself. Then here I also need to provide the training folder location. See, this is my training folder location. Okay, inside that I'm having all the training images. All right, that's how you have to provide the path. Then you have to register the data with the help of this particular register Coco instance, okay, object from the detection2. Now let me register my data. Now I'll save everything as a metadata object. Okay, metadata catalog. Okay, done. Now let's say if I want to show any kinds of data, if I want to show any kinds of image, now what I have to do, I have to call this particular dataset dict object. Okay, dataset dict object, and here I can iterate through that particular object, and I can only take the file name, that means the image location, and I can visualize it. Okay, with the help of this particular visualizer I imported. As you can see from detection2, I already imported this particular visualizer. As you can see, with the help of this particular visualizer, you can visualize the image. And I'm taking some random image, like 4 random images I'm picking up, and I'm just showing you on top of my Jupyter notebook. Okay, now let me show you. See, this is my actual image with the help of actual annotation. Okay, see, this is the actual annotation and this is the actual image. See, okay, so 4 images actually I'm rendering here. Now what I have to do, I have to start the training. Okay, see, using detection2, it's like very easy. First of all, set up the detection2. register your data. After that, start the training. Here only you just need to change the number of iteration. Let's say this is the number of iteration. How many iteration you want to train? So let's train only 100 iteration and see whether we are getting any output or not. Previously I'll see, yeah, previously I also trained 100 iteration, but see 100 iteration is not appropriate iteration, because here you are having images and only 100 iteration actually won't work, because your model won't be able to learn. At least you have to start with 300 epoch, 300 iteration. Okay, already they have commented here, but if you have like lots of data at that time, you can start with 1000 epoch. So this is the recommended, but just to show you in this particular session, I'm going to start with 100 iteration. And here you just need to give the training data location. Okay, now see, what is the registration name I was given in my training data? It was custom train 1. As you can see, whenever I registered my data, it was custom train 1. That name actually I'm giving it here. That means it will automatically load that particular data from my metadata object. Okay, and here you have to specify the model, which model you want to use. Okay, which model you want to use. So here I'm doing something called detection task, COCO detection task. Okay, if I go to the model view, I'm performing something called COCO detection task. So I'm going to use this particular COCO detection baseline model. Okay, this particular model I'm going to use. Now here you have different model. Now which model you want to use here? So I'm using this R50 FPN. This model I'm using. Now if I open this particular model, okay, so this is the name of the model. This is the name of the model. Just copy here and try to paste it here. Copy and try to paste it here. See, faster RCNN R50 FPN 3x YAML. If I show you here, faster RCNN R50 FPN 3x YAML. This is the model configuration and this is the weight of the model. So it will automatically download this particular weight. Okay, if I execute this particular code. Now this thing you have to change. Another thing you have to change, the same thing you have mentioned here, copy and paste it here. Line number 8, checkpoint URL. Okay, and everything keep it as default. You don't need to change anything because these are the default parameter. Learning rate, batch size, you can just keep it as default only. Batch size you can increase and decrease based on your machine configuration. Let's say if you are having good configuration PC, that time you can increase the batch size. Otherwise you can decrease the batch size. Okay, now I only change the iteration and the model configuration. Okay, now what I will do, I'll start the training. And let me show you the training process. See guys, first of all, it will load the model architecture. This is the entire architecture of my model. Now it is downloading the model as you can see. Now see, after downloading, it will start the training. Now see, training has started. Estimated time it is showing as you can see. So this epoch took 29 seconds. This epoch took actually 21 seconds. And it is showing all the iteration. That means after 20 iteration, it is printing all the losses and accuracy, as you can see. So this is the entire losses. And you can also see the average precision. I'll tell you, once it is done, I will tell you how to check the metrics and all. Okay, everything I'll tell you. Now see, iteration is going on. Let's wait. Okay, so 100 epoch is completed. Now, if you want to see that the loss and iteration, I can do the evaluation later on. Yeah, so this is the evaluation code. I'll tell you. So first of all, let's save the model. If you want to save the model, this is the code snippet you have to execute. So it will save your model with the help of this model final.pth format, because pth is the PyTorch format. As I already told you, Detecton 2 has been written with the help of PyTorch. Okay, PyTorch framework. That's why whenever you are saving any kinds of model, your model should be also in a PyTorch format. Okay, that means PTS format. Okay, and this is the confidence threshold actually you are setting. Let's say you are telling your model. Okay, so let's say whenever it is predicting something, let's say here I have given one card image. Let's say this is one card image I have given. Let's say this is queen. Okay, let's say this is queen. So if I give this particular data to my model, so my model will give me some prediction, right? Y hat, that means the prediction. Now whenever it will predict, okay, it will have some confidence code. Okay, let's say my model is confident. Okay, more than 50%. More than 50% my model is confident. That time it will show me, okay, it's a queen. It's a queen. Okay, it will show me it's a queen as the output. But if it is less than, okay, if it is less than 50%, let's say it is 45%, that time actually it won't be giving any kinds of prediction. Okay, that's how we can set the confidence code here. So here I'm giving 0.5. That means I want my model to be 50% confidence whether this is a correct label or not. If not, then try to ignore that particular label. Okay, let me save my model right now. Now if I want to show you the model, so just refresh here. So it will save inside this particular location only. Okay, inside output, you will see the model. See model final PTH. Okay, and these are some metrics and checkpoints you can see. Now if you want to see the metrics and all, you can execute this particular code. But before that, let me show you the detection. Okay, on top of my custom data, that is on top of my testing data. Now here I'm taking up some test data from my dataset dict. At least 4 images I'm taking, and I'm doing the prediction. Okay, as you can see, predictor. That means here I'm loading my model. Here I'm loading my model, and here I'm giving my image one by one, and I'm getting the prediction. I'm visualizing it on top of my Jupyter notebook. Let me show you. But the detection is not good because I only 100 epoch. That's why you won't be getting any good detection here. See, although it is detecting perfectly, it's queen, again queen and queen. Okay, so it's not a queen exactly because I only 100 epoch. That's why some wrong prediction is there. But at least it is detecting. See, at least it is detecting something. Now you can also detect with another image. It will take another sample 4 images and it will detect. See, everything coming as a queen because in my data set, if you see, queen is there a lot. Okay, if you see in my data, so you'll see lots of queen images there because I collect this data set like randomly. That's why lots of queen. See, q is there. Lots of q you can see in my data set. So here is a q. Let me show you. Here is a q. Then here is a q. If I just go below, you will see queen data set is almost there. Okay, there are lots of images actually of the queen data set. That's why queen is detecting more. Now if I show you the evaluation part, you will see queen accuracy is better than my other accuracy. So our detection is completed. Now I'll go to the detector 2. Now I'll evaluate my model. Now it will show you the final accuracy graph. There actually you will see that. Okay, completed. Now average precision wise, as you can see, AG got 49 9 average precision, 9 got 50 average precision. Jack got 0 precision because Jack image is like very less in my data. Okay. Now queen, as you can see, queen got 30 average precision. King 0, 10, 0. That means what is happening? My data set is imbalanced. Okay. Whenever I collected my data, so there actually ACK was lots of images of the ACK, and queen had lots of images. Okay. And any other data, let's say 10, 9. Okay. And I think there was another level. Jack. Okay, 10 like Jack and King. Jack and King. So these image actually has less images. Okay, less images. That means this is an imbalance problem. Okay, imbalance problem. Imbalance dataset problem. So I want you to fix it. Okay, I want you to fix it. So how to prevent this kinds of imbalance problem, guys? Any idea? So I can see Jack and Queen has lots of images, but 10, 9, Jack and King doesn't have lots of images. So how to let's say fix this kinds of imbalance problem? Any idea? Anyone? So what I have to do? I have to collect more images of the 10, 9, Jack and King, and I have to add inside the folder, right? Then you will see this AP score average precision would be close to each other. If it is close to each other, that means it is learning better that time. Okay. And what to get the data? Card dataset, you can use RoboFlow Universe. So if I open the universe, so RoboFlow Universe has having this kinds of card dataset already. So let's say object detection. You can search for card dataset. Card data. Let me go to the universe again, just a minute. Playing card data row flow. Even it is also already available inside Kaggle. Okay, Kaggle is also having this kinds of card. See, playing card dataset is available inside RoboFlow. So you can also download the data from here, and on top of this particular data, you can train your model. Okay, so this should be the task. So what you have to do, you have to use this particular data, this particular label data, okay, balance data, and you have to train this particular detectron 2 model on top of it. Okay, that time actually you won't be getting this kinds of imbalance problem, because now my model is stick to the queen. Okay, queen label, everything it is detecting as a queen, because queen is having lots of images, okay, inside my data. That's why. Okay, now see, this is the evaluation metric. Yeah, so now you can load this particular model and you can create any kinds of web application. This is a later on task, but I just wanted to show you the custom training, okay, with the help of the custom data, how we can perform it. Now I think it is clear, guys, for everyone. Let me know in the chat if it is clear for everyone, because detection part we have already explored. Now next class onward we'll be starting with the segmentation task. Okay, so make sure you learn everything about the detection. Fine, thank you. So any more query, guys, you are having, you can ask me, because this is all from my end for today. Yeah, thank you, guys. And next class actually we'll start with the segmentation task. As I already told you, image segmentation task we'll be doing. Yeah, I will share my code in the resources section. I think you have the access in the dashboard. Let me know this particular dashboard, Monica. Computer vision hands-on. You can see the link in the description, video description. You can enroll for this particular course, and this is completely free. And there you will get all the resources. Okay, let me show you. If I go to the courses, see all the video and all the resources is there in the resource. Because if I share in the chat, so it will disappear after some times. Okay, you won't be getting this thing. Okay, fine. So after the session, you can get everything from here only, right? Okay. So if you have any query, guys, you can let me know. Otherwise, I think we can conclude the session. And you can practice with different data. I already showed you. You can use RoboFlow Universe. You can use Kaggle.com. If you can find any kinds of data from other, let's say, website as well, you can also download from here. Okay, but at least you have to export the things you have learned. You have to explore with a new data set. Then things will be much clear. Now let me terminate the notebook because I'm not using it. Okay, fine. I think you don't have any query. So I think we can now conclude the session, guys. Thanks for joining the session. And if you like this particular session, so please share this particular playlist with your friends and family. And please subscribe to our channel, because going forward, whatever things actually were coming up, you can see everything from here. You will get the notification from our end. Okay. Nothing in the resources section. See, resources section is there now. You can see now today's session actually you will get after the session. After the session, after some hour, actually this video would be updated. It's not like that instantly it would be updated. You have to wait for some time. Okay. So once I complete the session, I will share this particular resources with my team. They will update in the dashboard. Okay. Thank you. So yes, guys, thanks for joining the session. Bye everyone. Take care. Have a nice day. Bye everyone. Bye. Okay, so thanks for joining the session. So today I'll continue with the image segmentation task with the help of Detectron 2. Because previous session we have already completed our detection part with the help of Detectron 2 and all. Even I have already showed you how we can perform object detection with the help of YOLO series as well, right? Now let's explore something new, because image segmentation task is like one of the like very important task in the field of computer vision, because there are so many application actually these kinds of I mean technology is using. Let's say currently I'm using this particular streaming software, right? So there actually you can see in my background there is a different background I have added. So how I'm able to add this particular background? So here actually your image segmentation task is applied. So basically it is segmenting out me and my chair as an object, and rest of the thing it is removing. Okay, and that place actually I can place any kinds of background images and all. So this is one of the like great application whenever you are using any kinds of meeting platform or let's say streaming platform and all. So these kinds of technology they are using inside that only. So we'll be learning like how we can perform these kinds of segmentation tasks. We'll be learning how we can prepare our data. We'll be learning how we'll be training our model on top of our custom data. Okay, we'll be exploring the model view as well. So everything I'll be discussing about in this particular session. So make sure you are watching this particular session till the end. And if you're looking for the previous resources and all, I'll tell you each and everything where you will get. Okay, after that, I think I will start with the session. So where will I see the previous sessions for the practice purpose? Okay, so Akash, so for this, what you have to do, you have to log in with your iNeuron website. So here you will see, let me just share my screen. Yeah, I think my screen is visible. So here, first of all, logging with the iNeuron website. So here, just go to the community program. Okay, if you go to the community program, now if you just scroll just right side a little bit, you will see my course. Okay, you will see my course called Computer Vision Hands-On. Now open this particular course. And if you haven't enrolled for this particular course, first of all, just try to enroll. This is completely free. So you don't need to pay for anything. It is completely free. Just enroll for this particular course. Then click on the go to courses. Now, once you open the course, you will see the dashboard. Now let me log in with my account. So this is my course. Now see, all the lecture has been updated here till day 7, I think. Yeah, till day 7 we have completed. Like yesterday I was talking about this detectron 2, like object detection part. It is already updated here. Now if you are looking for the resources, so just click on the video and there is a resources tab actually will see. So click on the resources tab, see all the resources has been updated here. Got it? So there actually you can get all the resources and as well as the video material, everything in one place. So I hope guys this dashboard part is clear. Now we can start with our session. We can start with our agenda for today, right? And in this particular session, actually, I'm going to follow the RoboFlow blog only. So they have written one beautiful blog on the image segmentation. So this is called instance image segmentation. Okay, so let's say this is the image. You have to segment out that particular image. Okay, so this is called masking. So they're applying masking on top of it, and they have already given the step like how we can perform it. Let's see, if you want to get the notebook, you can also download the notebook and all. But I already prepared one notebook for you. I'll show you that particular notebook. I referred this particular blog website and I prepared everything, right? Now, if you see here data annotation part, you can also see how we can perform the data annotation with the help of RoboFlow platform. I'll tell you, I will upload my data and there I'm going to annotate my data. See that the annotation they are doing, it is called this one actually polygon annotation. Okay, polygon annotation. Why it is called polygon annotation? Because it is more than 4 points here. But previously we used to create a bounding box, and in a bounding box we have 4 points, right? 4 coordinate point. But here you have more than 4 points. Okay, that is called polygon boxes. So okay, you have to create this particular polygon annotation here. Then we can do the annotation. See, that's how we can do the annotation. After annotating, I will be saving the label. Then we will be registering the data. I think I already told you how to register the data with the help of detectron 2. Then after that, we'll be starting the training. Okay, see all the steps they have already given here. So let's discuss one by one. I will discuss each and everything, how to prepare the data, how to register the data, how to start the training, how to choose the model, everything I'll be discussing about. But you can read this particular blog if you want to get more idea about instance image segmentation and all. You can read this particular blog. Okay, we'll get the entire idea. Now see, whenever I'm talking about segmentation, okay, that means image segmentation, there's some variant of the segmentation. Okay, so let me show you some variant you will get over the Google. So the first segmentation, we call it as instant segmentation, and this is most used segmentation task. Instant image segmentation type. Okay, if I search, let's see if I get anything. Yeah. So here you have something called A segmentation, instant segmentation, then watershed segmentation, panoptic segmentation, then you have clustering segmentation. Okay, then yeah, so you have different segmentation here, but we usually use instance segmentation, panoptic segmentation, and there is another segmentation called let me just show you. If I go to the image, yeah, so this is the image I can refer. Yeah, so semantic segmentation, instance segmentation, and panoptic segmentation. Okay, so this three type segmentation is like very popular, and this is frequently used. Okay, this is frequently used in the industry. Okay, as you can see, but this three type segmentation you can see, but now you can ask me which segmentation I should use, which segmentation I should use in my task. So it depends upon what kinds of application you are building. Let's say you are building one application. In that particular application, you are only worrying about the object present in that particular image. Okay, only the selected object. Let's say this is the instance segmentation. I only want to segment out this particular person and vehicle, and rest of the thing I don't want to consider. So that, let's see, here you can see this rest of the background is black because I'm not considering the background. I'm only considering the person and vehicle here. So this is called instance segmentation. Now, what is semantic segmentation? In semantic segmentation, you are segmenting out everything. Okay, you are segmenting out everything with the same color. So let's say person you are segmenting out with the red color, vehicle you are segmenting out with the yellow color, road you are segmenting out with the blue color, and sky and tree you are segmenting out with another color. Okay, so this is called semantic segmentation. Basically, you are trying to consider everything. Okay, everything in that particular image. Okay, but what is the panoptic segmentation? Panoptic segmentation, you are segmenting out all the objects but with a different color. Okay, let's say this person has been segmented out with this particular color. This person has detected with this particular color. Okay, this vehicle has detected with this particular color, and this vehicle has detected with this particular color. Okay, all the colors are different here. So this is the difference between your semantic segmentation, instance segmentation, and panoptic segmentation. I hope this is clear, guys. Yes or no? Right? But now let's say I'm using this particular streaming software. Now here I want to only remove my background. So which particular segmentation I should use here? Which particular segmentation I should use in my application? Any idea? Semantic segmentation, instance segmentation, or panoptic segmentation? Any idea, anyone? If you can let me know in the chat. Just think about it. How it is segmenting out me? It is segmenting out me and my chair, and rest of the thing it is removing. So can I apply instance segmentation here, guys? Please let me know, because I only want to segment out the selected object present in that particular image. Okay, and rest of the thing I want to consider as a black. Okay, so we can apply this instance segmentation in that particular application. Okay, and they are using instance segmentation in this particular application only. That's it. But whenever I'm talking about self-driving car, I think you have seen self-driving car, right? Self-driving car. Let's say self-driving car simulation. So you will see it is also applying segmentation only. Okay, but it is segmenting out everything. Let me show you. There are some beautiful image I think I can get. See guys, this is the environment of the self-driving car. Okay, now here if you see, it is segmenting out everything. It is segmenting out the road, buildings, okay, traffic light, in front of the objects, pedestrian. Okay, it is segmenting out everything. That means it is applying this particular segmentation, panoptic segmentation, or you can also talk about semantic segmentation. Because whenever you were implementing any self-driving car, you have to consider all the objects present in that particular environment, right? Otherwise it might collide with the accident, right? So that's why you have to take care of everything. Got it? So self-driving car also using this kinds of segmentation like technology in the backend. Got it? So those who are working in the automobile industry, so maybe you have heard of this particular segmentation. So if you're working with the autonomous vehicle, so you'll be mostly seeing this particular application and all. Right? Okay. All right. Now, first of all, let's see the data preparation part, like how we can prepare the data. before starting the model training and all. Okay, then after that I'll show you how we can like train on top of our custom data and all. And we'll be using this particular detector on true framework only, because yesterday I was discussing about with the help of detector on true you can perform object detection, then image segmentation, as well as the key point detection. These three tasks you can perform. Okay, so it is having one model view. So this is the model view. Let's open the model view. So in the model view they have already written everything. So Coco object detection baseline, then instance segmentation baseline, then you have key point detection baseline. You can also perform panoptic segmentation. That means this particular segmentation you can also perform panoptic segmentation. Okay, but I'm going to show you the instance segmentation task, because panoptic segmentation is more costly, because whenever you are annotating your data you have to annotate for all the objects. Okay, and this is more costly, it will take more computational power, right? But whenever I'm talking about instance segmentation, it is easy to implement, because here I'm only considering my selected object present in my image. That's it. So I hope guys this part is clear. If it is clear, please write down something in the chat so that I can go proceed. Let's make the session interactive so that I can get you are getting everything. Okay, thank you guys. So now what I will do, I'll show you the data preparation part. But first of all, let me show you the data set I'm going to use here. So this is the data. I already annotated this particular data, and this is already annotated in the Coco format. As you can see, this is the JSON file, and inside the JSON file, I'm having all the annotation points and all everything. Let me open this particular file and show you. See, all the image and everything has been annotated here. Okay, in the single file, all the image information it is already capturing. See, these are the like points. Okay, your this annotation point. Okay, see segmentation annotation point. So these are the coordinate point. Okay, and this is the label. Now how we can perform this particular annotation? So for this there are some open source tool as well. If you, let's say, don't want to use RoboFlow at that time, you can use this is the tool, label. Okay, label me. There is a tool called label me. But what is the issue with this particular tool? You have to manually install this particular tool in your system. Okay, and you have to manually take care about your data. Like you have to manually take care of the tensor split and all. Everything you have to take care manually. But whenever I'm talking about RoboFlow platform, it is having some beautiful, let's say, automation technology with that. So you just need to upload your data, annotate it, and save the data. It will automatically perform tensor split, and it will automatically convert your data to the Coco format and all. Everything it would be automatically performing. So you don't need to do anything. So that's why I personally prefer RoboFlow platform instead of using these are the open source tool. Okay, because sometimes we face difficulty actually whenever we install these particular tools in our system and all. Okay, because this is like very old implementation, as you can see, old implementation, but still this research is active. You can see the last commit was 2 months ago. Okay, still it is active research. So you can use any of them. I'll suggest you can also explore this particular tool called label me, or else you can use the RoboFlow platform, because it would be easy for me to annotate my data. Now what I have to do, I have to sign up with my account first of all. All right, now here I'm going to create a new project. I can name this particular project as segmentation demo. And annotation group, here you can write anything. So let's see what are the objects I'm having in this particular image. I'm having dog, person, mask, cow, motorcycle, helmet. Then I'm having different foods as well. So let's write only dog here. Okay, later on I will be writing other label as well. So I'll be writing dog as of now, dog. Now here, what is the task we are performing, guys? Instance segmentation or semantic segmentation? So which task I want to select? Which project I want to select? I'm to select the instance segmentation. Okay, so this particular project I'll be selecting instance segmentation. Now I'll be creating the project. Now here I need to upload my image. So let's select some of the image. So I'll be selecting this image. Then I can select this particular image. This image also I can select. Then I'll be taking let's say this image also I can consider. And I can also take, let's say, this image. So I'm taking some of the image. So you can consider all of the image, but it will take time to annotate all the image. So that's why I'm taking some sample of the image. Okay. Now let me take another image. I can also take this cow image. So I've selected 6 images, okay, from this particular list. Yeah, 6 images is fine for me. So I'm going to upload these are the image here. Now I'll save and continue. Now start manual labeling. Assign the image. Now I can start the annotation. Okay, so by default, it is having one annotation tool called Smart Polygon. So this is AI based polygon they have developed. Let's say if I click here, so it will automatically select. Okay, it will automatically select that particular object. See, but it is initializing the model. So it will take some time. First of all, it will initialize the model, then it will automatically segment out. And if you want to get a good, let's say, output, you have to take their premium subscription for this. If you want to access the premium model and all. So this is called auto annotation. You can perform auto annotation here, but it will take time. So what I will do, I'm going to use just a minute. I'm going to use the manual polygon tool. Okay, this is the manual polygon tool. And here I will start the annotation. So this is kinds of lasso tool in the Photoshop I think you have used. So this is the similar wise your lasso tool. See, that's how you have to create the polygon mask. Basically, I want to select this particular object. Okay. The way actually we use lasso tool in the Photoshop. And that is why it is very time taking task, because you have to carefully select that particular object. And the more good annotation you will be doing, the more good prediction you will be getting from the model. So here I'm doing quickly because I want to complete. And whenever you are doing, make sure you are doing in a good way. The more smaller step you will be taking, the more good annotation you'll be performing here. So let me complete it quickly. So I'll be doing it quickly. Now I'll be adding this particular point. Now this is dog. I'll just save enter. Now see, it has been annotated. Now I'll go for the next image. Now here I can annotate first of all the helmet. So this is nothing but helmet. Sorry, I think it has disappeared. Helmet. Now let's annotate another helmet. Now you can also segment the person. So this is person. You can also consider this person. So here I'm doing quickly, but whenever you are doing, make sure you are doing in a good way. All right. Now let's go to the next image. So this is dog. So this is dog. I'll go to the next image. Now this is cow. This is cow. Now next image. Now you can also detect as a vehicle. So this is I can consider as car as of now. You can also consider van or car. You can consider any of them. This is also car. This is also car. So you can complete all of the car present in that particular image, but I'm only showing you 3 images, okay? Because it will take time. I'll go to the next image. Now here you can also annotate the helmet. And you can also annotate the person. Person, right? So all the 6 images I have completed. Now what I have to do, I have to go back, and here I will add the image to the dataset. Now perform 10 test split operation. Now create a new version of the image. If you want to perform any pre-processing, you can perform, otherwise press continue. And if you want to apply any augmentation technique, you can add, otherwise press continue. Then I'll create my data. Now here I can export. Now I'll download as a zip file. Now what is the format, guys? I have to download my data. Can anybody tell me? What is the format I have to download my data? I have to download my data as a COCO segmentation. Okay, COCO segmentation format. Okay, COCO segmentation format. Either you can also download as a XML, that means Pascal VOC. If you're downloading as a Pascal VOC, then you have to convert Pascal VOC to COCO. And for this, I'm going to share one script. See, label me to COCO. So this particular script you have to execute. Then it will convert to COCO. But you can also directly download the COCO. It is also possible. See, COCO image segmentation. Okay, now let's continue. All right, now you can unzip and you can use this particular data. Now you can use my data. I will share my data with you. So it is already available in my Google Drive. So here I already uploaded my data. So this is my annotation file and these are my images. Okay, so these are my images, as you can see. Now let's explore the training part, how we can perform. So before that, what I will show you, there is a notebook I prepared. So this is the notebook. Okay, so this notebook I'll be referring to train the model. First of all, let me close this at the tab. Yeah, I think it's fine. So the first thing, I'll be connecting with my GPU. So T4 GPU is fine, save. And let's connect with my GPU. Now let's check the GPU, whether I got the GPU or not. So this is the command you can execute. So here I got Tesla T4 GPU. Now, first of all, what I have to do, I have to mount my Google Drive, because all the data, everything present in my Google Drive. This is the location. So I already told you what is mount like Google Drive. So if you're mounting the Google Drive, that means you can access your Google Drive and you can access all the file present in that particular location, right? So that's why we'll be mounting the Google Drive at the very first. Now let's connect to the Google Drive. I'll choose my account and continue. And this is the same notebook I shared for the detection notebook as well. So the same command I'm executing to install the detectron 2. Nothing changed. You can check the previous notebook. You will see the same thing. I'm installing the PyML. After that, I'm checking the version. Then I'm installing the detectron 2. Okay. Same way I'm doing everything. Now see, like my drive has mounted. Now, first of all, I'll be installing detectron 2. So it will take some time. Let's wait. And tomorrow, I'm going to show you the segmentation with the help of YOLO V8. Tomorrow, we'll be exploring YOLO V8 for the segmentation. Right? Then after that, I will start with the object tracking. Object tracking. So we'll be exploring something called deep sort and YOLO V5. Tell me some specific application where this image segmentation can be applied. So I already told you this meeting software and streaming software. Like when you do video conference, you can change the background, right? And to change the background, first of all, you have to segment out that particular object. That means me as a person and my chair as a objects. You'll be segmenting out these two things and you will be removing entire things from the background. Then you can add any kinds of background there. So this is the application of the image segmentation. Then self-driving car should be also another example, because whenever autonomous vehicle will let's say move on the road, it will segment out everything in front of it. So let's say pedestrian, traffic light, roads, okay, sky, everything it will segment out. So this is another application. So you can see like different application are there for the image segmentation task over the internet. Okay, still installation is going on. So let's wait. Once it is done, then I think I can show you the import operation. Then I can start with my training. So you can try this panoptic segmentation by you. So as I already told you, it also support panoptic segmentation. So panoptic segmentation baseline is already there. So after this particular learning, you can also try with panoptic segmentation. Same thing, only you just need to change the model. That's it. Can we apply this where the motion carried out, or can we apply this in static area also? Yes, you can do it. You can do it, but I just need to like confirm your specific, let's say, task, like where you want to exactly apply, like how you are going to apply. Sports industry also they're using segmentation in sports. Computer vision. Yeah, so they're also using in the sport industry. You can see it is also segmenting out the player. Okay, player, it is also segmenting out. See, So they're also using here this particular technology. And Meta AI proposed one amazing model called segment annotating. Okay, this is the model. So this model can perform auto annotation. So let's say the annotation we have done like manually. So you can use that particular segment anything model, and you just need to select that particular object. Automatically it will segment out whether it's a person, whether it's a cow, whether it's a dog, it will automatically segment out. And if you want to learn this particular segment anything model, so in my YouTube channel I already created one tutorial. So let me show you. So this is my channel. If you go to the video section, so here I already created segment anything. Okay, segment anything. So this is the video you can refer. So that's how actually you can perform the auto annotation with the help of this meta model, this meta segment anything model, SAM, or you can call it a SAM model. Okay, installation is completed. Now I have to import all the library one by one. Done. Then first of all, I have to relocate my location because you can see in my drive, I'm having one folder called classes. Inside that, detect on true. Okay, so here is my data. So I'll copy this particular path and here I'm going to mention it. That's it. Now I have to relocate that particular directory. Now if I just write pwd, you will see I'm inside the detect on 2 folder. That means this particular folder. Now I can access everything. Fine. So the first thing what I have to do, I have to register my data. Okay, I already told you the registration concept inside detect on 2. So here you just need to register your data. So you can give any name. I have given sample, and you have to specify the location of the annotation file. So this is the location of my annotation file inside data. This is the location, and I'm also specifying the image location, data.image location, right? Now let's register the data. Then I'll be saving the metadata objects. Done. Now, if you want to visualize any image, so you can take from the dataset dict from this particular object, and you can visualize it also with the help of this visualizer. Visualizer method we imported here from the detect on 2. So let's visualize some of the sample image. See, this is dog, this is fruits, this is dog. So these are some sample images I am visualizing here with the actual level. Okay, with the actual level. See, these are the car. Now what I have to do, I have to start the training. So to start the training, I think remember I'm using the same code. Let me show you. See here, instead of using detection model right now, you have to use segmentation model. Okay, you have to change this particular model. So here, initially I was writing Coco object detection. If you check out my previous notebook, I was writing Coco object detection, but here I'm doing something called instance segmentation. So that's why you have to write Coco instance segmentation. How will get this particular name? Just go to the model view, go to the segmentation baseline, detection baseline, and instance segmentation baseline. And this is the model I'm using, R50 FPN. Okay, so I'll open this particular model, and now you can see this is the name. This is the name. Just copy this particular name and try to mention it here. That's it. Now let's see, if you want to perform panoptic segmentation, what you have to do, go to the panoptic segmentation baseline. Panoptic segmentation baseline. Let's say you want to use this particular model, R50 FPN. Open this particular model and copy this particular URL. Coco panoptic segmentation. Now you can see the task is changing, right? That's how you can change the different model with different tasks. Now let's say I want to perform instance segmentation. That is why I've written Coco instance segmentation, and this is the model I want to use, mass RCNN R50 FPN 3x model. Okay, so from this particular YAML file, it will automatically get the model, and I'm giving my training data, and the same configuration you have to give for the URL as well. Okay, checkpoint URL as well. Now here you have to specify the maximum iteration you want to train. So here I'm taking 300 iteration, but whenever you are having more data set, make sure you increase this particular iteration size. Okay, so here I'm not going to get any good performance from my model because I'm having very less images, and I'm also training with less number of epoch. That's why. Now you can also change the batch size and any other parameter, but it's not recommended. You can keep it up, but if you have some good configuration PC at the time, you can increase the batch size and all, right? This thing actually you can perform. Now, once it is done, you can also save the model and everything. Now you can start the training. Now let's start the training and see. So it will first of all load my architecture, then download the model. Okay, so iteration has started. Now you can see 20 iteration is going on. And this is the loss, this is the class loss. And if you go to the Google Drive and if you go back, you see it will create one folder called output. Inside output, it will save everything, all the artifacts, all the logs, all the model, everything it will save here. So let's wait. So 200 iteration is going on out of 300. Okay. So training is completed. Now I have to save my model with the confidence score. Okay. I already discussed what is confidence score and all. Now it is saved. Now if I show you, so if I go to the output, now if I refresh this particular page, see my model has been saved. Model final.pth. PTH is the format for the PyTorch because this is the PyTorch implementation. Now what I have to do, I have to load my model and I have to do the prediction. So here what I'm doing, I'm taking some test data. So as you can see, I'm having one test data directory. So inside that, I'm having some test data. So these are some testing images I'm having. Okay, I'll be picking one by one and I will do the testing on top of it. So here you can give the directory of the test data. Then I'll be loading the model object. So this is the model object predictor. And inside that, I'm doing the prediction. And that prediction actually I'm just visualizing with the help of visualizer object. Let me show you. See, it is segmented out the dog and see the confidence score. Okay. See, it is 97% confidence a dog. Then it's a person. Then you can see it's a helmet. Then again, it's a dog. That means it is segmenting perfectly. Although I trained 300 epoch and it's still, if you see, it is segmenting out in a good way. Okay. Now you can also take the data from the previous sample, like the data you have registered, and you can also see the segmentation. See, so it is also segmenting out the fruits and person as well. Now you can also evaluate the model if you want to see the evaluation score and all. So you can execute this line of code. Now, so guys, you can see the average precision score. So Apple got 86, Chili, actually, I didn't annotate it. That's why it's having 0. Now, almost all the numbers are close to same. That means it is learning. Your model is learning better. So some of the like object, it is not having like good images in the like image directory. That's why it is coming very less. So yeah, so this is the thing. Now you can also save the config.yaml file, this configuration file, because whenever you will be creating the web application, at the time you need this particular config.yaml file, and I have already saved it. If I go back, so here is my config.yaml. I think outside output folder it is there. Config.yaml I have set. Yeah. So everything is working fine. Now, if you have any question, guys, you can ask me about this implementation, and I will suggest try to at least try this particular panoptic segmentation one. Okay, panoptic segmentation from this particular backbone. You can follow the same notebook. You can only change the model. And there are so many dataset also in the RoboFlow universe. Let me show you. If I go to the universe, you can search about, let's say, instance segmentation. So these are the dataset are available. Okay, you have the different dataset: glass count, segmentation, bar tool, weight detection, then point detection. Okay, you can also even upload your own data here. It is also possible. You can also give your own data if you want to give. Even kaggle.com having also lots of data. So if I go to the Kaggle dataset, let's say I want for the computer vision. Okay, so these are the data related computer vision. Now let's see, you want to take the segmentation data. So you can search about instance segmentation. I can copy, and here I can search. See, these are the data related instance segmentation. Okay, you can use it. So we are having ISAID dataset, brain tumor dataset, football dataset, strawberry dataset, electron microscopy dataset, food image segmentation dataset, road line instance segmentation dataset. So these are very good problem statement. I think you can work on. Okay, so these are real time problem statement. Then face mask paddle detection, sport coco segmentation. Let me check. See, furniture detection. So satellite image is also there. Yeah, so you are having different data set. You can use it. So if you have any query, guys, you can ask me in the chat. And tomorrow I'm going to use the object tracking task. Okay, because I'm going to track the object right now, because we have seen like how to detect and how to segment out the objects, but how to track that particular objects. We'll be learning this part. And if you're interested learning end-to-end implementation, at that time you can visit our YouTube channel. So in the playlist section, you will see we have already covered object detection end-to-end projects. Let me show you. So see, this is the object detection end-to-end projects. So this is completely end-to-end playlist. And here I already showed you Jenkins CI/CD deployment. Okay, on the AWS cloud. Like from the data ingestion itself, from the project setup itself, I have covered everything. Could you please share your white key link? Yes, you can search with the name. This is the name you can search over the YouTube. You will get my YouTube channel, Akash. DS with Bappy. Okay, DS with Bappy. All together you have to write. Okay. So anyone worked with the GAN before here? Have you worked with the GAN concept? GAN, like generative adversarial neural network, GANs. Any idea about GANs? With the help of GANs also you can generate your training data. Okay. Let's say you don't have any training data, you can also generate your data with the help of GANs. Nowadays, actually, lots of application you will see like on top of the GANs, like image generation. Have you seen like DALI API, DALI from the OpenAI, DALI API, DALI API. So if you give any prompt, it will generate the image for you. Right. Yeah. So they're using this GANs technique at the end. Okay. GANs is a generation model. It's a generation model. Generation model. So it can generate the image from the noise data. Let's say you are having one noise data here. So let's say this kinds of noise data. By referring this particular noise data, it will generate one beautiful image. Let's say it might generate one cat images from the noise data. Okay, that's how we can generate. Yeah, what is the question you can ask, Akash? Can let me know your question. Then I think I can conclude the session because this is an this is for today only. And all the resources I will be sharing, everything would be up to date in the dashboard. Okay, dashboard itself, we will get everything. So I'm not going to share in the chat. Instead, after a session, you can look for in the dashboard. Everything you will get from here only. Suppose we are making the API projects, how we'll get the different APIs in our projects. Suppose we are making the API project, how we'll get the different APIs in our projects. What is the API projects you want to develop? I didn't get. The API means some of the model actually is hosted on the like platform. There you can access that particular model through API request. You can even create your own API. Regarding API key. Yeah, API key, like the platform will provide you. Let's say you are using OpenAI. That time you can use OpenAI API key. Let's say if you are using Bedrock, so at that time you have to use AWS API key, right? Secret key and secret access key. So these are the credentials you have to use. You can also create your own API. It is also possible. Okay. So there is a, I think community session starting. Let me show you in the YouTube channel, or you can go to our website. Just a minute. In the community program, you will see LLM Ops community is starting. So this is the course, and starting from 16th April, like from today only, 3 to 5 p.m. IST. So here you will learning about LLM Ops. Okay, so there actually this API would be discussed, like how we can create our own API, how we can deploy our model. Okay, see, deploy Llama 2 on Amazon SageMaker endpoint, so you can learn this. Okay, yeah. All right, guys. So this is all from my side for today. So let's connect tomorrow and try to explore the object tracking part. With that, guys, thank you so much, guys, for joining the session. Bye, everyone. Take care. And I'm ending the session. Bye, everyone. Bye. So today, in this particular session, I will continue with the segmentation part only because yesterday I was talking about the detect on two, like segmentation part, but Today, I was thinking to show you also the YOLO V8 one, because I was telling you with the help of YOLO V8 also we can perform this kinds of image segmentation task, right? Because YOLO V5 one amazing like framework and algorithm they have developed, so you can perform multiple tasks with the help of one particular algorithm only. Like you can do object detection, image segmentation, and image classification. All the three kinds of tasks you can perform. So let's try to see the instance segmentation part with the help of YOLO V8 today. And from tomorrow onward, I will show you the object tracking part, like how we can perform the object tracking, okay, with the help of deep sort and YOLO V5, this thing. Now, first of all, I want to show you where you will get all the resources previously we have covered. So for this, first of all, try to log in with your dashboard. And in the dashboard itself, you will see one community program section. So click on the community program section. And here, if you just go to the right side, here you will see my courses called Computer Vision Hands-on. So first of all, make sure you have one account in the iNeuron website, okay? And if you have one account, so you will be able to see this kinds of interface. And if you haven't enrolled for this particular course, first of all, you have to enroll for this particular course. And this is completely free. You don't need to pay for anything. So I have already enrolled for this particular course. So what I will do, I will log in with my account and I will try to show you the dashboard, like where you will get all the resources. Let's say I'll go to my courses, Computer Vision Hands-on, and see guys, this is the dashboard. And from day 1 to day 8, I think, yeah, day 8, everything is up to date. So day 8, I was discussing about detect on 2 image segmentation part. And if I click here, the resources is also updated here. Okay, so make sure you enroll for this particular course and get all the resources from here only. All right. Okay. So I'm not going to discuss the image segmentation, like what is image segmentation exactly, because I already given you the idea what is image segmentation and how many like types of image segmentation are there. Let's say I was telling about instance segmentation, panoptic segmentation, semantic segmentation, and I was also discussing about the difference. I was also discussing about the difference application of that particular segmentation, right? So you can go ahead with your previous lecture and try to understand, okay, this part. Yeah. So today in this video only, I will be performing the instance segmentation task because this is the most frequent used, okay, in the industry. All right. Now let me just change the view. Yeah, now I think screen is visible properly. Now, first thing what I will show you, I'll show you the YOLO V8 repository. Okay, so if you just search for YOLO V8, YOLO V8 GitHub. Okay, YOLO V8 GitHub. So this is the official repository we'll get. So YOLO V8 GitHub, as you can see, and this is for Ultralytics. And here, just a minute, I think this is, yeah, this is YOLO V8. This is the detection, as well as you have something called segmentation and classification. Okay, you can also perform post detection. They have added this particular new feature, and this one, oriented bounding box detection. Okay, this thing actually you can also perform. I think I was discussing about in the YOLO V8 session whenever I was discussing about the object detection part. Okay, that time I was discussing about. So here I'm going to perform this segmentation task. What is the segmentation? This is the post detection. This is the segmentation. Oh, yeah. So I'm going to perform this particular task called segmentation. Now, if I open the segmentation documentation, so they have already given all the, let's say, code snippet and all, like how to perform this particular image segmentation and all, everything they have already mentioned. All the steps, all the models. Okay, this is the model view. So these are the model actually you are having inside the image segmentation. And this is like segmentation model. As you can see, this is a seg model. Segments, this is the segmentation model. And DEC means this is the detection model. CLS means this is the classification model. Okay, that's the difference. Now, as you can see, this is the example code. If you want to run it from Python SDK, you can copy this particular code, you can run it. And if you want to run from the CLI, you can execute this particular code. Both, I think I already showed you, right? Now, see, evaluation, inference, all the code they have already given. And if you are getting any kinds of issue, so we can also create a issue section here so that your issue would be also resolved, because this is like very active research. Let me show you. The last commit was 18 minutes ago. Okay, the last commit was 18 minutes ago. So this is like very active research. So whenever you are having any kinds of issue with any kinds of tools and technology, you can create a issue section here and you can mention your issue. It would be resolved quickly. All right. Now what I'll do, yeah, so let's refer this particular documentation and try to complete this particular task. All right. Fine. Now, before that, let me show you the dataset I'm going to use for this particular session. So this is the dataset called cell dataset. So this is the blood cell dataset I'll be using in this particular project. Let me show you the images. So this is the blood cell dataset. As you can see, this is the CT scan blood cell images. So these are the blood cell actually. Okay, these are the blood cell. So I have to segment this particular cell. Okay, as a blood cell. Got it? You can use any of the data. It's completely fine, but I'm going to use this particular data because this was annotated for me previously. Now, why you will get the dataset? Like if you want to, let's say, use any other dataset, again you can use RoboFlow Universe. Let me open the RoboFlow. Let me sign in. Now here, I already had the cell dataset here. Let me remove this particular project. Okay. Now if I go to the universe, so here you can search for instance segmentation. So you have different dataset you can use. See, so these are the dataset for the instance segmentation. So you can use Apple dataset, feature detection dataset, inspection dataset. Then you have different datasets. See, you have satellite dataset also. You can use any of the dataset and you can use it. But I'm going to use the cell dataset because the dataset is available for me. Now, how to prepare this particular dataset? First of all, create a project. So give the project name. Let's say this is segmentation, cell segmentation. Okay, cell segmentation demo. And annotation group. This is a cell only. And this is the instance segmentation task. I'll be selecting this particular project and create a public project. Now let me download some of the images so that I can show you the annotation part at least. I'll download this particular image. Just a minute. This is the same format as you did for your YOLO V5 annotation. Only you just need to do the polygon annotation, but format will remain same. In the train folder, you will have the image and labels. Inside that, you will have the labels. That means the YOLO annotation. Inside image, you will have the images. And you will have one particular, let me show you, file called data.yaml. Data.yaml will contain the folder location. Okay, I'll tell you. First of all, remove it, this particular cache file. I think everything is fine now. Let me check this folder. Okay. Now I think it is downloaded. Now let me open it up. So this is my cell images. Okay, this is my cell images. Now let me upload these are the images in my RoboFlow platform. Now I'll start the labeling, assign the image. Okay, now you have to use this polygon annotation. Okay, make sure you are using the polygon tool and you are annotating this particular cell. Okay, so this is nothing but cell. Now this is also cell. This is also cell. So like that, you have to complete for all the cell present in that particular image. But I'm only annotating 3 cell because I want to complete it quickly. So what I will do, I'll go to the next image and I'll start again annotation. Done. Now I will go to the next image. Let's annotate. I'll go to the next image and I'll also complete. So let's say I have completed for all the images. Now what I have to do, I have to go back, add the images to the dataset, perform the 10 test split. Okay, then after that, what I will do, I'll create a version. Then let's continue, and create. Then I will export the dataset. Now here I have to download a zip file and I'll be selecting this one, YOLO V8 segmentation. YOLO V8 segmentation. So here is the oriented boxes, convert to object detection, Coco YOLO V8. Where is the YOLO V8? So yeah, so this is the YOLO V8. I'll be saving it. Then I can continue. So see, it has downloaded. Now if I open it up, now see guys, you got the same folder structure. Okay. Now you can delete this particular to readme file. It's not required. So inside training folder, you will have the training images and the labels. Okay. So this is the labels and it will have the annotation. Okay. And it will have the annotation. That means that coordinate point, that polygon coordinate point. See, this is the polygon coordinate point and this is the label. 0 means this is a cell. Okay. It is considering a cell. How will identify it's a cell? So for this, you can open up this particular data.yaml file. So let me open it up. Let me show you. See guys, so you can remove this part, not required. Now see, it is the training folder location, validation folder location, testing folder location. You have number of classes, which is nothing but one, called cell. Okay. So that's how your data will look like. Then you have to upload this particular data to the Google Drive. So I already uploaded inside my Google Drive. As you can see, I have uploaded as a cell data. So inside my Google Drive, I have updated everything. Now what I have to do, I have to copy this particular data.yaml file and I have to paste it outside of the cell data folder inside a Google Drive. Okay. Then here I'll be creating one Colab notebook. So this is the Colab notebook I already created. Now let me execute this particular notebook and let me show you the training process, how we can perform the segmentation training. Fine. So first thing what I have to do, I have to change my runtime to the GPU. So for me, it is already selected T4 GPU. I'll be saving it up, then connect with the T4 GPU. Fine. Now let me check whether I got the GPU or not. See, here I got Tesla T4 GPU. Now the next thing, what I have to do, I have to check the directory. So I'm inside content directory. So this content directory I'm storing inside the home variable. Okay. If I'm printing home, that means it's a content. Now, first of all, I have to install YOLO V8. And how to install YOLO V8? I think I already given you the idea whenever I was doing the detection part. For this, you have to install this particular Alterytics package. All right. So let's install this particular Alterytics package. Okay, so installation is completed. Now what I have to do? Okay, still it is running. Let's wait. Yeah, it's done. Now let me import and check whether everything is working fine or not. Now, first of all, let's inference on top of the model actually we're having, the pre-trained model we're having. So here we'll be doing the inference and we'll be doing through the CLI, command line interface. Okay, so for this, you have to execute this particular command, YOLO. Task is equal to segment because I want to perform the segmentation task. Mode is equal to predict. That means I only want to do the prediction. Model, which model you want to use. So you can go through the model view and you can select the model. So let's say this is my segmentation model. So I want to use this particular model. Nano model, I think, or smaller model. Let me check. Yeah, smaller model. So I'm using this model. So copy the name and paste it here and make sure you give .pt. Okay, after that. Confidence score I'm setting because I'm telling my model if you're more than 25% confidence that time, just try to show me the prediction. Otherwise, try to ignore. And this is the source image. So this is the URL of the source image. So if I open it up, so this is the image. So this image actually I'm giving. So it will segment out this particular image. Then after that, I'm also saving save is equal to true. That means it will create a runs folder. Inside that, it will save everything. Now let me show you. So if I execute it, first of all, it will download the model. Now see, runs folder is created. Now it says runs folder, segmentation folder, predict folder, and this is my prediction. So let me show you. This is my prediction. See, it has beautifully segmented out all the object present in that particular image. Now, if you want to visualize on the Colab notebook, it is also possible. For this, you have to execute this line of code. See, guys, so it has segmented dogs, person, backpack, handbag, and car. See the results, okay? It's pretty much good. Now, you can also try with Python SDK for this, call the YOLO module, and inside that, just mention the model you want to use. And after that, just try to call this particular predict method and provide the source image. That is that particular URL and set the confidence score. So it will also give you the same thing. Now, this is the bounding boxes coordinate, and this is the confidence score. This is the results, and this is the result masked. So you can use visualizer or RoboFlow vision, like supervision to visualize the image. Otherwise, you can also use OpenCV or Matplotlib to visualize this particular image. But if you're using command line, so you don't need to do it. It will automatically show you. All right. Now what I have to do, I have to start the training. So you can get the dataset from RoboFlow Universe. Otherwise, you can use your custom data. So first of all, what I have to do, I have to mount my Google Drive because my dataset is present inside my Google Drive. That's why I have to mount my Google Drive first of all. So let's mount my Google Drive. Let me connect my drive. And continue. Done. Now if I refresh, so my drive has uploaded. Now if I go to the drive, classes, I think not classes, my courses. Inside that I'm having YOLO V8 segmentation, this particular folder. So I'll be leaving this particular location here. So make sure you are giving your location, not my location. Otherwise it won't be working. So let me close it. So this is my root path and this is my current path. Now I have to change this to this particular path. So that's why I'm writing the cd command. That means change directory. Now if I again wpwd, so this is my current location. Now if I do the ls, you can see all the folders and file inside that. Now I can start the custom training. So to start the custom training, you can execute this particular command YOLO, task is equal to segment, mode is equal to train, and model you want to use the same model. Data.yaml file location you have to give. So this is the data.yaml file location. This is the data.yaml file location. And this is the number of epoch you want to train. So let's give at least 100 epoch. And this is the image size and save is equal to true. Okay, so let me start the training. See, my epoch has started. So it will take some time. Let's wait. Once this training is completed, I will show you the prediction as well and how you can get the losses and accuracy, everything I will discussing about. So in between, if you are having any question, guys, you can ask me in the chat. Any question related to the object detection, image segmentation you are having, you can let me know. Architecture of YOLO V8, sir, explain it. See, architecture wise, you can get from the research paper and documentation and all. So this is the hands-on session, Charan. So you can see the playlist. This is the hands-on session. Here I'm not going to explain about the architecture and all. So if I go to the playlist, so see, this is the computer vision hands-on series. Because theoretical understanding wise, everybody knows about already. Because theory, if I'm considering, let's say YOLO V8 architecture. See, YOLO V8 architecture. YOLO V8 architecture. So there are so many blogs. There are so many, let's say, research paper actually will get. But whenever it comes into the practical implementation, people will get difficulties. Okay, so that is why I always try to focus on the practical implementation. See, all the architecture is already there in this particular research paper. You can download it and you can try to see that. YOLO V9 will see that if we can cover, we'll also cover that one. But see, this is similar to your YOLO V8, YOLO V7, whatever you have used. Only the slight modification they have done. Maybe you can also explore from your end. It's not a big deal, Monica. You can check out that RoboFlow platform. They have already written the blog on top of it. So the way actually I showed you for all the YOLO, you can, I think, try. And make sure after learning this task, you are trying to build projects, because at the end, projects will help you, right? So try to build projects on top of it. Different projects you can build. Some good use cases you can take up from the Kaggle, or let's say RoboFlow universe, and try to build some projects and try to convert it to as end-to-end pipeline. And if you want to learn how to convert as end-to-end pipeline, you can refer our previous project implementation session, right? That's how you can learn everything. It's not like that you are learning this particular community series and you are not practicing this particular task. So things would be much difficult for you. So make sure whatever you are learning, get the idea, pick up a different data set, try to do your own experience on top of it. Okay, and share this works with your network so that people can get to know, okay, you are doing something and you know these are the technology. So definitely you will get lots of opportunity. %78, 78 epoch out of 100. Still 30 more epochs I have to wait. Akash, I already given you the answer for this particular question. What is the purpose of the YOLO? Because it's a state of the art algorithm. It is like very faster and the result is pretty good. But if you're using faster RCNN, at that time you will see this model is a little bit bigger than your YOLO. So the inference time would be a little bit high there. Latency, you will face the latency. But you can also use this particular YOLO on the edge devices, let's say mobile phone, microcontroller, you can easily run, because if you see the model size is like very less. Object detection is like detecting single objects in an environment. Object segmentation is identifying the multiple objects. No. See, I think I showed you one comparison image. I think remember object detection, image classification, object detection, and segmentation. See this particular image. I think you will get the idea. Image classification means you will have only one single image. In that particular image, you have to classify whether it's a dog or cat or any other objects. Object detection means you should have multiple objects present in that particular image. You have to localize that particular object. Let's say this is a dog, this is a cat. And segmentation means you are masking that particular object. Okay, and rest of the thing you are removing. I already explained this part in the introduction session. Now see, training is completed. Now it has created one folder called runs. Let me show you. So runs folder has created. Inside that, it has saved all the artifact. Now let me show you. So this is the runs folder it has created. Now inside that, it has saved all the artifact. Now if you want to visualize that particular metric, confusion metric, you can execute this particular code. Okay, so it's not running because metrics.png is not there. Why it's not there? Let me execute it again. Confusion metric. Okay, I think confusion metric is not there. They have removed it. So what I can do, I can comment this line. I can show you the results directly. Yeah, so this is the results. I can open in a new tab so that you can see the bigger picture. See, this is the bigger picture. So this is the training loss and this is the accuracy, recall, precision, and MAP score. That means your model is learning. So here I'm using very less number of images. So whenever you are doing actual training at the time, you should have more images. That means you will be getting a good model, because you can see learning is happening. Now you can see some batch prediction. Okay, so batch 0 prediction is not there. Why? Batch train batch. So these are some batch prediction. And now if you want to validate your model, so you can run this particular command, validation, and give the weights, the weight actually you have trained, and give the data.yml location, and it will give you the validation. Okay, so you can see the validation score you got, MAP score. Now you can do the inference on top of the testing data. So here I'm giving my test source images, and I'm giving my trained model location, and I want to perform the prediction. So let me show you. Yeah, now if you want to visualize your prediction, so you can execute this particular command. So it will take all the prediction images from the folder. See, it has segmented out this particular cell as a cell. See, beautifully segmented out. Some of the things it is missed out because again, I'm having very less numbers of images. Okay, it is got overfitted because I trained 100 epoch and I'm using very less images here. All right. See, it's working fine. And see the confidence score, almost 98, 96, 90, 82. So it's a good prediction. Now we can pick up any kinds of dataset from the universe and try to do this particular segmentation task with the help of YOLO V8. Okay, this should be your task. So try to explore. That's actually you'll be learning. Fine. So our segmentation task is completely completed. Let me change the view. So from tomorrow onward, I will start with the this one, object tracking. I'll show you how we can perform the object tracking. After that, I think I will be discussing about this particular things, GANs. I think mostly GANs I'll be discussing. Then, yeah, I think I don't need to discuss anything because most of the thing I've already covered in the computer vision hands-on. And if you want to like learn anything else, you can let me know in the chat. If you want to explore something which is related to computer vision, okay, you can let me know. I think I can conduct that particular session also. All right. So yes, guys, this is all from this particular session today. I hope you like this particular session. If you have liked this particular session, so please subscribe to our channel and share this video with your friends and family. And let's connect tomorrow and try to see the object tracking part. With that, guys, I think I can end the session right now. Bye, everyone. Take care. So, guys, let's continue with our this particular computer vision hands-on series. So today I'm going to discuss about object tracking part. Okay, like as of now, we have seen how we can perform object detection, image classification. Then we have seen like how to perform the image segmentation task. Now there is another very important task actually will find inside computer vision called object tracking. So why object tracking is very important? I'll first of all give you some idea why exactly this object tracking is required. Then after that, I will show you the tools and technology I'm going to use for this particular implementation. And we'll be seeing that particular implementation, like how we can integrate object detection with object tracking and how we can track one particular objects, okay, with the help of deep sort algorithm, right? So in this particular session, you will be learning actually two things. One is like object detection. After object detection, how we can use object tracking, okay, to track that particular objects. Okay, so both you will be learning in this particular session. Yeah. So anyone having any idea about object tracking before anyone did any projects? Any idea, guys? If not, no need to worry. I will show you how we can do it. It's like very easy. Yeah. So first of all, what I will show you before starting with the session, if you're looking for the previous materials and all, so what you can do, you can go with our website, and here you just look for my courses. So just go to the community program. Inside community program, you will able to see my courses called Computer Vision Hands-On. So make sure you just open up this particular course and logging up with your account. You did the number plate detection, Gupta, but that was the detection actually problem statement. But today we'll be doing the tracking part. Okay, tracking that means it will track that particular objects. I'll tell you what is tracking exactly, right? Yeah. So let me log in with my account. So this is my account. Now, if you go to the courses, now I think this is the course Computer Vision Hands-On. And here you will see all the recordings, all the materials is already updated inside the dashboard. Okay, now let's see. I have completed till image segmentation with the help of YOLO V8. Yeah, so this is the last video, and inside that particular video, my resources is also updated. So you can, what you can do, you can open up your dashboard and you can download each and everything from this particular dashboard itself. And this particular recording also would be available in this particular dashboard. Even you will also get from the YouTube. And if you're looking for the codes and materials and whatever actually required in this particular session, everything would be available inside resources section. Okay. Yeah. Now let's try to understand what is this exactly object tracking. Okay, why object tracking is required. So let me open up my board, and here just let me write down. See, as of now we have done image classification. Image classification. So inside image classification, what you used to do, you just need to classify one particular image. Let's say this is one image. In this particular image, I am having one, let's say cat images. Let's say this is one cat. Okay, let's say this is one cat. So you only just need to classify whether this particular image is a cat image, okay, or it's a dog image. Okay. Now, whenever I'm talking about object detection, So in object detection, what you have to do, you just need to detect that particular object. You have to locate that particular object. Let's say inside this particular image, I'm having one, let's say cat. Let's say this is cat. Okay. And I'm also having one particular object called person. So this is one person. Okay. Now you just need to classify whether, sorry, you just need to detect whether this is a cat and this is a person. This is a person. Okay. Basically, you are just trying to locate that particular object inside the image. Okay. This is called object detection. Now, what we have seen, we have also seen something called object segmentation. Object segmentation. So inside object segmentation, what you usually do, you just segment out that particular object. Let's say here I'm having one object. Let's say I'm having one person. Okay, I'm having one person here. So what I have to do, I have to segment this particular objects. Okay, that means I will be creating the mask. Okay, mask on top of this particular object. We call it as masking. Okay, instance segmentation. Okay, this is called masking. Okay, and it will tell you this particular mask. This particular mask is a person or anything you can consider in this particular image. Now I'm getting one question, sir. What will be the name of the course? You can already see the course name, right? It's Computer Vision Hands-On. YOLO can be used for classification, segmentation, as well as the detection. Yes, it can be used for the multiple purposes. Even I already showed you. Okay, that YOLO V8, I was doing the detection as well as the segmentation. Classification I didn't show because it is not required. classification wise, I already showed you the TensorFlow and PyTorch implementation. You can check it out in that particular playlist. Got it? Yeah. Now, another task will come inside computer vision called object tracking. Object tracking. So in object tracking, what you have to do, you have to track that particular object. Let's say there is a person. Let's say there is a person. Okay, there is a person. First of all, you have to detect that particular person. Let's say this is a person. This is a person, and this is the position of the person. Let's say this is the location of the person. Let's say location L1. So there is a chance actually this can be a video, this can be a, let's say, live camera. This person is moving. Let's say this person has moved here. Let's say now this person is present here. Okay, now this is location 2. This is L2, location 2. Again, this is a person. Now see, there is a possibility this person will run, this person will move, this person will sit and all, everything it can do because this person is moving. This person is moving. Okay. But if you apply object detection on top of this particular, let's say, person, you will see that object detection can't actually locate that particular uh, uh, object, okay, in an image. Actually, you will see, you will feel lagging there. It won't be happening real time. Okay. So to track this particular object as a real time, like it will also track the position. Let's say it was in the position 2. Again, this person has moved to the position 3. That's how it will track that particular object always. Okay, real time it will track. And if you want to do it, you have to apply something called object tracking. So what object tracking will do, first of all, it will detect that particular object, and that particular object will be tracked. Okay, like whether it's a position 1, or whether it's a position 2, or whether it's a position 3, and so on. Okay, continuously it will be tracking, and so that you can get the real-time location of that particular person. Now you can ask me where it can be applied. Okay, where it can be applied. I think we have seen, guys, the traffic control system, traffic control system, traffic control system. Yes, you can see mostly in abroad actually. So they have automatic traffic control system. So they have CCTV camera. Okay, CCTV camera on the road. So this particular camera will automatically track your car. Okay, car, bus, okay, trucks, everything it can track. Like how many cars are moving. Okay, how many cars are, let's say, going. How many bus is coming. How many bus is going. Even on the airport also, at the airport also, you will see that. Okay, you will see that there would be lots of CCTV camera, and they're tracking the person. Okay, they're tracking the pedestrian in that particular airport, real time. I think you saw, like, from different movies actually, will see that in abroad country actually, they will be tracking the passenger, they'll be tracking the pedestrian, they'll be tracking the employee, everything they'll be tracking. Okay, they'll track their movement and everything, right? Even I can show you some of the example. Let me show you. Here I can search car count, object tracking. So there are different videos I can show you. Let me open this particular video. See, you can see that how many cars are coming, how many cars are moving, everything it is counting. So this is the implementation, but there are some real-time application as well. Car tracking. Computer vision. See, on the road itself, it is applied. See, now let me just show you. See, guys, how many cars are coming, how many cars are moving, how many trucks are coming, how many trucks are moving. Okay, everything is being counted, and it is tracking real time. You can see it is tracking real time. First of all, it is detecting that particular objects. Okay, after that, it is tracking. As you can see, real time it is tracking. See, this bounding box also is moving. That means the tracking is happening. And see how smooth it is. It is doing everything as real time. But if you apply object detection, you won't be able to get these kinds of performance, because object detection will only detect that particular objects. But when objects are moving, so it's difficult to tag that particular objects, okay, with the help of object detection. So that's why we can't perform object detection if you want to track any kinds of objects present in that particular image, or let's say video or live camera. Got it? So this is the object tracking application. And that's why actually object tracking comes into picture, and it is very much important whenever you want to track any kinds of objects. I hope this is clear. Now you can ask me how we can perform these kinds of object tracking tasks. Okay, how we can perform. So the first thing, always try to remember, if you want to perform object tracking, so first of all you have to apply something called detection. Okay, detection. First of all, you have to detect that particular objects you want to track. After detection, you just need to pass this particular detection, okay, to the tracker. Okay, tracker wise, there are so many tracker algorithm are available. I can name some of them. So the very famous is like deep sort. Okay, deep sort. Even you can also use something called byte track. Byte track can be used for the smaller object tracking. Okay, let's say if your object is very small, it can still track that particular objects. Okay, deep sort is also fine, but deep sort will work mostly on the bigger objects and the medium objects. You can use any of them. I'll show you this particular deep sort one. You can also explore this byte track from your end. There are so many content are available for the byte track. You can also check it out. The thing is, like, the major component should be the detection. After detecting, the detection actually you are getting, whatever detection actually you are getting, you have to pass to the tracker, and this particular tracker will apply one of the algorithm. Let's say it will apply deep sort algorithm. After applying this particular deep sort algorithm, it will automatically track that particular objects. Now you can ask me how this deep sort is tracking. Okay, what is the mechanism inside deep sort? So there is like so many mathematical actually intuition inside that particular deep sort, but I'm not going to deep dive into the mathematics. I'll give you some high level overview how things are working. Okay, for this I have prepared one PPT for you. So let me show you this particular PPT. So deep sort, as I already told you, it's nothing but it's a multi-object tracking algorithm. Okay. Now, as I already told you, if you want to perform tracker, on top of any kinds of object, first of all, we have to do the bounding box detection. That means the object detection first. Then tracker needs to be combined with the detector. As I already told you, first of all, you have to detect that particular objects. After detecting that particular objects, you just need to pass those detection to the tracker, and tracker will automatically start the tracking on top of that particular objects, okay, present in that video. Now you can see object tracking versus object detection. What is the difference? I think you already got to know right now. It's important to distinguish the difference terms in the area. Detection, object detection, which is not same as object tracking, identifies an object in a frame but does not take into the consideration in the past position or the possible of the future position. As I already told you, if your object is moving in that particular video, let's say what was the past position, what was the future position, okay, your object detection can't handle this particular situation. Okay, that time, such as a why the pedestrian bulking across the street will be few seconds in the future, object detection is not concerned with the knowing that person at the position in a video frame is also the same person is a different position in a frame from a late time. Instead, it is tasked with the labeling object as a car, person, bicycle, and etc. This means object tracking is the better suited for the tracking specific object position tragedy over the time, while object detection can count similar objects identified in a common identifier label such as a person or vehicle. That means what it is trying to say, object detection can be only applied for the detection purpose, whether it's a person, vehicle, or any other object present inside particular video or frame, and after the detection of the objects, what you have to do, you have to use this particular tracker to track that particular objects present in that particular video or frame. Right? It can remember your past position. It can also remember your future position. That's why object tracking is very much important. And this is the difference between your object tracking and object detection. I hope this part is clear right now. Now let's go to the next slide. Now you can see here, this is the mechanism inside deep sort algorithm. Okay, what is the mechanism? The first step, perform the detection. Now detection wise, you can use any kinds of framework, any kinds of algorithm. So here I'm going to use the YOLO V5. You can also use YOLO V6, V7, V8, V8, V9, and so on. You can also use Detectron 2. You can also use TensorFlow object detection. It's completely fine. But I'm going to use YOLO V5 because YOLO V5 integration is a little bit easy for me. Okay, that's why I'm going to use this particular YOLO V5 one, right? Then step 2, multi-object tracking deep sort data correlation problem. Okay, what does it mean of data correlation problem? See, whenever you are doing this kinds of object detection, okay, side by side, you also need to train your deep sort model. Deep sort model is already trained with bigger data set. So how it is happening, let me just show you one idea. Let's say you are using pedestrian data set. You are trying to detect the person. Let's say this is a person. You are trying to detect this particular object. This is a person. This is a person. Okay. Now this person data already trained with the deep sort model. Deep sort model, it is already trained with the person data. Okay. Now what is happening whenever you are detecting this particular object and sending to tracker algorithm, that is this deep sort algorithm, it is just measuring the correlation. Let's say this is the person. So deep sort is already trained with the person data. Okay. Now person plus person. Okay. If it is combined and measured the correlation, I think you know what is correlation, right? Now tell me, this correlation should be increased or decreased? Any idea, guys? Correlation should be increased or decreased? If you have done, I think, correlation inside machine learning, I think you know what is correlation, because this data and this data is matching. If it is matching, that means correlation is increasing. That means, let's say if I'm considering 0 to 1, that means it would be close to 0.9. That means 90% correlated. This is a person, this is also a person. That time what it will do, it will start tracking that particular person in that particular frame. Now let's say you are trying to detect the car. You are trying to detect the car from a frame, and you're sending this particular car in a deep sort algorithm. And let's say deep sort doesn't have this kinds of car image trained with that particular model. So at the time, what it will happen? So let's say the car is coming. Okay, car is coming, and inside deep sort you have nothing related car. Let's say inside deep sort only you have the person. Okay. Now car plus person, if you just measure the correlation, you will see it would be close to 0. That means 0.1 to 2%, like that. 10% correlation actually you will get. That time your deep sort won't be tracking this particular object present inside that particular frame. This is the complete idea for this particular deep sort. That's why they are telling here multi-object tracking deep sort data correlation problem. Okay, data correlation means it is trying to correlate that particular data. Okay, correlate that particular data. So this is the idea. Now how it is happening? They are using lots of things here. They're using Kalman filtering. Okay, Kalman filtering is a filtering technique to process the correlation of a frame by frame data. They're also using something called Hungarian algorithm for correlation measurements, and they're using CNN network for training and feature extraction. I think you know already what is CNN. Okay, convolutional neural network. We can use convolutional neural network to extract the feature from that particular image, right? So these are the three main things they are using inside deep sort algorithm. Okay, and this is the entire steps to perform the object tracking. Got it, guys? I hope this part is clear how these things are working, and I have given you the high level overview. This is the high level overview, right? But if you want to go inside mathematics, like how the things are working, how it is measuring the correlation, how this Hungarian algorithm Kalman filtering is working, you can feel free to open up any research paper of the Kalman filtering Hungarian algorithm or deep sort paper. You will get each and every idea, right? Now you can ask me where I will get the paper. No need to worry. There is a beautiful website actually you will get called paperwithcode.com. So if you just go to this particular website, and any kinds of paper, let's say if you're looking for, you can search here. Let's say I'm looking for the deep sort one. Deep sort. Okay, deep sort. Now deep sort is, I think, already there. Let me search. Okay, so it's not found. Just a minute. If you're not getting deep sort paper here, so we can directly search deep sort. Okay, deep sort research paper. Yeah, so object tracking with deep sort. See, directly you will also open the paper. You can also read it from here. Let me show you. See, I can open the PDF file. Now this is the paper. This is the research paper. It's taking some time. Let's wait. I think I can show you the paper. In between, if you have any query, guys, you can ask me. Any query about this particular deep sort and this object tracking, you can ask me. And we'll do the implementation as well. Implementation is very easy. We just need to connect the deep sort with YOLO V5, and easily we can do the tracking. See, guys, this is the deep sort one. The paper name is Simple Online and Real-Time Tracking with Deep Association Metric. Okay, now you can see this is the entire research paper. All the technique, all the equation, everything they are using, they have written inside this particular paper. Okay, there are some also detailed paper. There are also some blog actually website you will get. They have explained in a beautiful way with the help of visualization and all. You can also prefer that particular content. Okay, if you want to understand in depth, right? But I'm not going to show you that particular in-depth integration and all, because this is the hands-on series. We'll be more focusing on the practical implementation, right? So yes, guys, this is all about our deep sort introduction and introduction about our object tracking. Now what we have to do, guys, we have to do the implementation for this particular object tracking. Now how we can implement this particular object tracking? First of all, I have to clone one repository called deep sort. Okay, so you can search about this particular deep sort repository. So deep sort GitHub. Okay, deep sort GitHub. So deep sort having one GitHub actually. Let me show you. So I think this is the GitHub. Deep sort PyTorch. I think this is one. Yeah, so this is the GitHub, guys. So let me show you. I already completed this particular code part, like how we can. I'll show you how we can integrate, because here you don't need to write any code. Only you just need to clone the repository and you just need to keep it here. Okay, see what I have done. I already cloned this particular repository, as you can see, deep sort underscore PyTorch. Okay, as you can see, this particular repository I already cloned. This repository I already cloned. Then I removed some of the folders and file which is not required. As you can see, I only kept the necessary folders and file. Now you can open it up and you can try to understand what are the folders and file I have removed and what are the folders and file I have kept. Okay. Now if you open this particular deep sort folder, now inside that you will see one deep file. Okay, deep file, a deep folder. Now open this particular deep folder. Inside deep folder, you will see one checkpoint folder. Just open this particular checkpoint folder and you can see one model here called ckpt.t7. So this is the model of the deep sort model. As I already told you, deep sort has also its own model, right? This model has already trained with different data. Let's say car data, person data, okay, any kinds of data, it is already trained. Okay, so this is the model. You can also train this particular model. Maybe in future, I will also show you how we can train the deep sort model, right? But as of now, I'm using the pre-trained model. This model I have downloaded from the GitHub itself. If you open the GitHub, you will see the model zoo. From the model zoo itself, you can download this particular model called ckpt.t7. So you just need to keep this particular model inside checkpoint folder. Okay, I already kept. So only just you just need to change this one. If you are training your own model, you just need to keep your model here inside checkpoint folder and everything would be same. Okay, so this is the deep sort folder. Now what I have done, I cloned another repository called YOLO V5. Now you can open up the YOLO V5 one. So this is the deep sort repository, as you can see. Okay, you just search about deep sort PyTorch, you will get this particular repository. And see, this is the real-time tracker. Okay, now you also need to clone another repository called YOLO V5. I think I already showed you the YOLO V5. This is the official repo. You just need to clone this particular YOLO V5 repository. So see, here I have already cloned this particular repository. Okay, and some of the folders and file I have removed, which is not necessary. Okay, and I kept everything here. Now, as you can see, this is my repository, and with that, actually, I have also downloaded one model called YOLO V5s.pt. Okay, so this is the model I have downloaded. Let me go to the model view. It is having the model view, I think, here. This model actually I have downloaded. I'm using pre-trained model, guys. Okay, I'm not training my own model. I'm using pre-trained model. With the help of pre-trained model, I'm doing everything. So this model I have downloaded. If you just click here, it will start download that particular model. Okay, I downloaded this model. Then I kept here. Then I kept another video file because on top of this particular video, I want to perform the tracking. So let me open this particular video and let me show you. So this is the Pretrained video. I just downloaded from the internet. See guys, this is the video. So some pedestrian are moving on the road. So this video actually I will fill to my object tracking, object detection and object tracking, and it will start tracking this particular person, okay, on the road. See, this is the video I'll be using. So this is my input video. Here you can use live camera, you can use video, anything you can use, but I'm using video. But if you want to use live camera, I will also show you how to use live camera. Okay, that can be also done. See, now what I have to do here, first of all, I need to make a setup. I just need to make a setup. So how to make a setup properly? So let me show you. So if you want to make a setup, this particular project, I will share this code with you in the resources section. No need to worry. First of all, try to see how we can perform the setup operation. So here I've already given the step to perform the setup. So if you can open this particular command.txt. So here I have mentioned everything. So first of all, what you have to do in the README file I have written, first of all, you have to create one virtual environment with the help of Python 3.7. So let's create one virtual environment. So I'll open up my terminal here. So this is my terminal. Now let me create this particular environment. I'll copy this command. And here I'm going to execute. So name of the environment is tracking. Okay, I've kept it tracking. You can give any name. Okay, it is done. Now I'll activate this particular environment. I'll clear it. Now what I have to do, I have to follow the command.txt. Now let's open the command.txt. So first of all, I have to install the requirements. So inside YOLO V5, I am having the requirement.txt. So these are the requirement I have to install first of all. So let's install. I'll copy this command and I'll execute from my terminal. So kindly create a video on detecting and tracking objects level which is not present in the pre-trained model. For example, satellite image, etc. Yeah, in future, I will also show you how we can train our own deep sort model with our custom data. This can be also done. Shubashi. Okay, I'm getting an error. It is telling ignore the following version that returns uses the Python version. Python requires more than 3.8. Okay, so what I can do, guys, instead of Python 3.7, maybe I can use Python 3.8. Just a minute. I'll again copy and create another environment, but I'm going to name it as tracking 1 right now. Now let me activate. Now let me execute this command. Okay. So installation will take some time. After that, we can start the tracking part because everything we're doing on our local machine, so it will take some time. Hi Vapi, I really appreciate everything you bring to the community. Love you from the Vietnam. Yeah, thank you. Thank you, Nian. Thank you. So installation is going on right now. You can see. After that, we also need to install PyTorch. This specific version because when I like say train this particular model, at that time actually this is the version I was using for the PyTorch. So make sure whenever you are using your own model and the environment actually you are using, let's say the PyTorch version and Torch Vision version, you are using the same version here. Otherwise, it will create issue. I think today my connection is a little bit slow. That's why it's taking time. I think it could have done. So could you name some advanced object detection? These are advanced. Now, so far, whatever things we have used, these are advanced only. YOLO, Detectron 2, right? Then Deep Sort, Byte Track. So these are industry used, right? Okay, let me change my connection and see whether I got faster training or not. Just a minute. Yeah, now I think it's happening quickly. So initial installation takes some time. Once it is done, then next installation actually won't be taking that much of time. Yeah, so it's completed. Now I'll copy this command and I have to install the torch library here. I'll give yes. So it's around 157 MB. So let's wait. Once it is done, we can use it. So guys, if you're having any kinds of doubt in between, you can ask me. I will answer one by one. So what is the next step? Let me show you. See, once you install this one, now you also need to install this EasyDict library. Then this should be the command to run your application. So Python detect sort dot py, as you can see, detect underscore sort dot py. There is a file I created. So this is the file. Uh, this is the same file of your detect.py inside YOLO V5. I think I already showed you detect.py. I just copy pasted the same code from here inside this particular file. Only the modification you have to do here. Let me show you. Only you just need to add this div sort code. Apply classifier, process detection. After detection, you have to pass the detection to the div sort. Okay, so this is the modification you have to do. As you can see, update it sort. So the detection actually you are getting the x, y, w, is coordinates. Okay, confidence score and the image. You will need to pass inside div sort, and div sort will do automatically everything for you. So this is the modification you only need to do inside this particular code. Okay, and everything will remain same. Then you have to write this div sort dot increment edges, and everything is same. So you can compare these two file, and you can check it out what are the modification I have done in this particular code. All right, and this should be the final endpoint. So we'll be executing this particular endpoint. We'll provide the model location. So this is the model location YOLO V5s.pt. Image resolution 640. You can give with respect to your image resolution or video resolution, and source is equal to your video file. So this is the video file I want to uh, track. Okay, inside the video file I showed you, I am having the pedestrian object present. Now, if you want to open up your camera, real camera, so what you can do, you can give 0. Instead of pretrained.mb4 source is equal to, you need to provide 0. 0 means it will access up your camera. That's how you can do it. Then it will take this particular video, it will process the frame, it will track everything, and it will save again one video. That should be the result. Okay, it's completed. Now let's install this EasyDict. Now finally I can execute my final command, and now you will see it will load this particular video. It will detect, track everything, and it will again save my results. Let me show you. This is the final command. So first of all, it will count how many frame actually we are having in this particular video. All the frame it will process one by one. So if your video size is big, it will take time. If your video size is small, it will take less time. See my uh, tracking has started. Now see, frame wise it is taking. So we are having 967 frame. Okay, in this particular video. Now it is processing 28, 30, 31, 33, 34. So I have to wait till 967. So let's wait. Once it is done, it is saving everything in the runs folder. You can see runs folder, it is saving everything. So it will combine all the frame again in that particular video, and it will show me as the results. I'll tell you just a minute. Okay, I got one error here. So line number PyTorch dSort. This was deprecated. Allows the float, avoid the error. You could use float by itself. Doing is not modifying the Sessio. You wanted to numpy scalar. Yeah. Deprecated numpy to it is related to that. Okay. Okay, let me see the error. Actually, I'm getting here. Pip install numpy to work around it. Okay, so let me copy this command and execute. Okay, now let me try again. See, these kinds of error may come because continuously all the libraries changing, they're upgrading the functionality, they're making some function deprecated and all. So definitely you will face these kinds of difficulty. So all the solution are there over the internet. You just need to look for. See, I already got the solution. I installed that and now it is working. Okay, that's how you can debug your own code. And debugging is very much important because implementing projects is very easy, but you just need to fix the bug. That is the main thing. So I can mention this thing inside this particular command. So in future, if you're having issues, so you can refer it. So 280 frame is going on right now out of 967. Four hundred and 33, 4, 5, 6. Almost done. So let's wait. See, code wise, it's nothing. I only showed you now why I changed this. I changed here only inside detect underscore sort.py, and I copied the code from YOLO V5 folder only. So there is a file called detect.py. So this code you have to copy as it is, whatever code you are having, and only the modification you have to do after classifier. After classifier, you have to process the detection. Then after that, you can start with the deep sort part. Here, pass the detection to deep sort. Line number 171. Here would be your changes. That's why I told you open this two file together and you can see the changes I have done. Okay. And everything I'm using the GitHub repository code only, nothing else. So what is happening? It is first of all detecting. It is detecting the object detection. And this detection is passing where to the deep sort for the tracking. So here is the code for this. So pass the detection to deep sort. Okay. And deep sort is managing everything. It is applying this Kalman filtering, right? Hungarian algorithm and all. It is performing the correlation measurement. So on what basis you have chosen these? Didn't get your question, Vivashi. I mean output 04. What is it? Okay, this one. So you can print now. You can print the output. You will see that if you want to take the bounding box XY and XY coordinate, so it will come. This is the list slashing I'm doing now. List slicing. So if you print it inside this particular list, you will have so many value. But I only want the bounding box. So that's why I'm just slicing that particular out. Okay. So this is a like simple coding. So you just need to print this statement and you have to check it out. Okay, which one you have to take. Okay, 700. 200 more, guys. Just wait 200 more. Then I will show you that beautiful tracking part. and how many person it is detected, tracked, everything is showing here. You can see person. Almost done, guys. So now see, result has been saved. Now let me open the results and show you. So go to the runs folder, detect experiment 2, because I already did one experiment and that was failed. That's why it has created experiment 2. Now this is the results. Now open it up. See, guys. So beautifully, it has tracked my object. See, it has first of all detected. Now it will track. See, and how smooth it is. See how smooth it is. See, it's like really good. So this is called real-time tracking. Okay, now instead of video, what you can use camera. So if you want to use camera, in this command, you just only need to delete it and just write 0. Okay, 0 means it will access up your camera. So this thing you can try from your end, guys. I'm not going to show you the camera part. Yeah, so it is already 11. So let's end the session right now. And just try to practice with different, let's say, detection. You can do it. I've showed you everything. Now I'll share you the code in the resources section. Then after that, you can also make this setup in your system, right? So yes, guys, this is all about of our object tracking part. I hope you like this particular session. So if you have liked this particular session, so please subscribe to our channel and share this video with your friends and family so that they can get to know this kinds of community series is going on, right? Sir, can we use image also? See, image actually, why you will be applying tracking? Because image is a fixed, right? You can apply detection on top of the image, but tracking wise, you have to use videos or live camera, right? Yeah. So yes, guys. So thanks for joining the session. Thank you, everyone. Bye, everyone. Take care. Let's close the session and let's meet again, okay, with another session. Thank you, everyone. Bye. So today in this particular session, we'll be learning about generative adversarial network called GANs. I think you have heard of this particular GANs concept and all. But the thing is, like, here we'll be more focusing on the practical implementation of the GANs, like how we can use this particular GANs to solve different problem statement and all, right? Even I will also show you some advanced GAN application you can use. I'm not going to discuss the theoretical concept of the GANs. I will give the brief idea about the GANs, like how GANs exactly works. Then after that, I will focus on the practical implementation of the GANs, okay? But before starting with the session, what I will do, first of all, I will show you the previous materials of your classes. So where you will get all the resources and recording and everything. So for this, what you have to do, first of all, logging with our iNeuron website. Okay, so make sure you have logged in with our iNeuron website. And here, if you go to the community program, so here you will see my course called Computer Vision Hands-on. So just go to this particular course. Now here, I'll go to this particular course. And here you will see all the recordings, even all the materials has been updated here. So everything you will get from this particular dashboard itself. So make sure you have enrolled for this particular course, and this is completely free. Okay, you don't have to pay for anything. And guys, apart from that, if you want to upskill your technical, I mean the skill set, and also what you can do, you can visit our OneNeuron platform. So here actually you will get 200 plus online course. Okay, so different course actually will get, let's say you want to learn about, let's say, cloud platform. So all the cloud platform course actually will see here. So let me open it up and let me show you this particular platform. So let me log in with my account. Okay, so this is the OneNeuron platform. Now I will go inside that. Yeah. So you can also call it as TechNeuron. Okay, TechNeuron. So here if you see, we are having lots of courses here. Now let's say you want to learn cloud platform. Let's say any cloud you want to learn. Let's say you want to learn about AWS. Just search for AWS. See, you will see different AWS courses are available. So it is not specific to the AWS. Let's say you want to also master AWS SageMaker separately. So you will get the SageMaker course. Then quick site course, then interview preparation, then architect also. Okay, then data engineering, then big data analytics, okay, then glue, then redshift, everything is available. Now let's say you want to learn about GCP. Okay, so search for GCP. So GCP is also there. So GCP project, GCP interview, GCP machine learning certification. Let's say you want to learn about Azure. Okay, so if I search for Azure, see Microsoft Azure is also available. It's not only cloud platform. Let's say you want to learn about NLP. Okay, so NLP is also there. I think natural language processing. Yeah, so it is inside, I think, data science course. Yeah, so you can see we are having also full stack data science batch included in this particular platform. So you can also refer any kinds of, let's say, topic. Let's say you want to learn machine learning, you want to learn deep learning, you want to learn computer vision, everything is available here. So that's actually you have more than 200 plus courses are available. If you're interested, you can visit this particular platform and you can take the subscription of this particular platform. So you don't need to buy separate any kinds of course. Okay, after this one, and going forward, all the live classes is coming in the iNeuron website. Everything would be available inside TechNeuron platform. Okay, so this is one amazing platform you will see here. Now guys, let's start with our topic. So here I'm going to discuss something called GANs, that means generative adversarial network. So I'll be focusing on the practical implementation, as I already told you. So here I'm going to use two separate GAN. One is like SRGAN and there is like ESRGAN. So what is SRGAN? SRGAN is nothing but it's a super resolution GAN. What is super resolution GAN? I will tell you. And there is another variant of the ASR GAN called ESR GAN. ESR GAN means this is enhanced super resolution GAN. So this is like more advanced than your SR GAN. The output actually will get from the SR GAN. The more good output you will be getting from the ESR GAN. I'll show you like both of the practical. Then you will realize, okay, which one is the best for you. Okay. So here what I will do. Just a minute. Yeah. Sorry, I think some video has been played there. Yeah. So here what I'm going to show you, I'm going to take like lower resolution image, and that resolution image, with the help of GAN, actually, I'll try to improve the resolution of that particular image. Let's say here I've kept one example. Let's say you are having one very lower quality image. Okay, as you can see, this is like very lower resolution image. So after applying this particular ESR GAN and SR GAN, you will see your image will look like that. That means your resolution would be improved. Now what you can do, let's say you are having some older photo like of your family, which is not properly visible. You can use this particular ESR GAN and SR GAN to improve the quality of that particular image. Okay, so there are so many applications you will see over the internet. Let's say if you upload your image, it will automatically make the good resolution of that particular image. So they're using this particular GAN actually called SR GAN and ESR GAN. Now today I'll show you the practical implementation, how we can do this particular task, and after that you can improve any kinds of image quality, okay, with respect to the let's say SR GAN and ESR GAN, right? So this is the agenda for today. I hope this agenda is clear, guys, everyone. So anyone used like GAN before in any of the projects before? Anyone? So if not, I think this is going to be one amazing session for you. So you can utilize the GAN technology. And nowadays, actually, these GANs are like, frequently used things in the generative AI also. If you see lots of generative model are coming, right? It can also generate image. So how it is generating image? It is using GAN architecture in the backend. Okay, it is using diffusion model in the backend. With respect to that, it is generating new image for you. So let's say if you are giving any kinds of prompt, with respect to the prompt, it will generate that particular image. So they're using hybrid technology. They're integrating NLP as well as the computer vision, and they're creating this particular multi-model. Okay, and with the help of this particular multi-model, we are able to generate the text as well as the image. Even video generation also came, right? Currently, I think you saw that there was a model. It can generate videos, right? So you can also use GANs to generate the video as well. Okay, so everything can be possible. All right. So first of all, let me give you some idea about GANs, like what is exactly this GAN it is, and like how these GANs work. Actually, I will give you one high level overview. Then I will start with the practical implementation of the GANs. Fine. So just to explain the architecture, so what I will do, I'll take one sample architecture of the GANs. So this is the common architecture for all the GANs, okay? So this is the root architecture for all the GANs. I think this architecture is visible on my board. See, GANs is having two main component. One is this particular generator, okay? This generator. Just a minute. Generator. And another is like discriminator. So what happens actually, so see, GANs always try to generate something from the noise data. So let's say, first of all, you will input some of the noise data. Noise data means it can be any random data. It can be any kinds of number. Okay, we call it as noise data. And you have to provide as a latent space, okay, latent dimension. This particular dimension you will feed to the generator. And this generator is nothing but it's a convolutional neural network, CNN. Okay, it's a convolutional neural network. So what it will do actually, it will take the data and it will generate some fake sample. Okay, fake sample means it can generate anything. Okay, it can generate anything. Let's say you are feeding here noise data. So it is generating some fake sample. And what you want to do, you want to train a GAN. Okay, you want to train a GAN which will be able to generate cat image. Okay, cat image for you. Okay, it will only generate cat image for you. So what you have to do as a real sample, as you can see, we are also passing some real sample. So real sample wise, you have to give cat image here. Cat image here. Okay. So whatever image you want to generate from your GANs, you have to give that particular real sample here. Make sure you are giving the real sample as a label. Okay, label here. So what it will happen actually, it will generate some fake sample. This fake sample will go to the discriminator, and discriminator model is nothing but it's a classifier. Okay, it's a classifier. I think you know what is classified in image classification. It will take one image and it will classify whether this particular image is a like real or fake. Let's say you are classifying cat or dog. Okay, cat or dog. So what will happen actually, the image actually you are getting, okay, the image actually you are getting from the generator. Okay, first of all, it will try to match with the real image whether it's a cat or not, whether it's a cat or not. If it is cat or if it is a cat, that means it will tell yes. Okay, otherwise it will tell no. Okay, so initially you will see from the noise data it can't generate the cat image. So initially discriminator model will take that particular fake sample and it will also take the real sample. Okay, then it will classify. So it will classify as a fake. Okay, it's not a cat. So what will happen again, it will do the back propagation. Okay, that means it will update the weight in the both neural network. Okay, then after that what will happen again, it will take the noise data, it will generate something. Okay, again it will give to the discriminator will predict whether it's a cat image or not. Again it will tell it's a fake. Okay, that's how again this loop will again running. So when this loop will be closed, so once your generator can generate something like a cat image, okay, something like a cat image, that time it is also getting a cat from here, it is also getting a cat from here. That time actually this statement would be true. That means it is generating a real image for you. Okay, that time actually your discriminator model has trained. Okay, your generator model has trained. So what you will do, you will take this particular generator model that time. Okay, now if you give any kinds of data here, any kinds of noise data here, it will able to generate cat image for you. Okay, so that's how this particular GANs is working. Okay, so they are using two neural network together. One is like generator, and one is like discriminator model. Okay, so generator is nothing but it's a convolutional neural network. Discriminator is nothing but it's just a classifier. They are giving the noise data. From the noise data itself, your generator is generating something, that means the fake sample. This particular fake sample is coming to the discriminator. Discriminator is trying to classify whether this particular fake sample is close to our real sample or not. If it is real sample, that means your generator model has trained. If it is wrong sample, that means this particular generator model hasn't trained. Okay, you have to keep on training that particular architecture. Okay, again and again. That's why this training GANs actually is not easy. Okay, training GANs is not easy. So for this, you should have good configuration machine. Okay, first of all, you should have good configuration machine. Good configuration machine. Second, you should have lots of data. Okay, lots of data, and you should spend lots of time. Okay, even you also need money, right? So if you have these four things, actually you can easily train one GANs, okay, by yourself. So this is the root architecture inside any GAN. Now you can ask me how many GANs are available. There are so many GAN. There are thousands of GANs are available over the internet. Okay. Now let me show you some of the GAN architecture. So there is a repository called the GAN Zoo. If you just search over Google, the GAN Zoo, you will get this particular repository. Okay. In this particular repository, so what this guy has done, he has collected all the GANs. Okay. He has collected all the GANs with the research paper. Okay. With the research paper, and he has created one README file here. Now see here, we are having different GAN, 3D, ED GAN, 3D GAN. Then we are having, let's say, this ADA GAN. Okay. Now we are having this APD GAN. So different GAN. If you see, thousands of GANs are available. Thousands of GANs are available. Okay. Now let's say you want to export this particular GANs. Okay. So what you can do, you can open up the research paper directly. Okay. Research paper link is already given. You can open up the research paper and you can deep dive into this particular GAN architecture. Okay. Because they have done the tweaking of this particular architecture and they have created this particular different GAN. But this is the root architecture inside every GAN. Okay. Now see guys, this is the research paper of this particular GAN. Okay. Now see how these GANs are working, what is the equation they are using, how it is generating the image, everything they have mentioned in the research paper. Now today we are exploring the ESR GAN. That means SR GAN. You can also search about SR GAN here. So press Ctrl F and search for SR GAN. See guys, SR GAN is also available. Now let's open this particular research paper of the SR GAN. So this is the SR GAN. That means photorealistic single image super resolution using generative adversarial network. See guys, this is the research paper name. So these are the author and this is the introduction about the paper. Okay, so they are also telling if you have any raw resolution image with the help of SR GAN, you can improve the quality of the image. Okay, so see how they are doing and all, everything they have given in detail in this particular paper. So you can go ahead with this particular paper. So here I'm not going to discuss about the theoretical part of this particular GAN. I'm going to show you the practical implementation of the GAN, like how we can utilize this particular SR GAN in ESR GAN in our project implementation. Okay, so this is the paper. Now I'll show you the SR GAN and ESR GAN. What you can do, you can also explore any other GAN as well. Let's say you want to do some other task, you can like open this particular GAN and you can try to see what kinds of tasks actually you can perform with this particular GAN. Okay, so everything is available. So everything is available. You can refer this particular GitHub repository, and the repository name is the GAN Zoo. Okay, the GAN Zoo. You can search over Google. You will get this particular repository. Fine. Okay. Now what I will do, first of all, I will open up one Colab notebook. Just a minute. Yeah, so I can open up one Colab notebook. I'll take a new notebook. Now I'll just name it as SR GAN. Okay, SR GAN. And so if you're training the GAN at the time, you can select the runtime as GPU. Otherwise, you can also select as CPU. But let's take GPU because here I'm getting free GPU. Okay, I'll take the T4 GPU. Now let's connect the notebook. Okay, it is connected. Now, if you want to check, so you can execute this particular command called NVIDIA -SMI. Okay, that means everything is fine. Now, if you want to use SR GAN, first of all, you have to clone one GitHub repository. Okay, let me show you that particular repository. So this is the repository, and this repository is available inside my GitHub only. So I already cloned the official repo and I modified. Okay, I modified some of the things and I published in my repository. Okay, as you can see, this is inside my GitHub. Okay, this is my GitHub. Let me show you. This is my GitHub. Okay, so what you can do, you can fork it, you can start it. And now what I have to do, I have to clone this particular repo. Okay, I'll copy this particular link. I'll go to the Colab notebook, and here I'm going to write git clone. Okay, and I'm going to paste this particular link. Now let me clone this particular repo here. Now if I refresh, you'll see that I have cloned this particular repository. Now what I have to do, I have to go inside this particular folder. So I'll copy this folder name. Just a minute. How I can copy the name of the folder. Okay, I think I can copy the path, and here I can write cd, and I can mention it here. Now if I just write pwd, now you'll see I'm inside this particular folder. Okay. Now what you have to do, you just have to upgrade one package called scikit-learn image. Okay, so let's upgrade this particular package called scikit-learn image, because this is required whenever it will process that particular image. So it needs this particular scikit-learn library. Okay, scikit-learn scikit image library. So let me upgrade this particular package. So it's done. Now let me restart the runtimes because it is required. Restart the runtime. So restart session. Okay, now what I will do, again, I will execute this particular cell. Now what I have to do, I have to execute one command. Okay, as you can see left hand side, I'm having one file called main.py. So inside main.py, all the code is already written for you, like how it will load that particular model. Okay, how it will improve the quality of the image. Everything is available here. Okay, all the code is available here. So now what you have to do? Okay, so if you see here inside that, we are having one folder called model. So if I open this particular model folder, so by default, okay, so not a model, I think pretrained model folder. Yeah. So inside pretrained model folder, you can see I'm having two model. Okay, srgan.pt and srresnet.pt. So it is having two different model called srgan and srresnet. Okay, this is the two model actually it is having. Now you can use any of the model. So this is the nothing but the generator model. Okay, this is nothing but this particular generator model. So I have trained this particular generator model and they saved, okay, as a pt format because they're using PyTorch library. Okay, that's why this is the PyTorch implementation. That's why they're saving as a pt format. Okay, so what I will do, I'll utilize this particular model here called srgan. This particular model I'll be utilizing. You can also use this particular model, but I'm going to use this particular model. Now before that, what you have to do, in the test data folder, you have to keep your image, okay, like some lower resolution image. So let me show you. I'm having some lower resolution image, okay, with me. So let me just open it up. I'll just unzip this particular file. Yeah, so this two image actually I'm having. See, it is like very lower resolution. You can see it's like very lower resolution image, okay? And this is another image. So this is actually my image, my childhood image. So I was just trying the experiment whether it is able to improve the quality of the image or not. That's why I kept this particular image also. So this is my image. So I will be utilizing these two images and I will try to improve the quality of this particular image. So what I will do, I'll upload these two images inside a folder called test image. Okay, let's select and try to upload here inside the test folder. Now done. Now try to delete this particular readme file. It's not required. I'll try to delete this particular file. Now if I refresh, see, nothing is there. Now you just need to execute one command. So the command is just write Python. You have to execute the main.py. Okay, main.py. And first of all, you have to give the mode. Okay, what you want to do? You want to train the model or you want to test the model? So I want to test the model. So that's why I'll just write test only, test underscore only. That means I only want to do the inference out of my image. Okay. Then you need to give the lower resolution path image. So LR means lower resolution path image. So what is the lower resolution path? LR path inside test folder. Okay, as you can see inside test data, test underscore data. Inside that I'm having the image. Now here you have to provide the generation path. Okay, generation path, that means the generation model. So it is inside pretrained model. Okay, it is inside pretrained model. So here I will be just writing generation. Okay, generation generator path, generator underscore path. Okay, then here I just need to write pretrained model, and I'm going to use this particular model srgan.pt. I'll copy the path, and here I'm going to mention it. So I don't need this particular content, and this thing I can only take this particular path. I think it's fine. Yeah. Let me check. I think everything is fine. Generator, generator path. Yeah, everything is fine. Now let me execute and see whether it is able to generate my high resolution image or not. Now what it will save? It will save inside the result folder. Okay, see, by default result is empty. There is nothing. Now let me execute and show you. Okay, I got one error here inside test data. IP bind the checkpoint. So let me also delete this particular folder. Just a minute. Let me delete through the code. So here I can write AWT. Let me first of all go inside this particular folder. So I'll just write cd test data, test underscore data. Yeah, now I think I can remove it. Now if I refresh, yeah, so it is removed. Now I'll go back cd dot dot. Now see, I'm inside my super resolution GAN folder. Now I'll execute this particular file. So it will only look for the image. Okay, if you are having any kinds of file and folder, it won't be loading. Okay, it will give you error. Now see, execution is completed. Now inside result folder, you can see I'm having two output. Okay, so now let's open the first output. See guys, the quality of the image. Okay, initially this was the quality. This was the quality. Very lower quality, very lower resolution. Okay, and after applying this srgan, just see the quality of the image. Okay, you can also see my image also. Let me open the my image. I think this is my image. Okay, see, quality has been improved. Again, I took this particular like picture with my phone. The phone camera was not good, but again, still it is able to improve the quality of the image. Okay, it is better than previous quality. What do you feel like, guys? Let me know. Now you can open up your album, and you can see if you are having any kinds of lower resolution image there which is not properly visible, you can apply this particular srgan on top of it. Okay, and you can improve the quality of the image, right? So you don't need to take the help from Photoshop right now. Great guys. So yeah, so this is the srgan. But if you see, still this srgan output is not good. Okay, sometimes actually we'll see that it is not getting proper, let's say, resolution. Okay, sometimes you will see the it is not a good resolution. So if you want to like get a very improvement resolution at the time, what you can use something called ESR-GAN. Okay, that means enhanced super resolution GAN. So this is the same variant of the SR-GAN, but they have created another architecture. They name it as enhanced super resolution GAN. Okay, and this is better than your SR-GAN. Now let's explore how we can utilize this particular ESR-GAN right now. Okay, yeah. So for this, what I will show you, I already have one notebook with me. I already prepared for you. Let me show you. ESR-GAN. So this one, I'll share all the material with you, so you don't no need to worry about. And this is the Google Drive I also created. Okay, since at Google Drive, what I have created one notebook called ESR-GAN. Okay, this is the notebook I created. So let me connect this particular notebook. And I'm going to save everything inside my Google Drive. So that's why I just need to mount my Google Drive first of all. Okay. Okay, still it is connecting. Just a minute. Let me check. Let's take T4 GPU. Okay, and see. Okay, now it is connected. Now, first of all, see, I have mounted my Google Drive. Okay, if you want to mount the Google Drive, just click on this particular button. It will automatically mount. Now, whatever things actually I'm having inside my Google Drive, I can access everything. See, so I'll go to this particular folder location, and this is my location. So make sure you are going inside your location. So first of all, let me redirect to my location. Okay, and then if I do PWD, we'll see I'm inside my location. Okay. Now see, here I have to clone one repository. Okay, so this is the repository I have to clone called ESR-GAN. So this is the official repo. You have to clone it. This is the repository, okay, of ESR-GAN. Now it is having lots of model. Let me also show you the model. Model detail, Google Drive. Download the pre-trained model. Yeah, so this is the Google Drive. And here you are having lots of model. Okay, so here I'm going to use one particular model. Okay, it is having 4 different model. Now I already cloned this particular repo. If I show you, I already cloned this particular repo ESR-GAN inside my Google Drive. Okay, so this is the repository I already cloned. So I'm not going to clone it. So you can execute this particular command and it will automatically clone for you. Okay, then after that you have to relocate the folder. That means you have to go inside the ESRGAN folder. Okay. Now inside that, you have to execute this particular file called test.py. But before executing the test.py, what you have to do, you have to download one model. Let me show you. Inside ESRGAN, you are having one folder called model. Go to the model. Okay. And download one model here from the Google Drive I have showed you. Okay. From the model too. Now here I'm using this particular model called RRDB ESRGAN X4PT. DB ESRGAN X. See, I'm using this particular model. So just try to download this particular model. It is 63 MB around. Then you just need to keep inside this particular folder. Okay. I already downloaded and kept it. And you also need to keep your lower resolution image. Okay. Inside LR folder. So inside LR folder, if you see, I'm having three different lower resolution images. Okay. So one is like this one, another is like this one. Okay. And my image. So these three images I kept. Now what I will do, I'll execute this particular command and you will see the magic. Okay. Now let me execute test.py. It will save everything in the result folder. Done. Now if I open the result folder, you will see the result. Now let me open it up and see the resolution. See guys, see the resolution. No, here I'm not going to explain the architecture, Bala, because this is a hands-on session. Maybe in future we can discuss about the architecture, okay, in a theoretical discussion. Now see guys, this is the resolution. Now tell me which one is looks good, your SRGAN or ESRGAN? What do you feel like? Which one like looks more good? Let me know. ESRGAN is better because if you see the resolution, it's like pretty good. See, pretty good resolution. Okay. Yeah. So now you can try with different image and different model. Here is the model I already showed you. It is available inside this particular Google Drive link, and you can read this particular description and all. Everything you can read it out. And if you want to explore any other like GAN model, you can refer this particular the GANZoo repository. Okay. Yeah. Now, if you are having any query, guys, you can ask me, because this is what I just wanted to show you. So there are so many GANs model are available. It's not possible to show everything. So I just given you the idea. Now you can refer this particular link and you can try by yourself. Okay. Just open in a Google Colab and you can execute everything. It's possible. Now let me show you some real-time GAN example, GAN application. I think you have used something called OpenAI, right? Let me open up my OpenAI. First of all, let me see my account is there or not. Yeah. So inside OpenAI, maybe you have heard of something called DALI API, right? If I show you the API, it is having one API called DALI API. GPT model. Yeah, so DALI API is available. Learn about DALI. Image generation. See. So if you are giving any kinds of prompt, let's say an astronaut riding a horse in a photorealistic style. Okay, and this is the output. How it is generating this particular image. Okay, they're using something called GAN in the backend. Okay, this kinds of generation model they're using. Okay, I already showed you. It is having two component, generator and discriminator. They have already trained with huge amount of data and huge amount of prompt. Okay, based on that, it's generating the image. So this is one real world application of this particular GAN. Apart from that, I think you have heard of something called Gemini. Okay, Gemini Pro, Gemini model. Okay, Gemini Pro model. So this is also using GANs. Okay, in the backend diffusion model it is using, because it can also generate. It can also work with the image. Okay, image data. So it is also using GANs. Do we need to learn Mozo? As of now, not required. Fine. Yeah, apart from that, some video generator software are there. Currently, I think one tool has come for the video generator. I think you saw that. Do you remember the name? Anyone? It can generate realistic video for you. Soda, yeah, you are correct. It is the Soda model. Okay, Soda, OpenAI. This is the Soda. So it is also utilizing GRAN, creating video from text. Okay, if you give any kinds of text, it will generate the video for you. See, this is the some example you can see here. If I play this particular video, see the like realistic of the video. Okay, yeah. So deepfake are also using GANs. Okay, yeah. See the image, guys. Okay, it's great. So they are working on video level. See, this is another example of Soda. Okay, so that's how you can generate any kinds of video and image. Okay, with the help of this particular prompt. And the internal mechanism is this is the base mechanism they're using. On top of that, they have created lots of hybrid architecture, okay, with different layers and all. Yeah. So yes, guys, this is all about like of this particular session. I hope you like this particular session. If you liked it, so please subscribe to our channel and refer this playlist with your friends and family. And again, I already showed you this particular platform called OneNeuron. So if you are interested in OneNeuron, so you can visit this particular platform. Okay. So here you will get all kinds of courses. If you are interested learning different courses, let's say you are not familiar with generative AI. So generative AI is already available inside this particular OneNeuron. Let me show you. So TechNeuron. So let's say you are interested generative AI. Okay. So just search for generative AI. See, generative AI is available. Okay. All the live batch is already available here. Any kinds of tools and technology you can learn from this TechNeuron platform. Okay. So you can visit this particular platform. All the details are given in the website itself. Okay. Everything is available. So yes, guys, this is all about from today's session. I hope you like this particular session. So let's end this particular session with that, guys. Thank you so much for joining the session and take care, everyone. Bye. Thank you.